forget subscribing and click the thumbs down. I'd hate me also if I had a fuck to give. So thanks for giving one. Not gonna get one from me. Anyways, I'm gonna add another tick to my unconventional prison style countdown. Something is wrong with the sound. I just started the stream. I don't want to restart. It's like really delayed. I'm just gonna have to talk without hearing myself talk. I hate this software. This software sucks. So assuming that you can hear what I'm saying because I'm not listening to myself talk because it's like really delayed. I think everything's working aside from whatever's up with audio. I'm writing a JavaScript engine. I'm gonna meet the 2002 standard first because it's 200 pages. It's easier to meet. Then I'm gonna meet the 2024 standard because it's 800 pages. So I'll meet the smaller standard first, the older one. I'll meet the newer standard so I can get the rest of the mechanisms because I have a majority of the mechanisms, but not loop, function scope, block scope. I don't know. There's like little things I need to have the full engine. And yesterday, I tried to install GCC. But it needs like an offline installer. I mean, an online installer. I can't find an offline installer, one that works, whatever. So I'm not going to bother until I do a new Windows install. But I almost got an ASM assembly for x86-64 running with Visual Studio, linking and stuff. So I want to try to write some assembly and speed test it. So first I gotta like just get whatever to print to the council. So chatbot was like half helpful. It wasn't totally helpful. It keeps giving bad code. It can't write assembly. It literally can't because it's crap. Chatbot is garbage. But getting like the highest bit set, I have like an assembly trick, whatever that I want to try to compute the highest bit set. For 64-bit, a lot of people are using division by magic number to get like the highest bit set in a 64-bit number. And I kind of figured out a clever trick, but it ends up being like 2% slower, like a teensy bit slower than dividing. So I wanted to like write it out in assembly and compare it to the compiler to see if I handwrite the trick to get the highest bit set in a value whatever. If when handwritten in assembly, if that's gonna be faster than the compiler, what the compiler does, whatever. Because like the timing is like so close, and it should, the trick that I have, whatever, should be like a teeny bit faster than the division, whatever. So I don't know. That's like my goal for the next couple hours. Just to get some assembly running. I want to like, we're on a test loop. I want to like, I guess explain my like, get the highest bit set trick. Because I haven't found anywhere else where people are using the same technique to get the highest bit set. I'm gonna Google really quick to make sure, because I don't want to say that I figure something out or I do something that somebody else already claimed. But then there's like only so many possible ways to do something. So I don't know. Somebody else maybe have figured whatever out. It's really hard to like figure out something that nobody else hasn't already figured out. And when you do figure something out, you can't just tell people because then everybody knows and they'll take your idea. And then it means nothing to know something that everyone else knows. I don't know. Well, I do know. But yeah. So I'll ask, blah, blah, blah. I'll ask chatbot. I have to put headphones in and hear myself talk. Maybe the sound's fixed. I don't know. I can't not hear myself talk. I don't know how fast I'm talking. I'm gonna ask chatbot how to get the highest bit set in a 64-bit number and see what chatbot says. I think the sound's working. And the bitrate was failing, but now it's working, so I think the stream's working. Okay, so overall, I got real close to getting assembly to run in Visual Studio, whatever. I started up the computer and all my tabs are messed up. I have to like reorganize everything again. But aside from that, once I get everything organized again, I'm gonna write some assembly. I'm gonna do like a speed test loop and then compare it against whatever the fastest get the highest bit routine is or whatever, or instruction if it's not a full routine. A routine is like a collection of instructions that do something. Kind of like a function, but there's no, I guess a routine could be a function, it doesn't matter. So I don't know. I'm gonna ask chatbot the fastest way to get the highest bit set, see what it says. I'm gonna write some assembly, I'm gonna speed test it, and I'm gonna get back to like parsing my JavaScript engine and converting it from 32-bit to 64-bit. That's what I have to get back to, but I started this yesterday, and I want to like continue off it and try to get some progress because I almost got stuff working. So I'm gonna ask chatbot, see what it says, or whatever. I'm gonna try to figure out if other people are using the trick that I figured out, whatever, to get the highest bit set or not, and then I'll just like explain how it works. Because I got a lot, I don't know. There's like tons of tricks or whatever. I have more clever things. It's not the most clever. It is kind of clever. I already like explained it before on stream a couple times on like Twitch. So like, I don't know. People on Twitch, I don't know. They're more like C programmers or C sharp, not really assembly language. They don't really give a shit. Because people do like assembly streams on Twitch. I don't know, whatever. So I'm just gonna like explain it again on YouTube. The bit trick, whatever, to get the highest bits. So I'm gonna ask chatbot, do everything I just said. I'm just stalling. I'm tired. So I'm gonna stop stalling and get something done. Okay, I'm gonna ask chatbot. If the mouse will switch, it's not switching. Did they add this to chatbot yesterday? Yesterday I didn't have this pop up. Now they have like a little pop up here. It's kind of fancy. I was gonna word it as get the highest bit set, but then chatbot might confuse it. It's like setting a bit, so I don't know. I think this is the way to word the question. I don't know. I guess I'll find out. Just have to ask it again and again.
What's the fastest way to get the highest bit position that's on in a 64-bit number that works on x86-64? What's the fastest way to get the highest bit position that's on in a 64-bit number that works on x86-64? The fastest way to find the highest bit set, most significant bit set, in a 64-bit number on x86-64 is to use the BSR, bit scan reverse instruction, which is available on all x86-64 processors.
I was testing on a C language, so like Visual Studio doesn't have inline assembly anymore. So like people use a division trick by a magic number to get the highest bit set, or some people, I don't know, there's different tricks, whatever. So I haven't tried this instruction. So this instruction might be faster than whatever I was gonna say because it's built in as an instruction. So I don't know. So I'll test this too, whatever. And if this is faster than the division trick by a magic number or by doing whatever I'm gonna try to like test in speed loop to get the bit, then the compiler should have this instruction at C level because it'd be very useful. But I doubt, like C has intrinsics and stuff. I don't know. Everything is more complicated than it needs to fucking be. And modern software sucks. You don't have access, easy access to like low level things. And it's hard to do high level things when you can't even access low level things. I don't know. I'm just gonna test a bunch of stuff to see what's fastest. But this might actually end up being fastest because it's like an instruction. But some instructions are kind of slow. So I don't know until I test it. I would assume that this is gonna end up being the fastest way to get bits up, though. But if you're programming in C, you don't have direct access to this instruction. So I don't know. Everything's complicated.
Scans the bits of the value from most significant to least significant.
I like how it says scans the bit. What do you mean scan? Do you mean loop? I'm pretty sure it's a loop, right? What the hell is scanning? So like, I'm gonna try Sandtrack. I'm gonna ask chatbot this in a second. Because context is everything. And using the word scan when they, I don't know, just say loop. I don't know why they would explain it as scan.
Returns the index of the highest set bit, 1. Only defined if the input is non-zero. Computer, example in C with GCC clang, using intrinsics.
Yeah, see intrinsics, whatever. But, oh, I guess MSVC supports it? I doubt it. I don't know. I don't know. I tried to do this a year ago. I didn't see this intrinsic. Whatever. Half the time, chatbot's gonna say, oh, it does that. It does this. And then it's like, it doesn't fucking do any of what chatbot says. And it's like, what the hell? Wasted all my time. So maybe this is a waste of time. I guess I'll try it in a little bit. Because it says MSVC has it. So I'll see if it actually does have it or not. And then I'll ask chatbot if it lied, and chatbot would be like, they'd say, I didn't lie. It's all in context. Okay. It's already freaking. Chatbot is full of shit. It says the instruction counts the number of leading zeros. Which means if the value isn't just that, if the value doesn't have, if the value has more than a single bit set, the instruction might not do what it says. Chatbot didn't even answer my question. Chatbot is stupid as fuck. How do you spell mechanism? There's no Z. I think that's the spelling. So I'm gonna ask chatbot, what does scanning mean? Because that makes no sense. It's called a loop. So I don't know. It seems like misleading wording, so I want to see what chatbot says.
What does this mean? Scans the bits of the value from most significant to least significant. What mechanism of the CPU scans what exactly is scanning? Great question. Let's unpack what it really means when we say an instruction like BS scans the bits of the value from most significant to least significant. Brain. What scanning means in this context. When we say scan in the context of CPU instructions like BSR, bit scan reverse, we're using a metaphor. It does not literally mean the CPU walks through each bit one by one like a loop would. It's just an abstraction for what the instruction logically does.
So they said a loop. So it means that CPU doesn't logically walk through each bit one by one like a loop. It's an abstraction for what it logically does, which is basically a loop.
Scanning equals determining the position of a particular bit set to 1. The BSR instruction finds the highest index where the bit is set. That is, the leftmost bit that is 1 in the binary representation.
All right, I'm not gonna waste time getting technical with chatbot. So I'm gonna ask chatbot,
But you said Boolton CLZLL X counts the number of leading zeros. Is that the same thing as getting the highest bit that is set?
so I'm gonna ask chatbot that and see what it says, and I'm gonna try to get some assembly running. I have to find the magic division, or division by magic number. We're getting the highest bit set too. I don't know, I'm gonna try to get started in assembly in a second, and I'll find that in a minute. I shouldn't waste all my time arguing with chatbot.
You're absolutely correct to seek clarification. Let's delve into the distinction between Boolton CLZLL X and the BSR bit scan reverse instruction, especially in the context of determining the position of the highest set bit in a 64-bit number. Brain. Understanding Boolton CLZLL X. The function Boolton CLZLL X in GCC and Clang counts the number of leading zeros in the binary representation of X specifically. Input, a 64-bit unsigned integer X. Output, the number of leading zeros before the first 1 bit from the most significant bit, MSB.
It says before the first 1 bit from the most. Oh, it's not saying there's multiple significant bits. It's saying that the first bit that's on from the top bit.
For example, x equals 0 times 8 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 binary 100,000 0 0 0 Boolton CLZLL x returns 0 because there's no leading 0. X equals 0 times 4 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 binary 0 1 0 0 0 0 0 0 0 Boolton CLZLL x returns 1 because there's one leading 0 before the first 1 bit.
It's not even the same thing as a bit count. What the fuck? Oh my god, chatbot is so fucking stupid. Stupido. Stupido. How is it so stupido?
To find the position of the highest set bit, you can compute position equals 63, Boolton CLZLL x. This works because Boolton CLZLL x gives the number of leading zeros, and subtracting this from 63, the highest bit position in a 64-bit number, yields the position of the highest set bit.
Okay, so I guess technically it is the same thing if you convert it. But they're two different things. One does one thing, the other does the other. Because the BSR instruction returns the bit, and chatbot's saying to use for C is intrinsic, and it counts up the bits, which is 13, but when you do 63 minus 13, you do get 50. Except you can't do it if it's the number 0. If the number is 0, what does it return?
What if it's 0? What's the result? Great question. This is a special case that's important to handle. Crossmark what happens if the input is 0, jigsaw piece. BSR instruction bit scan reverse. If the input is 0,
Is it division?
SR is undefined. Some CPUs may leave the out.
Are you kidding me?
Others may set it to garbage. It's your responsibility as a programmer to check
This
input is 0 before calling BSR.
sounds like a bullshit instruction. BSR sounds like division hidden as an instruction called bit set reverse or scan or whatever the fuck it's called.
Jigsaw piece. Bulletin CLZLL 0. GCC clang. If the input is 0, the behavior of Bulletin CLZLL 0 is undefined according to the GCC clang documentation. In practice, some compilers may return 64, but you cannot rely on this. Is it actually a division behind the scenes Picasso 0 is handles the same way? This is a very insightful question. You're noticing that some CPU instructions and functions, like BSR and division, both have undefined behavior when the input is 0, and you're wondering if that's because they work the same way behind the scenes. Maybe one is implemented using the other. The short answer is no. BSR and Bulletin CLZLL, or similar bitwise operations, are not implemented using division behind the scenes.
Let's see about that.
Fundamentally different operations. They just happen to share the similarity that 0 is an invalid input in both cases. Let me explain why.
I'll open up the instruction table timings. I'm gonna look for bit scan reverse. Here we go. It is an instruction. So wow, that looks, is that the throughput? Or, oh, the UOPs, the latencies on the right. These tables, like, they flip around. That's a whole lot of UOPs. But I don't know. I'm gonna look at what's the latency. It has a latency of 10. It has a UOPs of 10. In the rightmost column is reciprocal throughput. Oh, throughput is at 10 too. That's also 10. So we got a 10, a 10, and a 10. This instruction seems extremely, very fucking slow. This seems like a very slow instruction. I'm gonna look for division and see if it's 10, 10, 10, or if it's close to that. And then I'll be able to assume if it's actually division or not. Oh, that's odd. Let's look at that. A division takes 9 UOPs when it's a register and it's a memory 8. If it's a memory 16, it takes 12. And if it's a 32, it takes 12. 64, it takes 23. It just says register memory. Does that mean it's by default 64-bit? It is faster, possibly, than division. I don't know. It seems very slow. There must be a lot of logic going on behind the scenes. They might be doing division by a constant number. I don't know. I didn't design this CPU. These CPUs, I don't know what CPU this is. Silver mount? I don't know. They're all gonna have different timings. But multiplication seems to be a hell of a lot faster than division. And this seems like there's some kind of division going on, or a loop internally. I don't know. It doesn't really matter. It's an instruction.
Leading zero detection circuits.
Okay, so it might not be division. It might be like a bit operation that's... Okay, it might not be division. But it's still slower, the multiplication. Okay, so chatbot says BSR. I'm gonna ask chatbot division by a magic number to get the highest bit set. And then I'm gonna get some assembly running. And I'll compare, I guess, these three tricks or whatever. I'll be able to do the BSR instruction in assembly. And then I can like look up the i7, the first gen i7, because that's this computer, whatever, here. And I can get like some accurate instruction timings. I don't know, that seems pretty accurate. I've used it before. That's why I'm using this computer again. Why I'm using Potato. It's a Potato computer. So I'll be able to run the BSR instruction, whatever, in assembly, because I'm running it NAS and whatever, and then I'll run like my big count trick or whatever too, and then I'll run in C, I guess. I'll run this in C, Visual Studio, compile whatever. I guess I'll have to make an exe to get more realistic timing, not leave it in debug mode. I'll just make the executable. I'll test this too. And I'll test my bit trick that I'm going to do. I'll explain it in a bit. I'll test that in C, because in C, I was like, why the hell is it so slow? It should be faster. So I can compare what the compiler generates in C versus what I can handwrite in assembly now. I still have to find a demo that works to log to the console, because it looks like it's linking and the assembly is working, or it's at least being passed in to be run, but it's not printing to the console. So I gotta figure that out and I'm good. So I'm gonna ask chatbot how to get the highest bit set using division by a magic number. And I'm trying to think ahead. Yeah.
People have been getting the highest bit set using division by a magic number in C. Output that technique. You're absolutely right. There's a clever trick using multiplication by a magic number to find the highest set bit in a 32-bit or 64-bit integer. This is not literal division, but uses floating point representation to exploit how CPUs store integers in IEE. Let me show you the technique and explain how it works. Wizard with a pointed hat and staff. Trick. Use double conversion to extract the highest set bit. This technique takes advantage of how floating point numbers store the exponent. For a 64-bit INT64T, here's the code. Int highest bit position magic, INT64TX. If x equals 0, return -1. Double dx equals double x int exp, frexp, dx, and dxp. Extract exponent, return exp1, exponent gives position +1.
Okay, so I said,
Division.
and then chatbot said,
Multiplication.
and then instead of using division or multiplication, they explain.
Double conversion.
Which might be faster than both. So I didn't know. I didn't think that this is like a whole new way to do this. I don't know if it's valid, and I gotta test it. Alright, so I'm gonna look up the division trick by magic number in a second. And I guess I'll try this too. I'm just gonna try a whole bunch of shit. Speed test stuff, and I gotta stop wasting time speed testing stuff. But it's not really wasting time because I'm gonna have to write assembly at some point. I don't know. I have to like get back in the motion. I still have to like convert the C program. At some point, I'm gonna have to write stuff in assembly. The C program, the C compiler, it sucks. I'm not gonna get the performance boost I need, at least in like certain spots of the code. So I'm gonna ask chatbot to open a new tab so I don't lose all this stuff.
output a demo tutorial snippet of NASM x86-64 ASM that makes the data BJ to link to Visual Studio command line and run to log to the console. Simply a letter or the text hello world. Provide an example from a real source. You always give bad ASM code. That does not ever work.
ASM stands for assembly.
Certainly. Here's a working example of a hello.
I hope this works.
x86-64 assembly for Windows, using the Windows API to output to the console. This example is designed to be assembled and linked using Visual Studio's command line tools. Blue textbook. Notes. This example uses getStd handle to obtain the standard output handle. Std output handle. Write consolia to write the message to the console, and exit process to exit the program. The program is 64-bit and utilizes the Windows API directly, without relying on the C runtime library. Ensure that your Visual Studio environment is properly set up with the necessary libraries and tools to assemble and link 64-bit applications.
I put a soda pop in the freezer. I think it might explode. One second. One more second. It sounds like it's like half frozen, so I don't know if I should risk opening the soda pop right here. I'm just gonna risk opening it. I hope it doesn't explode. I have a bad feeling though. This would be pop everywhere. I don't want warm pop. I'm gonna risk it. Please don't explode. Oh, I'm good. It didn't explode. Okay, back to simply.
Doesn't it need bit 64? And does it need default rel? And does this use full addressing and stuff for a truly 64-bit ASM to run on Win 11?
I don't know. I'll ask it to like do addressing after. I'll just get this run first, I guess.
Great follow-up. You're absolutely right to focus on 64-bit correctness for Windows 11, especially when writing NASM code targeting Win64 lets address your questions point by point for true x86-64 NASM on Windows 10/11 using the Visual Studio toolchain. Tick. Should you use bit 64? Yes. You should absolutely use NASM copy edit bit 64 at the top of your NASM file. It tells NASM explicitly to emit 64-bit machine code. Even though fwin64 implies it, being explicit is best practice. Tick. Should you use default rel? Yes. It's a very good idea to include NASM copy edit default rel. This directive tells NASM to generate RIP relative addressing by default for memory operands, which is required for position-independent code in 64-bit Windows. Without it, you'll often get linker or runtime issues. Windows x64 requires RIP relative addressing for accessing global variables or static data sections unless you're using full absolute addressing, which is less common and often unnecessary.
Can I get full absolute addressing? That'd be nice. I'm gonna ask chatbot to like keep the console open because I think it'll close when it's complete. I'm gonna ask it about full addressing or whatever. And I'm actually gonna copy paste and try to get something done. I'm gonna tell chatbot to make a check for the letter Y before closing the console, because the console might just be closing automatically after it prints it or not. So I don't know. Ask chatbot to account for this too.
Does the console close when complete? Make the console wait until the letter Y is pressed before it closes the console. Yes. When you run the program by double-clicking Hello Eggs from the Windows File Explorer, the console will indeed close immediately after execution finishes, unless the program waits for user input to fix that. You can make your assembly code wait until the user presses the letter Y before exiting. Tick. Modified NASM code. Wait for Y key. This version uses read consolia to read a single character from standard input and only exits when the character is Y. NASM copy edit.
So I'm gonna try that code it just gave me in a second. I also want to ask this or whatever.
Which is slightly more performant? RIP relative addressing or full absolute addressing? When considering RIP relative addressing versus full absolute addressing, the performance difference is generally negligible in most modern architectures, including x86-64, 64-bit mode, on Windows. However, there are some important distinctions regarding how each addressing mode works, and their performance implications in certain contexts. Let's break it down. 1. RIP relative addressing. RIP relative addressing is a technique where addresses are specified relative to the current instruction pointer, RIP. This type of addressing is essential for position-independent code, PIC, and is used heavily in modern 64-bit systems, especially in dynamic linking, shared libraries, DLLs, position-independent executables, PIs, security features like ASLR. Address space layout randomization. Two. Full absolute addressing. Full absolute addressing directly uses a hard-coded address. For example, MOVRAX 0 times 12,345,678, which is typically used for fixed memory locations. It can be beneficial in situations where the address is constant and known at compile time, such as accessing a specific memory map IO or static variable. Advantages of full absolute addressing. Direct access. Since the address is known, it can be faster to resolve the memory access because the CPU simply uses the fixed address without any need for adding offsets. Predictability. In certain cases, like static data access, absolute addressing is more straightforward and can be perceived as simpler.
This would be nice.
Cache locality. If you're using a constant address that is well cacheable and used repeatedly, the performance could be slightly better because the CPU doesn't need to perform any dynamic offset calculation.
So it didn't answer my question at all. It said they're both great. So they're both great. So I don't care, whatever. I'm going to copy paste the code it gave me, try to build it, and pray to God it works. Because that wait took so long yesterday. I don't know. It keeps giving bad code. I have to like shuffle around some folders. 1 second. And I'm gonna copy paste it in the first attempt out of however many attempts it's gonna take. Because I doubt it's gonna work until like several more attempts with Jetbot. paste it on this computer. Why does Windows keep doing this? Was I not even using the full file path? Oh no, it was. Oh, you navigate to the file path first, and then you run the script. So this is right. Dang it, I want whatever. So I got a CD to get to the directory. I think that's what it was on whatever I did yesterday. Open this, then CD. Because Windows runs off of DOS, which was stolen from Gary Goodall. I guess stolen is in context. It's not even Windows. So CD, file path. Actually, I hit Command C because I'm used to the Mac. It's pasted, then enter. It's in the folder. I copy the link. ASM, blah, 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 blah. Whatever from yesterday. Assuming it's correct, I might have to change it. I'll check what chatbot says. Because it might have changed its answer for whatever it just gave me. Paste. I gotta run assembler. I have to navigate to the folder, I guess. Or no. I wonder if it still doesn't remember from last time. I think it was this one. So I'll paste this into an ASM. I think built. Oh, I gotta put the new file path or the folder file name. So these are the files, whatever. So I build, it should make another file. Go over to here, paste, then enter. It didn't throw an error, and it built something. So now, to the command prompt, I already pasted it, so enter. And what the fuck? Okay, no, that's correct. I have to pick whatever the latest command was. I'm gonna paste it. I also want to check though. Dang it. Is that the right whatever? Okay, so in the file directory where it has the kernel 32, that's called, what was this? I think it was user mode. That's what Chapa said. It meant user mode privilege or something. x64 inside of this folder is kernel 32. Kernel 32 library. So inside of the folder x64 is kernel 32 and user 32 somewhere in here. I guess, I don't know, whatever. So 32-bit, I don't know, 32 means 32-bit. But also, inside this folder is x64 and x86 and ARM64 and ARM. So this is 32-bit, 64-bit, 64-bit, 32-bit. So they're separating things by architecture, whatever. So inside x86, is kernel 32. So inside of the 32-bit x86 folder is kernel 32. And inside of the 64-bit folder is kernel 32, which means 32-bit, but they're different kernels. So inside of the 64-bit folder, because clearly things are divided by CPU architecture, is kernel 32 and kernel 32. Why didn't they rename it to kernel 64? I'm gonna ask chatbot in a second, because it seems kind of goofy to call it kernel 32. It's clearly for x64. Go through all that work of making a separate folder, even for ARM and ARM64, but then call it 32-bit. That's just ridiculous. So I'm gonna run, link it, whatever. It looks like linked. Name. I'm gonna name it a different name. So there's these, blah, blah, blah. There's these files, whatever. I'm gonna paste and run it. And built. So here's the executable. Double click. And it doesn't fucking work. Fuck. This is so frustrating. Chatbot sucks. For fuck's sake. I think I'm gonna try without chatbot. Because I can't take it. I'm gonna lose it. Pisses me the fuck off. Wastes so much time. It's like, chatbot will be like, oh, here's the corrected version. Here's the corrected version. Oh, I see. Here's the corrected version. Here's the corrected version. Oh, I revised it. Here's the corrected. None of it fucking works. I'm going to go to Google. I think this might actually work. So, I don't know. I'll have Siri text to speech, the ECMA JavaScript standard, whatever. I got LBRB. I'm gonna like try to get stuff to assemble, whatever, and then do like the test stuff and stuff, whatever. I need some water. I can't even talk.
By algorithms within this specification. Hence, when the terms lexical environment and variable environment are used without qualification, they are in reference to those components of the running execution context. An execution context is purely a specification mechanism and need not correspond to any particular artifact of an ECMAScript implementation. It is impossible for ECMAScript code to directly access or observe an execution context. 4.1 Get active script or module. The abstract operation get active script or module takes no arguments and returns a script record, a module record, or null. It is used to determine the running script or module based on the running execution context. It performs the following steps when called. If the execution context stack is empty, return null. Let X be the topmost execution context on the execution context stack whose script or module component is not null. If no such execution context exists, return null. Otherwise, return X script or module. 4.2 Resolve binding. Name, env. The abstract operation resolve binding takes argument name, a string, and optional argument env, an environment record or undefined, and returns either a normal completion containing a reference record or a throw completion. It is used to determine the binding of name. Env can be used to explicitly provide the environment record that is to be searched for the binding. It performs the following steps when called. If env is not present or env is undefined, then A set env to the running execution context's lexical environment. Assert env is an environment record if the source text matched by the syntactic production that is being evaluated is contained in strict mode. Code. Let strict be true, else let strict be false. Return. Get identifier reference, env, name, strict, 4.3 Get this environment. The abstract operation get this environment takes no arguments and returns an environment record. It finds the environment record that currently supplies the binding of the keyword this. It performs the following steps when called. Let env be the running execution context's lexical environment 2. Repeat. Component purpose. Generator the generator that this execution context is evaluating. 156. ECMA International 2024. Note the result of resolve binding is always a reference record whose field is name. ABCDE. Let exists be env has this binding. If exists is true, return env. Let outer be env. Assert. Outer is not null. Set env to outer. Note the loop in step 2 will always terminate because the list of environments always ends with the global environment which has a this binding. 4.4 Resolve this binding. The abstract operation resolve this binding takes no arguments and returns either a normal completion containing an ECMAScript language value or a throw completion. It determines the binding of the keyword this using the lexical environment of the running execution context. It performs the following steps when called. Let env-rec be get this environment. Return env-rec get this binding. 4.5 Get new target. The abstract operation get new target takes no arguments and returns an object or undefined. It determines the new target value using the lexical environment of the running execution context. It performs the following steps when called. Let env-rec be get this environment. Assert. env-rec has a field. Return env-rec, 4.6 Get global object. The abstract operation get global object takes no arguments and returns an object. It returns the global object used by the currently running execution context. It performs the following steps when called. 2.5 Let current realm be the current realm record. Return current realm, jobs and host operations to enqueue jobs. A job is an abstract closure with no parameters that initiates an ECMAScript computation when no other ECMAScript computation is currently in progress. Jobs are scheduled for execution by ECMAScript host environments in a particular agent. This specification describes the host hook's host enqueue generic job. Capital H O S T capital E N Q U E U E capital F I N A L I Z A T I O N capital R E G I S T R host enqueue promise job and host enqueue timeout job to schedule jobs. The host hooks in this specification are organized by the additional constraints imposed on the scheduling of jobs. Hosts may define additional abstract operations which schedule jobs. Such operations accept a job abstract closure and a realm record or null, as parameters. If a realm record is provided, these operations schedule the job to be performed at some future time in the provided realm.
So, I don't know. I'm gonna try to get some code that'll like
Following requirements.
Compile and make the executable.
Agent for which the job is scheduled and that agent's execution.
Print to the console. Hello world or something first.
Perform any host-defined cleanup steps, after which the execution context.
Because Chatbot made a code that said it would like make the console wait for user input to click Y on the keyboard, so the console would remain open, but it doesn't do that.
Abstract.
Because when I click, what Chatbot said would work,
Handling of errors. ECMA International 2000.
it didn't print hello world,
One host
and the console didn't stay open.
uniform.
It didn't wait for me to press Y.
Browsers and Node.js treat promise handle.
It didn't do anything that Chatbot said it would do, because Chatbot is shit.
Particular time, script or module, a script record, a module
I don't know how people use Chatbot to write code. They must be writing shit code, like literal shit. They don't know how to program. Anyways,
context on the execution context stack.
I'm gonna try this, whatever,
Script or module, the realm component of X.
and I'm gonna try whatever else. I'm gonna get something running. I just gotta get it to print hello world
Script code
to the console, so I have like, so I know it's like printing to the console. Then I can make a speed test and actually test stuff, and then I'll do
kinds of jobs have additional
my find the highest bit set routine or whatever,
you use to
and I'll like speed test that against using a magic number to get the highest bit set and a number in C. But basically overall, and also the bit scan reverse instruction. I don't know. Overall though, I want to compare the Visual Studio output versus if I write it in assembly by hand, because the Visual Studio output seemed a bit slow. So I want to see if it's faster in assembly, whatever.
and returns a
So I don't know. That's my goal.
of host make job call
So I'm like, stop talking. I gotta figure this out.
job callback record whose field is
And I'll have something to say. And I had something else to say, but I forgot.
the execution context stack. The specific steps are implementation defined. The specific choice of realm is up to the host environment. This initial
I don't know. It's gone.
when a callback function related to a job, like a promise hand
Dang it. So I'm gonna try to figure this out though.
in context and realm, note the WHATWGHTML specification https://html.spec.whatwg.org/ for example, uses the host-defined value to propagate the incumbent settings object for promise callbacks. Field name value, meaning callback, a function object, the function to invoke when the job is invoked. Host-defined, anything default value is empty. Field reserved for use by hosts. 158. ECMA International 2024. The default implementation of host make job callback performs the following steps when called. 1. Return the job callback record. Callback empty. ECMAScript hosts that are not web browsers must use the default implementation of host make job callback, 5.3 hosts call job callback, v. Arguments list. The host-defined abstract operation host call job callback takes arguments job callback, a job callback record, v. an ECMAScript language value, and arguments list, a list of ECMAScript language values, and returns either a normal completion containing an ECMAScript language value or a throw completion. An implementation of host call job callback must conform to the following requirements. It must perform and return the result of call job callback, v. arguments list. The default implementation of host call job callback performs the following steps when called. Assert is callable. Job callback is true. Return call job callback, v. arguments list. ECMAScript hosts that are not web browsers must use the default implementation of host call job callback, 5.4 host enqueue generic job realm. The host-defined abstract operation host enqueue generic job takes arguments job, a job abstract closure, and realm, a realm record, and returns unused. It schedules job in the realm in the agent signified by realm to be performed at some future time. The abstract closures used with this algorithm are intended to be scheduled without additional constraints, such as priority and ordering. An implementation of host enqueue generic job must conform to the requirements in 9.5 host enqueue promise job realm. The host-defined abstract operation host enqueue promise job takes arguments job, a job abstract closure, and realm, a realm record or null, and returns unused. It schedules job to be performed at some future time. The abstract closures used with this algorithm are intended to be related to the handling of promises, or otherwise, to be scheduled with equal priority to promise handling operations. An implementation of host enqueue promise job must conform to the requirements in 9.5 as well as the following. If realm is not null, each time job is invoked, the implementation must perform implementation-defined steps such that execution is prepared to evaluate ECMAScript code at the time of job's invocation. Let script or module be get active script or module at the time host enqueue promise job is invoked. If realm is not null, each time job is invoked, the implementation must perform implementation-defined steps such that script or module is the active script or module at the time of job's invocation. Jobs must run in the same order as the host enqueue promise job invocations that scheduled them. Note this is called at the time that the callback is passed to the function that is responsible for its being eventually scheduled and run. For example, promise then action, calls make job callback on then action at the time of invoking promise prototype then, not at the time of scheduling the reaction job. Note this requirement means that hosts cannot change the behavior of function objects defined in this specification. ECMA International 2024 159. Note the realm for jobs returned by new promise resolve thenable job is usually the result of calling get function realm on the then function object. The realm for jobs returned by new promise reaction job is usually the result of calling get function realm on the handler if the handler is not undefined. If the handler is undefined, realm is null. For both kinds of jobs, when get function realm completes abnormally, that is called on a revoke proxy, realm is the current realm record at the time of the get function realm call. When the realm is null, no user ECMAScript code will be evaluated and no new ECMAScript objects, for example error objects, will be created. The WHATWG-HTML specification, https://html.spec.whatwg.org/ for example, uses realm to check for the ability to run script and for the entry, https://html.spec.whatwg.org/ /# entry. Concept, 5.6 host enqueue timeout job. Timeout job. Realm. Milliseconds. The host-defined abstract operation host enqueue timeout job takes arguments timeout job, a job abstract closure, realm, a realm record, and milliseconds, a non-negative finite number, and returns unused. It schedules timeout job in the realm in the agent signified by realm to be performed after at least milliseconds. An implementation of host enqueue timeout job must conform to the requirements in 9.5, 9.6 initialize host-defined realm. The abstract operation initialize host-defined realm takes no arguments and returns either a normal completion containing unused or a throw completion. It performs the following steps when called. Let realm be create realm. Let new context be a new execution context. Set the function of new context to null. Set the realm of new context to realm. Set the script or module of new context to null. Push new context onto the execution context stack. New context is now the running execution context. If the host requires use of an exotic object to serve as realm's global object, let global be such an object created in a host-defined manner. Otherwise, let global be undefined, indicating that an ordinary object should be created as the global object. If the host requires that this binding in realm's global scope return an object other than the global object, let this value be such an object created in a host-defined manner. Otherwise, let this value be undefined, indicating that realm's global this binding should be the global object. Perform set realm global object, realm, global. This value 0. Let global obj be. Set default global bindings. Realm 1. Create any host-defined global object properties on global obj 2. Return unused. 0.7 agents. An agent comprises a set of ECMAScript execution contexts, an execution context stack, a running execution context, an agent record, and an executing thread. Except for the executing thread, the constituents of an agent belong exclusively to that the agent. An agent's executing thread executes algorithmic steps on the agent's execution contexts independently of other agents, except that an executing thread may be used as the executing thread by multiple agents, provided none of the agents sharing the thread have an agent record whose field is true. Note 1. Some web browsers share a single execute thread across multiple unrelated tabs of a browser window. For example, 60. Copyright sign, ECMA International 2024. While an agent's executing thread is executing algorithmic steps, the agent is the surrounding agent for those steps. The steps use the surrounding agent to access the specification level execution objects held within the agent, the running execution context, the execution context stack, and the agent records fields. An agent signifier is a globally unique opaque value used to identify an agent. Table 29, agent record fields. Field name, value, meaning, little endian, a boolean. The default value computed for the is little endian parameter when it is needed by the algorithm's get value from buffer and set value in buffer. The choice is implementation defined and should be the alternative that is most efficient for the implementation. Once the value has been observed, it cannot change. Can block. A boolean determines whether the agent can block or not. Signifier. An agent signifier uniquely identifies the agent within its agent cluster. Is lock-free 1. A boolean, true if atomic operations on 1 byte values are lock-free. False otherwise. Is lock-free 2. A boolean, true if atomic operations on 2 byte values are lock-free. False otherwise. Is lock-free 8. A boolean, true if atomic operations on 8 byte values are lock-free. False otherwise. Candidate execution. A. Candidate execution record. See the memory model. Kept alive. A list of either objects or symbols. Initially a new empty list, representing the list of objects and or symbols to be kept alive until the end of the current job. Once the values of and have been observed by any agent in the agent cluster, they cannot change. Note 2. The values of and are not necessarily determined by the hardware, but may also reflect implementation choices that can vary over time and between ECMAScript implementations. There is no field. 4-byte atomic operations are always lock-free. In practice, if an atomic operation is implemented with any type of lock, the operation is not lock-free. Lock-free does not imply wait-free. There is no upper bound on how many machine steps may be required to complete a lock-free atomic operation. That an atomic access of size n is lock-free does not imply anything about the perceived atomicity of non-atomic accesses of size n. Specifically, non-atomic accesses may still be performed as a sequence of several separate memory accesses. See Read Shared Memory and Write Shared Memory for details. ECMA International 2024 161. Note 3: An agent is a specification mechanism and need not correspond to any particular artifact of an ECMAScript implementation. 7.1 Agent Signifier. The abstract operation agent signifier takes no arguments and returns an agent signifier. It performs the following steps when called. Let AR be the agent record of the surrounding agent. Return AR, 7.2 Agent can suspend. The abstract operation agent can suspend takes no arguments and returns a boolean. It performs the following steps when called. 2.8 Let AR be the agent record of the surrounding agent. Return AR agent clusters. Note: in some environments it may not be reasonable for a given agent to suspend. For example, in a web browser environment, it may be reasonable to disallow suspending a document's main event handling thread, while still allowing workers' event handling threads to suspend. An agent cluster is a maximal set of agents that can communicate by operating on shared memory. Every agent belongs to exactly one agent cluster. All agents within a cluster must have the same value for the field in their respective agent records. All agents within a cluster must have the same values for the field in their respective agent records. Similarly for the field, all agents within a cluster must have different values for the field in their respective agent records. An embedding may deactivate, stop forward progress, or activate, resume forward progress, an agent without the agent's knowledge or cooperation. If the embedding does so, it must not leave some agents in the cluster active while other agents in the cluster are deactivated indefinitely. Note 1: Programs within different agents may share memory by unspecified means. At a minimum, the backend memory for shared array buffers can be shared among the agents in the cluster. There may be agents that can communicate by message passing that cannot share memory. They are never in the same agent cluster. Note 2: The agents in a cluster need not all be alive at some particular point in time. If agent A creates another agent B, after which A terminates and B creates agent C, the three agents are in the same cluster if A could share some memory with B and B could share some memory with C. Note 3: If different agents within an agent cluster have different values of it becomes hard to use shared memory for multi-byte data. 62. Copyright sign. ECMA International 2024. Note 4. The purpose of the preceding restriction is to avoid a situation where an agent deadlocks or starves because another agent has been deactivated. For example, if an HTML shared worker that has a lifetime independent of documents in any windows were allowed to share memory with the dedicated worker of such an independent document, and the document and its dedicated worker were to be deactivated while the dedicated worker holds a lock. Say, the document is pushed into its Windows history, and the shared worker then tries to acquire the lock. Then the shared worker will be blocked until the dedicated worker is activated again, if ever. Meanwhile, other workers trying to access the shared worker from other windows will starve. The implication of the restriction is that it will not be possible to share memory between agents that don't belong to the same suspend wake collective within the embedding. An embedding may terminate an agent without any of the agent's cluster's other agents' prior knowledge or cooperation. If an agent is terminated not by programmatic action of its own or of another agent in the cluster but by forces external to the cluster, then the embedding must choose one of two strategies: either terminate all the agents in the cluster, or provide reliable APIs that allow the agents in the cluster to coordinate so that at least one remaining member of the cluster will be able to detect the termination, with the termination data containing enough information to identify the agent that was terminated. Each of the following specification values, and values transitively reachable from them, belong to exactly one agent cluster. Candidate execution record, shared data block, waitlist record. Prior to any evaluation of any ECMAScript code by any agent in a cluster, the field of the agent record for all agents in the cluster is set to the initial candidate execution. The initial candidate execution is an empty candidate execution whose field is a list containing, for each agent, an agent events record whose field is that agent's agent signifier, and whose fields are empty lists. Note 5 examples of that type of termination are operating systems or users terminating agents that are running in separate processes. The embedding itself terminating an agent that is running in process with the other agents when per. Agent resource accounting indicates that the agent is run away. Note 6. All agents in an agent cluster share the same candidate execution in its agent records field. The candidate execution is a specification mechanism used by the memory model. Note 7. An agent cluster is a specification mechanism and need not correspond to any particular artifact of an ECMAScript implementation. Point 9. Forward progress. For an agent to make forward progress is for it to perform an evaluation step according to this specification. An agent becomes blocked when its running execution context waits synchronously and indefinitely for an external event. Only agents whose agent records field is true can become blocked in this sense. An unblocked agent is one that is not blocked. Implementations must ensure that every unblocked agent with a dedicated executing thread eventually makes forward progress. In a set of agents that share an executing thread, one agent eventually makes forward progress. ECMA International 2024 163. An agent does not cause another agent to become blocked except via explicit APIs that provide blocking. Point 10. Processing model of weak ref and finalization registry targets 9.10. 1. Objectives. This specification does not make any guarantees that any object or symbol will be garbage collected. Objects or symbols which are not live may be released after long periods of time, or never at all. For this reason, this specification uses the term may when describing behavior triggered by garbage collection. The semantics of weak refs and finalization registries is based on two operations which happen at particular points in time. When weak ref prototype derf is called, the referent, if undefined is not returned, is kept alive so that subsequent synchronous accesses also return the same value. This list is reset when synchronous work is done using the clear-kept objects abstract operation. When an object or symbol which is registered with the finalization registry becomes unreachable, a call of the finalization registry's cleanup callback may eventually be made after synchronous ECMAScript execution completes. The finalization registry cleanup is performed with the cleanup finalization registry abstract operation. Neither of these actions, clear-kept objects or cleanup finalization registry, may interrupt synchronous ECMAScript execution. Because hosts may assemble longer, synchronous ECMAScript execution runs, the specification defers the scheduling of clear-kept objects and cleanup finalization registry to the host environment. Some ECMAScript implementations include garbage collector implementations which run in the background, including when ECMAScript is idle. Letting the host environment schedule cleanup finalization registry allows it to resume ECMAScript execution in order to run finalizer work, which may free up held values, reducing overall memory usage. 10.2 Liveness. For some set of objects and or symbols S, a hypothetical weak ref oblivious execution with respect to S is an execution whereby the abstract operation weak ref derf of a weak ref whose referent is an element of S always returns undefined. This, along with the liveness guarantee in the memory model, ensures that all sextst writes note eventually become observable to all agents. Note 1 weak ref obliviousness, together with liveness, capture two notions. 1. That a weak ref itself does not keep its referent alive. 2. That cycles in liveness does not imply that a value is live. To be concrete, if determining V's liveness depends on determining the liveness of a weak ref referent, R's liveness cannot assume V's liveness, which would be circular reasoning. Note 2 weak ref obliviousness is defined on sets of objects or symbols instead of individual values to account for cycles. If it were defined on individual values, then a weak ref referent in a cycle will be considered live even though its identity is only observed via other weak ref referents in the cycle. Note 3 colloquially, we say that an individual object or symbol is live if every set containing it is live. At any point during evaluation, a set of objects and or symbols S is considered live if either of the following conditions is met. Any element in S is included in any agents list 164. ECMA International 2024. There exists a valid future hypothetical weak ref oblivious execution with respect to S that observes the identity of any value in S. Note 4 the second condition above intends to capture the intuition that a value is live if its identity is observable via non-weak ref means. A value's identity may be observed by observing a strict equality comparison or observing the value being used as key in a map. Note 5. Presence of an object or a symbol in a field, an internal slot, or a property does not imply that the value is live. For example, if the value in question is never passed back to the program, then it cannot be observed. This is the case for keys in a weak map, members of a weak set, as well as the infields of a finalization registry cell record. The above definition implies that if a key in a weak map is not live, then its corresponding value is not necessarily live either. Note 6. Liveness is the lower bound for guaranteeing which weak refs engines must not empty. Liveness is defined here as undecidable. In practice, engines use conservative approximations such as reachability. There is expected to be significant implementation leeway. 10.3 Execution. At any time, if a set of objects and/or symbols S is not live, an ECMAScript implementation may perform the following steps atomically. For each element value of S, do a for each weak ref such that ref is value. Do I set ref to empty. B for each finalization registry FG such that FG contains a record cell such that cell is value. Do I set cell to empty. 2. Optionally, perform capital H O S T capital E N Q U E U E capital F I N A.
Okay, so basically, this does work, except the command line argument didn't work.
FG, C for each weak map such that map contains a record R such that R value.
I don't know. What chatbot gave me for the command line, the command line argument does actually work. So after like mixing things together, I don't know, I think, well, it built. There might be something wrong, but it did build.
This clause prescribes optimization.
There's like a teeny bit of hope.
It is possible to access an
And by a teeny bit, I mean like a teeny bit. It's like click build here, whatever.
Nation and scalar replacement on properties of non-escaping objects whose identity.
And then made the exe.
These optimizations are thus allowed to observably empty
When double click the exe.
objects. On the other hand, if an object's identity is observable, and that object is in the internals,
This pops up. This tiny little bit of hope.
because calling capital H O
And it says hello world.
E N.
So this isn't the console. It's a message box or an alert box. That's close enough. I can now print a number. That's all I want to do. So this is good enough. So I can make a speed test, and I'll just print the number to this message box, wherever the heck this is. And that's good enough. That'll do. So I'll BRB.
Necessarily holds that finalization registry live. Implementations may omit finalization registry callbacks for any reason. For example, if the finalization registry itself becomes dead, or if the application is shutting down. Note 2. Implementations are not obligated to empty weak refs for maximal sets of non-live objects or symbols. If an implementation chooses a non-live set S in which to empty weak refs, this definition requires that it empties weak refs for all values in S simultaneously. In other words, it is not conformant for an implementation to empty a weak ref pointing to a value v without emptying out other weak refs that, if not emptied, could result in an execution that observes the value of v, 10.4 host hooks, 1041, capital H, O, S, T, capital E, N, Q, U, E, U, E, capital F, I, N, A, L, I, Z, A, T, I, O, N, capital R, E, G, I, S, T, R, finalization registry, the host-defined abstract operation, capital H, O, S, T, capital E, N, Q, U, E, U, E, capital F, I, N, A, L I Z A T I O N capital R E G I S T R takes argument finalization registry, a finalization registry, and returns unused. Let cleanup job be a new job abstract closure with no parameters that captures finalization registry and performs the following steps when called. Let cleanup result be completion. Cleanup finalization registry. Finalization registry. If cleanup result is an abrupt completion, perform any host-defined steps for reporting the error. Return unused. An implementation of capital H O S T capital E N Q U E U E capital F I N A L I Z A T I O N capital R E G I S T R schedules cleanup job to be performed at some future time, if possible. It must also conform to the requirements in 9.5.11 clear-kept objects. The abstract operation clear-kept objects takes no arguments and returns unused. ECMAScript implementations are expected to call clear-kept objects when a synchronous sequence of ECMAScript executions completes. It performs the following steps when called. Let agent record be the surrounding agent's agent record. Set agent record to a new empty list. Return unused. 66. ECMA International 2024 9.12 Add to kept objects. Value. The abstract operation add to kept objects takes argument value, an object or a symbol, and returns unused. It performs the following steps when called. Let agent record be the surrounding agent's agent record. Append value to agent record. Return unused. 0.13 Cleanup finalization registry. Finalization registry. The abstract operation cleanup finalization registry takes argument finalization registry, a finalization registry, and returns either a normal completion containing unused or a throw completion. It performs the following steps when called. Assert. Finalization registry hasn't internal slots. Let callback be finalization registry. While finalization registry contains a record cell such that cell is empty, an implementation may perform the following steps. A choose any such cell. B remove cell from finalization registry. CPR form. Host call job callback. Callback. Undefined. Cell. Return unused. 0.14 can be held weekly. V. The abstract operation can be held weekly takes argument V, an ECMAScript language value, and returns a boolean. It returns true if and only if V is suitable for use as a weak reference. Only values that are suitable for use as a weak reference may be a key of a weak map, an element of a weak set, the target of a weak ref, or one of the targets of a finalization registry. It performs the following steps when called. If V is an object, return true. If V is a symbol and key for symbol, V is undefined, return true. Return false. Note when the abstract operation add to kept objects is called with a target, object, or symbol, it adds the target to a list that will point strongly at the target until clear-kept objects is called. Note a language value without language identity can be manifested without prior reference and is unsuitable for use as a weak reference. A symbol value produced by symbol 4, unlike other symbol values, does not have language identity and is unsuitable for use as a weak reference. Well-known symbols are likely to never be collected, but are nonetheless treated as suitable for use as a weak reference because they are limited in number and therefore manageable by a variety of implementation approaches. However, any value associated to a well-known symbol in a live weak map is unlikely to be collected and could leak memory resources in implementations. 0. Ordinary and exotic objects behaviors. 0.1 Ordinary object internal methods and internal slots. All ordinary objects have an internal slot called. The value of this internal slot is either null or an object and is used for implementing inheritance. Assume a property named P is missing from an ordinary object O but exists on its object. If P refers to a data property on the object, O inherits it for get access, making it behave as if P was a property of O if P refers to a writable data property on the ECMA International 2024 167 object. Set access of P on O creates a new data property named P on O if P refers to a non-writable data property on the object. Set access of P on O fails. If P refers to an accessor property on the object, the accessor is inherited by O for both get access and set access. Every ordinary object has a Boolean valued internal slot which is used to fulfill the extensibility related internal method invariance specified in 6.1.7.3. Namely, once the value of an object's internal slot has been set to false, it is no longer possible to add properties to the object, to modify the value of the object's internal slot, or to subsequently change the value of to true. In the following algorithm descriptions, assume O is an ordinary object, P is a property key value, V is any ECMAScript language age value, and ESC is a property descriptor record. Each ordinary object internal method delegates to a similarly named abstract operation. If such an abstract operation depends on another internal method, then the internal method is invoked on O rather than calling the similarly named abstract operation directly. These semantics ensure that exotic objects have their overridden internal methods invoked when ordinary object internal methods are applied to them. 0, 1, 1. The internal method of an ordinary object O takes no arguments and returns a normal completion containing either an object or null. It performs the following steps when called. Return ordinary get prototype of O1 0 1 1 1 ordinary get prototype of O. The abstract operation ordinary get prototype of takes argument O, an object, and returns an object or null. It performs the following steps when called. Return O1 0 1 2 V. The internal method of an ordinary object O takes argument V, an object or null, and returns a normal completion containing a Boolean. It performs the following steps when called. Return ordinary set prototype of O. V1 0 1 2 1 ordinary set prototype of O. V. The abstract operation ordinary set prototype of takes arguments O, an object, and V, an object or null, and returns a Boolean. It performs the following steps when called. Let current be O if same value, V, current, is true, return true. Let extensible be O if extensible is false, return false. Let bev, let done be false. Repeat. While done is false if P is null, then I set done to true. Be else if same value, P, O, is true, then I return false. See else. If P is not the ordinary object internal method defined in 1 0 1 1. Set done to true. 2. Else. Set P to P, set O to V, return true. 68. ECMA International 2024. Note the loop in step 7 guarantees that there will be no circularities in any prototype chain that only includes objects that use the ordinary object definitions for int 0, 1, 3. The internal method of an ordinary object O takes no arguments and returns a normal completion containing a Boolean. It performs the following steps when called. Return ordinary is extensible. O1 0, 1, 3. 1 ordinary is extensible. O. The abstract operation ordinary is extensible takes argument O, an object, and returns a Boolean. It performs the following steps when called. Return O1 0, 1, 4. The internal method of an ordinary object O takes no arguments and returns a normal completion containing true. It performs the following steps when called. Return ordinary prevent extensions. O1 0, 1, 4. 1 ordinary prevent extensions. O. The abstract operation ordinary prevent extensions takes argument O, an object, and returns true. It performs the following steps when called. Set O to false. Return true. 0, 1, 5. P. The internal method of an ordinary object O takes argument P, a property key, and returns a normal completion containing either a property descriptor or undefined. It performs the following steps when called. Return ordinary get own property, O, P1 0, 1, 5, 1 ordinary get own property, O, P. The abstract operation ordinary get own property takes arguments O, an object, and P, a property key, and returns a property descriptor or undefined. It performs the following steps when called. If O does not have a known property with key P, Return undefined. Let D be a newly created property descriptor with no fields. Let X be O's own property whose key is P. If X is a data property, then A set D to the value of X's attribute. B set D to the value of X's attribute. Else, A assert X is an accessor property. B set D attribute. C set D attribute. ECMA International 2024 169. 6. Set D to the value of X's attribute. Set D to the value of X's attribute. Return D 0, 1, 6, P, desk. The internal method of an ordinary object O takes arguments P, a property key, and desk, a property descriptor, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Return ordinary define own property O, P, desk 1 0, 1, 6, 1 ordinary define own property O, P, desk. The abstract operation ordinary define own property takes arguments O, an object, P, a property key, and desk, a property descriptor, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Let current be O, P, let extensible be is extensible O, return capital V, A, L, I, D, A, T, E, capital A, N, D, capital A, P, P, L, Y, capital P, R, O, P, E, R, T, Y, capital D, E, S, C, R, I, O, P, extensible, desk, current, 0, 1, 6, 2 is compatible property descriptor, extensible, desk, current. The abstract operation is compatible property descriptor takes arguments extensible, a boolean, desk, a property descriptor, and current, a property descriptor or undefined, and returns a boolean. It performs the following steps when called. Return capital V, A, L, I, D, A, T, E, capital A, N, D, capital A, P, P, L, Y, capital P, R, O, P, E, R, T, Y, capital D, E, S, C, R, I, undefined, extensible.
Okay, so
6, 3, capital V.
I'm not gonna waste time making like hexadecimal to like decimal. I'll just set the bytes to an array and then print them. But like nibble, I'll just do hexadecimal.
I, capital D,
This is so boring.
R, I, O, P, extensible, desk, current. The abstract operation, capital V, A, L, I, D, A, T, E, capital A, N, D, capital A, P, P, L, Y, capital P, R, O, P, E, R, T, Y, capital D, E, S, C, R, I, takes arguments O, an object or undefined, P, a property key, extensible, a boolean, desk, a property descriptor, and current, a property descriptor or undefined, and returns a boolean. It returns true if and only if desk can be applied as the property of an object with specified extensibility and current property current while upholding invariance. When such application is possible and O is not undefined, it is performed for the property named P.
So I don't know. I'll do the bit test thing in a minute.
True if current is
I'm gonna have to like
undefensible is false. Return
figure out the addressing mode and then test it a couple times to make sure it works.
true, then
So I can like make an array of bytes, set the hexadecimal value, I guess a result, the checksum maybe, I don't know, it doesn't matter. I just gotta like figure out which instruction to use.
Property named
And then like there's relative you gotta put inside of the address, the accessor.
if desk has
I'm not totally sure how that works. It's 64-bit. But the lead instruction, it loads any effective address. But it doesn't technically load, it just computes the address without actually loading it.
return
And then you can pass it around or whatever.
is not current.
You don't have to use Lee. Well, you have to, I don't know. Basically,
Current
I'm not going to waste time explaining everything.
current is true. Then I have
I just gotta make a byte array. I guess it has to be like null terminated.
2. If desk has a field in same value, desk current is false. Return false if O is not undefined.
Because it's calling message box A, which is a Windows thing, I guess. And it looks like it has to be null terminated. So if I make data, I just have to null terminate it. I guess a length isn't passed in.
Numerable be desk.
I think this is the title of the window of the message box A.
Object O with an accessor property
That's also null terminated.
and enumerable, respectively, and whose attributes are set to the value of the corresponding field in desk if desk has that field. Or to the
So I don't know, I gotta like
be else if is accessor descriptor. Current is true and is
define a larger byte array, set stuff up, and then I'll make a
let
highest bit test set thing, whatever.
2. If desk
I like speed test stuff.
let enumerable be desk. Else let enumerable
It's probably gonna get a pain to get the timer or like a stopwatch running
isn't
in assembly.
to configurable and
So that's gonna be fun. At least it's printing to, what is it?
if desk has that field. Or to the attribute
At least it's printing to message box A. So that's good enough for now.
set the corresponding attribute of the property named P of object O to the value of the field 7. Return true 0, 1, 7, P. The internal method of an ordinary object O takes argument P, a property key, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. 1. Return. Ordinary has property O, P, 0, 1, 7, 1. Ordinary has property O, P. The abstract operation ordinary has property takes argument so, an object, and P, a property key, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Let has own be O, P. If his own is not undefined, return true. Let parent be O. If parent is not null, then a return parent. P5. Return false 0, 1, 8. The return ordinary get O, P. Receiver ECMA International 2024 171 10 1 8 1. Ordinary get O, P. Receiver. The abstract operation ordinary get takes argument so, an object, P, a property key, and receiver, an ECMAScript language value, and returns either a normal completion containing an ECMAScript language value or a throw completion. It performs the following steps when called. Let desk be O, P. If desk is undefined, then a let parent be O, B. If parent is null, return undefined. See return parent. If is data descriptor, desk, is true, return desk. Assert, is accessor descriptor, desk, is true. Let getter be desk. If getter is undefined, return undefined. Return, call, getter, receiver 0, 1, 9. The return ordinary set O, P, V, receiver 1, 0, 1, 9, 1. Ordinary set O, P, V, receiver. The abstract operation ordinary set takes argument so, an obj, CT, P, a property key, V, an ECMAScript language value, and receiver, an ECMAScript language value, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Let ownDesc be O, P, return. Ordinary set with own descriptor. O, P, V, receiver, ownDesc, 0, 1, 9, 2 ordinary set with own descriptor. O, P, V, receiver, ownDesc. The abstract operation ordinary set with own descriptor takes arguments O, an object, P, a property key, V, an ECMAScript language value, receiver, an ECMAScript language value, and ownDesc, a property descriptor or undefined, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. If ownDesc is undefined, then a let parent be O, B. If parent is not null, then I return parent. I set ownDesc to the property descriptor, undefined, true, true, true. If is data descriptor, ownDesc, is true, then 72. ECMA International 2024. ABCDE. If ownDesc is false, return false. If receiver is not an object, return false. Let existing descriptor be receiver, P. If existing descriptor is not undefined, then if is accessor descriptor, existing descriptor, is true, return false. 2. If existing descriptor is false, return false. 3. Let valueDesc be the property descriptor, V, I've, return, receiver, P, valueDesc, else, I assert, receiver does not currently have a property P. 2. Return, create data property, receiver, P, V, assert, is accessor descriptor, ownDesc, is true. Let setter be ownDesc. If setter is undefined, return false. Perform, call, setter, receiver, V, return true, 0, 1, 1, 0, P. The internal method of an ordinary object O takes argument P, a property key, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Return, ordinary delete, O, P1, 0, 1, 1, 0, 1 ordinary delete, O, P. The abstract operation ordinary delete takes arguments O, an object, and P, a property key, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Let desc be O, P. If desc is undefined, return true. If desc is true, then A remove the own property with name P from O. P return true. Return false. 0, 1, 1, 1. The internal method of an ordinary object O takes no arguments and returns a normal completion containing a list of property keys. It performs the following steps when called. Return ordinary own property keys, O1, 0, 1, 1, 1, 1 ordinary own property keys, O. The abstract O, operation ordinary own property keys takes argument O, an object, and returns a list of property keys. It performs the following steps when called. Let keys be a new empty list. For each own property key P of O such that P is an array index, in ascending numeric index order, do A append P to keys. For each own property key P of O such that P is a string and P is not an array index, in ascending chronological order of property creation, do A append P to keys. For each own property key P of O such that P is a symbol, in ascending chronological order of property creation, do A append P to keys. 5. Return keys, 0, 1, 1, 2, ordinary object create, proto, additional internal slots list. The abstract operation ordinary object create takes argument proto an object or null, and optional argument additional internal slots list, a list of names of internal slots, and returns an object. It is used to specify the runtime creation of new ordinary objects. Additional internal slots list contains the names of additional internal slots. ECMA International 2024 173. That must be defined as part of the object, beyond and. If additional internal slots list is not provided, a new empty list is used. It performs the following steps when called. Let internal slots list be. If additional internal slots list is present, set internal slots list to the list concatenation of internal slots list and additional internal slots list. Let O be make basic object, internal slots list, set O to proto, return O, 0, 1, 1 3 ordinary create from constructor, constructor, intrinsic default proto, internal slots list. The abstract operation ordinary create from constructor takes arguments constructor, a constructor, and intrinsic default proto, a string, and optional argument internal slots list, a list of names of internal slots, and returns either a normal completion containing an object or a throw completion. It creates an ordinary object whose value is retrieved from a constructor's prototype property, if it exists. Otherwise, the intrinsic named by intrinsic default proto as used for internal slots list contains the names of additional internal slots that must be defined as part of the object. If internal slots list is not provided, a new empty list is used. It performs the following steps when called: assert. Intrinsic default proto is this specification's name of an intrinsic object. The corresponding object must be an intrinsic that is intended to be used as the value of an object. Let proto be. Get prototype from constructor. Constructor, intrinsic default proto. If internal slots list is present, let slots list be internal slots list. Else, let slots list be a new empty list. Return ordinary object create. Proto, slots list. 0, 1, 1 4 get prototype from constructor. Constructor, intrinsic default proto. The abstract operation get prototype from construct, or takes arguments constructor, a function object, and intrinsic default proto, a string, and returns either a normal completion containing an object or a throw completion. It determines the value that should be used to create an object corresponding to a specific constructor. The value is retrieved from the constructor's prototype property, if it exists. Otherwise, the intrinsic named by intrinsic default proto is used for. It performs the following steps when called: assert. Intrinsic default proto is this specification's name of an intrinsic object. The corresponding object must be an intrinsic that is intended to be used as the value of an object. Let proto be. Get. Constructor. Prototype. If proto is not an object, then let realm be. Get function realm. Constructor. Be set proto to realm's intrinsic object named intrinsic default proto. Return proto. Note, although ordinary object create does little more than call make basic object, its use communicates the intention to create an ordinary object, and not an exotic one. Thus, within this specification, it is not called by any algorithm that subsequently modifies the internal methods of the object in ways that would make the result non-ordinary. Operations that create exotic objects invoke make basic object directly. 174 ECMA International 2024. Note, if constructor does not supply a value, the default value that is used is obtained from the realm of the constructor function rather than from the running execution context. The 10th of January 2015 require internal slot. Oh, internal slot. The abstract operation require internal slot takes argument so, an ECMAScript language value, and internal slot, an internal slot name, and returns either a normal completion containing unused or a throw completion. It throws an exception unless O is an object and has the given internal slot. It performs the following steps when called: if O is not an object, throw a type error exception. If O does not have an internal slot, throw a type error exception. Return unused. 0.2 ECMAScript function objects. ECMAScript function objects encapsulate parameterized ECMAScript code closed over a lexical environment and support the dynamic evaluation of the code. An ECMAScript function object is an ordinary object and has the same internal slots and the same internal methods as other ordinary objects. The code of an ECMAScript function object may be either strict mode code, 1122, or non-strict code. An ECMAScript function object whose code is strict mode code is called a strict function. One whose code is not strict mode code is called a non-strict function. In addition to and, ECMAScript function objects also have the internal slots listed in Table 30. Table 30. Internal slots of ECMAScript function objects. Internal slot. Type. Description. Environment. An environment record. The environment record that he function was closed over. Used as the outer environment when evaluating the code of the function. Private environment. A. Private environment record or null. The private environment record for private names that the function was closed over null if this function is not syntactically contained within a class. Used as the outer private environment for inner classes when evaluating the code of the function. Formal parameters. A parse node. The root parse node of the source text that defines the function's formal parameter list. ECMAScript code. A parse node. The root parse node of the source text that defines the function's body. Constructor kind. Base or derived. Whether or not the function is a derived class constructor. Realm. A realm record. The realm in which the function was created and which provides any intrinsic objects that are accessed when evaluating the function. Script or module. A script record or a module record. The script or module in which the function was created. This mode. Lexical, strict, or global, defines how this references are interpreted within the formal parameters and code body of the function. Lexical means that this refers to the this value of a lexically enclosing function. Strict means that the this value is used exactly as provided by an invocation of the function. Global means that this value of undefined or null is interpreted as a reference to the global object, and any other this value is first passed to object. Copyright sign, ECMA International 2024, 75. Table 30, internal slots of ECMAScript function objects. Continued. Internal slot. Type. Description. Strict. A boolean. True if this is a strict function. False if this is a non-strict function. Home object. An object. If the function uses super, this is the object whose provides the object where super property lookups begin. Source text. A sequence of Unicode code points. The source text that defines the function. Fields. A list of class field definition records. If the function is a class, this is a list of records representing the non-static fields and corresponding initializers of the class. Private methods. A list of private elements. If the function is a class, this is a list representing the non-static private methods and accessors of the class. Class field initializer name. A string, a symbol, a private name, or empty. If the function is created as the initializer of a class field, the name to use for named evaluation of the field. Empty otherwise is class constructor. A boolean indicates whether the function is a class constructor. If true, invoking the functions will immediately throw a type error exception. All ECMAScript function objects have the internal method defined here. ECMAScript functions that are also constructors in addition have the internal method 0, 2, 1. This arguments list, capital T. The internal method of an ECMAScript function object f takes arguments this argument, an ECMAScript language value, and arguments list, a list of ECMAScript language values, and returns either a normal completion containing an ECMAScript language value or a throw completion. It performs the following steps when called. Let caller context be the running execution context. Let callee context be prepare for ordinary call. F. Undefined. Assert. Callee context is now the running execution context. If f is true, then a let error be a newly created type error object. B note. Error is created in callee context with f's associated realm record. C. Remove callee context from the execution context stack and restore caller context as the running execution context. D. Return throw completion. Error. Perform ordinary call bind this. F. Callee context. This argument. Let result be completion. Ordinary call evaluate body. F. Arguments list. Remove callee context from the execution context stack and restore caller context as the running execution context. If result is a return completion, return result. Return of abrupt. Result 0. Return undefined. 176. ECMA International 2024. Note when callee context is removed from the execution context stack in step 7 it must not be destroyed if it is suspended and retained for later resumption by an accessible generator. 1 0, 2, 1. 1. Prepare for ordinary call. F. New target. The abstract operation prepare for ordinary call takes arguments f, an ECMAScript function object, a new target, an object or undefined, and returns an execution context. It performs the following steps when called. Let caller context be the running execution context. Let callee context be a new ECMAScript code execution context. Set the function of callee context to f. Let callee realm be f. Set the realm of callee context to callee realm. Set the script or module of callee context to f. Let local env be new function environment f. New target. Set the lexical environment of callee context to local env. Set the variable environment of callee context to local env 0. Set the private environment of callee context to f1. If caller context is not already suspended, suspend caller context. 2. Push callee context onto the execution context stack. Callee context is now the running execution context. 3. Note: any exception objects produced after this point are associated with callee realm. 4. Return callee context. 0, 2, 1. To ordinary call bind this f. Callee context. This argument. The abstract operation ordinary call bind this takes arguments f, an ECMAScript function object, callee context, an execution context, and this argument, an ECMAScript language value, and returns unused. It performs the following steps when called. Let this mode be f. If this mode is lexical, return unused. Let callee realm be f. Dot. Let local env be the lexical environment of callee context. If this mode is strict, then let this value be this argument 6. Else, if this argument is either undefined or null, then I let global env be callee realm 2. Assert: global env is a global environment record. 3. Let this value be global env be else I let this value be. To object this argument. 2. Note: to object produces wrapper objects using callee realm. Assert: local env is a function environment record. Assert: the next step never returns an abrupt completion because local env is not initialized. Perform local env bind this value 0. Return unused 0, 2, 1. 3. Runtime semantics. Evaluate body. The syntax-directed operation evaluate body takes arguments function object, an ECMAScript function object, and arguments list, a list of ECMAScript language values, and returns either a normal completion containing an ECMAScript language value or an abrupt completion. It is defined piecewise over the following productions: function body, function statement list, return. Evaluate function body of function body with arguments function object and arguments list. Concise body, expression body, return. Evaluate concise body of concise body with arguments function object and arguments list. ECMA International 2024 177. Generator body, function body, return. Evaluate generator body of generator body with arguments function object and arguments list. Async generator body, function body, return. Evaluate async generator body of async generator body with arguments function object and arguments list. Async function body, function body, return. Evaluate async function body of async function body with arguments function object and arguments list. Async concise body, expression body, return. Evaluate async concise body of async concise body with arguments function object and arguments list. Initializer, assignment expression, assert. Arguments list is empty, assert. Function object is not empty, if is anonymous function definition, assignment expression, is true, then a let value be. Named evaluation of initializer with argument function object, else a let RHS be. Evaluation of assignment expression, be let value be. Get value, RHS, return completion record, return, value, empty, class static block body, class static block statement list, assert. Arguments list is empty, return. Evaluate class static block body of class static block body with argument function object, 0, 2, 1. For ordinary call evaluate body, f. Arguments list. The abstract operation ordinary call evaluate body takes arguments f, an ECMAScript function object, and arguments list, a list of ECMAScript language values, and returns either a normal completion containing an ECMAScript language value or an abrupt completion. It performs the following steps when called. Return. Evaluate body of f with arguments f and arguments list 1 0 2 2 arguments list. New target. The internal method of an ECMAScript function object f takes arguments list, a list of ECMAScript language values, a new target, a constructor, and returns either a normal completion containing an object or a throw completion. It performs the following steps when called. Let caller context be the running execution context. Let kind be f if kind is base, then let this argument be. Ordinary create from constructor. New target. %object prototype %4. Let callee context be prepare for ordinary call. F. New target. 178. ECMA International 2024. Note even though field initializers constitute a function boundary, calling capital F, U, N, C, T, I, O, N, capital D, E, C, L, A, R, A, T, I, O, N, capital I, N, S, T, A, N, T, I, A, T, I, does not have any observable effect and so is omitted. 5. Assert. Callee context is now the running execution context. If kind is base, then a perform ordinary call bind this. F. Callee context. This argument, be let initialize result be completion, initialize instance elements. This argument, F. See if initialize result is an abrupt completion, then I remove callee context from the execution context stack and restore caller context as the running execution context. 2. Return initialize result. Let constructor env be the lexical environment of callee context. Let result be completion. Ordinary call evaluate body. F. Arguments list. Remove callee context from the execution context stack and restore caller context as the running execution context. 0. If result is a return completion, then if result is an object, return result. B if kind is base, return this argument. C if result is not undefined, throw a type error exception. 1. Else a return if abrupt. Result. 2. Let this binding be constructor env get this binding. 3. Assert. This binding is an object. 4. Return this binding. 0, 2, 3 ordinary function create. Function prototype, source text, parameter list, body, this mode, env, private env. The abstract operation ordinary function create takes arguments function prototype, an object, source text, a sequence of Unicode code points, parameter list, a parse node, body a parse node, this mode, lexical this or non-lexical this, env, an environment record, and private env, a private environment record or null, and returns an ECMAScript function object. It is used to specify the runtime creation of a new function with a default internal method and no internal method, although one may be subsequently added by an operation such as make constructor. Dart source text is the source text of the syntactic definition of the function to be created. It performs the following steps when called. Let internal slots list be the internal slots listed in table 30. Let f be ordinary object create. Function prototype. Internal slots list. Set f to the definition specify. Add in 1 0 2 1. Set f to source text. Set f to parameter list. Set f to body. If the source text matched by body is strict mode code, let strict be true. Else let strict be false. Set f to strict. If this mode is lexical this, set f to lexical 0. Else if strict is true, set f to strict 1. Else, set f to global 2. Set f to false 3. Set f to env 4. Set f to private env 5. Set f to get active script or module 6. Set f to the current realm record 7. Set f to undefined 8. Set f to a new empty list 9. Set f to a new empty list 0. Set f to empty 1. Let len be the expected argument counter parameter list 2. Perform set function length f len 3. Return F. ECMA International 2024 179 1024 capital A D D capital R E S T R I C T E D capital F U N C T I O N capital P R O P E R T I E F realm. The abstract operation capital A D D capital R E S T R I C T E D capital F U N C T I O N capital P R O P E R T I E takes arguments f, a function object, and realm, a realm record, and returns unused. It performs the following steps when called. Assert. Realm exists and has been initialized. Let thrower be realm. Perform. Define property or throw. F. Caller. Property descriptor. Thrower. Enumerable. False. True. Perform. Define property or throw. F. Arguments. Property descriptor. Thrower. Enumerable. False. True. Return unused. 0, 2, 4, 1% throw type error %. This function is the %throw type error % intrinsic object. It is an anonymous built-in function object that is defined once for each realm. It performs the following steps when called. Throw type error exception. The value of the internal slot of this function is false. The length property of this function has the attributes false, false, false. The name property of this function has the attributes false, false, false. 0, 2, 5 make constructor f. Writable prototype, prototype. The abstract operation make constructor takes argument f, an ECMAScript function object or a built-in function object, and optional arguments writable prototype, a boolean, and prototype, an object, and returns unused. It converts f into a constructor. It performs the following steps when called. If f is an ECMAScript function object, then a assert is constructor, f is false. B assert, f is an extensible object that does not have a prototype own property. C set f to the definition specified in 10, 2, 2 else. A set f to the definition specified in 10, 3, 2 set f to base. If writable prototype is not present, set writable prototype to true. If prototype is not present, then a set prototype to ordinary object create %object prototype %. Perform. Define property or throw prototype constructor property descriptor f. Writable prototype false true. Perform. Define property or throw f. Prototype property descriptor prototype writable prototype false false. Return unused. 80 ECMA International 2024 10, 6 make class constructor f. The abstract operation make class constructor takes argument f, an ECMAScript function object, and returns unused. It performs the following steps when called. Assert. F is false. Set f to true. Return unused. 0, 2, 7 make method f. Home object. The abstract operation make method takes arguments f, an ECMAScript function object, and home object, an object, and returns unused. It configures f as a method. It performs the following steps when called. Set f to home object. Return unused. 0, 2, 8 define method property. Home object, key, closure, enumerable. The abstract operation define method property takes arguments home object, an object, key, a property key or private name, closure, a function object, and enumerable, a boolean, and returns either a normal completion containing either a private element or unused, or an abrupt completion. It performs the following steps when called. Assert. Home object is an ordinary, extensible object if key is a private name. then a return private element, method, closure 3. Else. A let desk be the property descriptor, closure, true, enumerable, true, be perform. Define property or throw, home object, key, desk, C note. Define property or throw only returns an abrupt completion when attempting to define a class. Static method whose key is prototype. D return unused. 0, 2, 9 set function name. F, name, prefix. The abstract operation set function name takes arguments f, a function object, a name, a property key or private name, and optional argument prefix, a string, and returns unused. It adds a name property to f. It performs the following steps when called. Assert. F is an extensible object that does not have a name own property. If name is a symbol, then a let description be name's value. B if description is undefined. Set name to the empty string. C else. Set name to the string concatenation of description. And else if name is a private name. Then a set name to name if f has an internal slot. Then a set f to name. If prefix is present, then a set name to the string concatenation of prefix. The code unit 0 times 0020 space and name. B if f has an internal slot, then I optionally set f to name. Perform. Define property or throw f name property descriptor name false enumerable false true return unused. ECMA International 2024 181, the 10th of February 2010. Set function length, f, length. The abstract operation set function length takes arguments f, a function object, and length, a non-negative int, ger or plus, and returns unused. It adds a length property to f. It performs the following steps when called. Assert. F is an extensible object that does not have a length own property. Perform. Define property or throw f, length, property descriptor, length, false enumerable, false, true, return unused. 0, 2, 1, 1, capital F, U, N, C, T, I, O, N, capital D, E, C, L, A, R, A, T, I, O, N, capital I, N, S, T, A, N, T, I, A, T, I, func, arguments list. The abstract operation, capital F, U, N, C, T, I, O, N, capital D, E, C, L, A, R, A, T, I, O, N, capital I, N, S, T, A, N, T, I, A, T, I, takes arguments func, an ECMAScript function object, and arguments list, a list of ECMAScript language values, and returns either a normal completion containing unused or an abrupt completion. Func is the function object for which the execution context is being established. Note 1. When an execution context is established for evaluating an ECMAScript function, a new function environment record is created and bindings for each formal parameter are instantiated in that environment record. Each declaration in the function body is also instantiated. If the function's formal parameters do not include any default value initializers, then the body declarations are instantiated in the same environment record as the parameters. If default value parameter initializers exist, a second environment record is created for the body declarations. Formal parameters and functions are initialized as part of capital F, U, N, C, T, I, O, N, capital D, E, C, L, A, R, A, T, I, O, N, capital I, N, S, T, A, N, T, I, A, T, I, all other bindings are initialized during evaluation of the function body. It performs the following steps when called. Let callee context be the running execution context. Let code be func. Let strict be func. Let formals be func. Let parameter names be the bound names of formals. If parameter names has any duplicate entries, let has duplicates be true. Otherwise, let has duplicates be false. Let simple parameter list be a simple parameter list of formals. Let has parameter expressions be contains expression of formals. Let var names be the var declared names of code. 0. Let var declarations be the var scope declarations of code. 1. Let lexical names be the lexically declared names of code. 2. Let function names be a new empty list. 3. Let functions to initialize be a new empty list. 4. For each element D of var declarations, in reverse list order, do, if D is neither a variable declaration nor a for binding nor a binding identifier, then, IASA, T, D is either a function declaration, a generator declaration, an async function declaration, or an async generator declaration. 2. Let fn be the sole element of the bound names of D. 3. If function names does not contain fn, then insert fn as the first element of function names. Note, if there are multiple function declarations for the same name, the last declaration is used. Insert d as the first element of functions to initialize. 5. Let arguments object needed be true. 6. If func is lexical, then, a note, arrow functions never have an arguments object. B set arguments object needed to false. 7. Else if parameter names contains arguments, then, a set arguments object needed to false. 82. ECMA International 2024. 18. Else if his parameter expressions is false, then, if function names contains arguments or lexical names contains arguments, then, I set arguments object needed to false. 9. If strict is true or has parameter expressions is false, then, a note, only a single environment record is needed for the parameters, since calls to eval in strict mode code cannot create new bindings which are visible outside of the eval. B let env be the lexical environment of callee context. 0. Else, a note, a separate environment record is needed to ensure that bindings created by direct eval calls in the formal parameter list are outside the environment where parameters are declared. B let callee env be the lexical environment of callee context. C let env be new declarative environment. Callee env. D assert. The variable environment of callee context is callee env. E set the lexical environment of callee context to env. 1. For each string param name of parameter names, do a let already declared env has binding. Param name, b note. Early errors ensure that duplicate parameter names can only occur in non-strict functions that do not have parameter default values or rest parameters. See if already declared is false. Then, I perform env create mutable binding. Param name, false. 2. If his duplicates is true, then, perform env initialize binding. Param name, undefined 22. If arguments object needed is true, then, if strict is true or simple parameter list is false, then, I let AOB create an mapped arguments object, arguments list. B else, I note, a mapped argument object is only provided for non-strict functions that don't have a rest parameter, any parameter default value initializers, or any destructured parameters. 2. Let AOB create mapped arguments object, func, formals, arguments list, env. See if strict is true, then I perform env create immutable binding, arguments, false. 2. Note, in strict mode code, early errors prevent attempting to assign to this binding, so its mutability is not observable. D else, I perform env create mutable binding, arguments, false. E perform env initialize binding, arguments. O. F let parameter bindings be the list concatenation of parameter names and argum. NTS. 3. Else, a let parameter bindings be parameter names. 4. Let iterator record be create list iterator record, arguments list. 5. If his duplicates is true, then a perform iterator binding initialization of formals with arguments iterator record and undefined 26. Else a perform iterator binding initialization of formals with arguments iterator record and env 27. If his parameter expressions is false, then, a note, only a single environment record is needed for the parameters and top-level vars. B. Let instantiated var names be a copy of the list parameter bindings. C. For each element n of var names, do I if instantiated var names does not contain n, then append n to instantiated var names. Perform env create mutable binding, n, false. Perform env initialize binding, n, undefined. D. Let var env be env28. Else, a note, a separate environment record is needed to ensure that closures created by expressions in the formal parameter list do not have visibility of declarations in the function body. B. Let var env be new declarative environment. env. C. Set the variable environment of callee context to var env. D. Let instantiated var names be a new empty list. E. For each element n of var names, do I if instantiated var names does not contain n, then ECMA International 2024 183 1. Append n to instantiated var names. Perform var env create mutable binding, n, false. If parameter bindings does not contain n, or if function names contains n, then a let initial value be undefined for. Else, a let initial value be env get binding value, n, false. Perform var env initialize binding, n, initial value. Note, a var with the same name as a formal parameter initially has the same value as the corresponding initialized parameter. 9. Note, an xb, 3, 2, 1 adds additional steps at this point. 0. If strict is false, then a let lexenv be new declarative environment. Var env, b. Note, non-strict functions use a separate environment record for top-level lexical declarations so that a direct eval can determine whether any var scope declarations introduced by the eval code conflict with pre-existing top-level lexically scoped declarations. This is not needed for strict functions because a strict direct eval always places all declarations into a new environment record. 1. Else, a let lexenv be var env. 2. Set the lexical environment of callee context to lexenv. 3. Let lex declarations be the lexically scoped declarations of code. 4. For each element d of lex declarations, do a note, a lexically declared name cannot be the same as a function generator declaration, formal parameter, or a var name. Lexically declared names are only instantiated here but not initialized. B. For each element dn of the bound names of d, do I if this constant declaration of d is true, then perform lexenv create immutable binding, dn, true to. Else, perform lexenv create mutable binding, dn, false. 5. Let private env be the private environment of callee context. 6. For each parse node f of functions to initialize, do a let fn be the sole element of the bound names of f. B. Let fo be instantiate function object of f with arguments lexenv and private env. C. Perform var env set mutable binding, fn, fo, false. 7. Return unused. 0.3 Built-in function objects. A built-in function object is an ordinary object. It must satisfy the requirements for ordinary objects set out in 10.1. In addition to the internal slots required of every ordinary object, see 10.1. A built-in function object must also have the following internal slots: a realm record that represents the realm in which the function was created, a string that is the initial name of the function. It is used by 20, 2, 3, 5. The initial value of a built-in function object's internal slot is %function prototype %, unless otherwise specified. A built-in function object must have an internal method that conforms to the definition in 103. 1. A built-in function object has an internal method if and only if it is described as a constructor, or some algorithm in this specification explicitly sets its internal method. Such an internal method must conform to the definition in 103. 2. An implementation may provide additional built-in function objects that are not defined in this specification. Note 2b. 3.2 provides an extension to the above algorithm that is necessary for backwards compatibility with web browser implementations of ECMAScript that predate ECMAScript 2015. 84. Copyright sign, ECMA International 2024. 103. 1. This arguments list, The internal method of a built-in function object f takes arguments this argument, an ECMAScript language value, and arguments list, a list of ECMAScript language values, and returns either a normal completion containing an ECMAScript language value or a throw completion. It performs the following steps when called. Return, built-in call or construct, f, this argument, arguments list, undefined 1 0, 3, 2, arguments list, new target. The internal method of a built-in function object f, when the method is present, takes arguments list, a list of ECMAScript language values, a new target, a constructor, and returns either a normal completion containing an object or a throw completion. It performs the following steps when called. Return, built-in call or construct, f, uninitialized, arguments list, new target 1 0, 3, 3 built-in call or construct, f, this argument, arguments list, new target. The abstract operation built-in call or construct takes arguments f, a built-in function object, this argument, an ECMAScript language value or uninitialized, arguments list, a list of ECMAScript language values, a new target, a constructor or undefined, and returns either a normal completion containing an ECMAScript language value or a throw completion. It performs the following steps when called. Let caller context be the running execution context. If caller context is not already suspended, suspend caller context. Let callee context be a new execution context. Set the function of callee context to f. Let callee realm be f. Set the realm of callee context to callee realm. Set the script or module of callee context to null. Perform any necessary implementation defined initialization of callee context. Push callee context onto the execution context stack. Callee context is now the running execution context. 0. Let result be the completion record that is the result of evaluating f in a manner that conforms to the specification of f if this argument is uninitialized, that this value is uninitialized. Otherwise, this argument provides the this value arguments list provides the named parameters new target provides the new target value. 1. Note, if f is defined in this document, the specification of f is the behavior specified for it via algorithm steps or other means. 2. Remove callee context from the execution context stack and restore caller context as the running execution context. 3. Return result 0, 3, 4. Create built-in function, behavior, length, name, additional internal slots list, realm, prototype, prefix. The abstract operation create built-in function takes arguments behavior, an abstract closure, a set of algorithm steps, or some other definition of a function's behavior provided in this specification, length, a non-negative integer or plus, name, a property key or a private name, and additional internal slots list, a list of names of internal slots, and optional arguments realm, a realm record, prototype, an object or null, and prefix, a string, and returns a function object. Additional internal slots list contains the names of additional internal slots that must. Note, when callee context is removed from the execution context stack, it must not be destroyed if it has been suspended and retained by an accessible generator for later resumption. ECMA International 2024 185 be defined as part of the object. This operation creates a built-in function object. It performs the following steps when called. If realm is not present, set realm to the current realm record. If prototype is not present, set prototype to realm. Let internal slots list be a list containing the names of all the internal slots that 10.3 requires for the built-in function object that is about to be created. Append to internal slots list the elements of additional internal slots list. Let fun be a new built-in function object that, when called, performs the action described by behavior, using the provided arguments as the values of the corresponding parameters specified by behavior. The new function object has internal slots whose names are the elements of internal slots list, and an internal slot. Set func to protot, set func to true, set func to realm, set func to null. 0. Perform set function length, func, length 1. If prefix is not present, then a perform set function name, func, name 12. Else, a perform set function name, func, Name, prefix 13. Return func. Each built-in function defined in this specification is created by calling the create built-in function abstract operation. 0.4 Built-in exotic object internal methods and slots. This specification defines several kinds of built-in exotic objects. These objects generally behave similar to ordinary objects except for a few specific situations. The following exotic objects use the ordinary object internal methods except where it is explicitly specified otherwise below. 0, 4, 1 Bound function exotic objects. A bound function exotic object is an exotic object that wraps another function object. A bound function exotic object is callable. It has an internal method and may have an internal method. Calling a bound function exotic object generally results in a call of its wrapped function. An object is a bound function exotic object if its and, if applicable, internal methods use the following implementations, and its other essential internal methods use the definitions found in 10.1. These methods are installed in bound function create. Bound function exotic objects do not have the internal slots of ECMAScript function objects listed in Table 30. Instead, they have the internal slots listed in Table 31, in addition to and Table 31, internal slots of bound function exotic objects. Internal slot. Type. Description. Bound target function. A callable object. The wrapped function object. Bound this. An ECMAScript language value. The value that is always passed as this value when calling the wrapped function. Bound arguments. A list of ECMAScript language values. A list of values whose elements are used as the first arguments to any call to the wrapped function. 186. ECMA International 2024. 10411. This arguments list. The internal method of a bound function exotic object f takes arguments this argument, an ECMAScript language value, and arguments list, a list of ECMAScript language values, and returns either a normal completion containing an ECMAScript language value or a throw completion. It performs the following steps when called. Let target be f, let bound this be f, let bound args be f, let args be the list concatenation of bound args and arguments list. Return. Call. Target. Bound this. Args 0, 4, 1, 2. Arguments list. New target. The internal method of a bound function exotic object f takes arguments list, a list of ECMAScript language values, and new target, a constructor, and returns either a normal completely on containing an object or a throw completion. It performs the following steps when called. Let target be f, assert, is constructor, target, is true. Let bound args be f, let args be the list concatenation of bound args and arguments list. If same value, f, new target, is true. Set new target to target. Return. Construct, target, args, new target. 0, 4, 1, 3 Bound function create. Target function. Bound this. Bound args. The abstract operation bound function create takes arguments target function, a function object. Bound this. An ECMAScript language value. And bound args. A list of ECMAScript language values. And returns either a normal completion containing a function object or a throw completion. It is used to specify the creation of new bound function exotic objects. It performs the following steps when called. Let proto be target function. Let internal slots list be the list concatenation of, and the internal slots listed in Table 31. Let obj be make basic object. Internal slots list. Set obj to proto. Set obj as described in 10, 4, 1, 1. If this constructor, target function, is true, then a set obj as described in 10, 4, 1, 2. Set obj to target function. Set obj to bound this. Set obj to bound args 0. Return obj 0, 4. To array exotic objects. An array is an exotic object that gives special treatment to array index property keys. C6, 1, 7. A property whose property name is an array index is also called an element. Every array has a non-configurable length property whose value is always a non-negative integral number whose mathematical value is strictly less than 32. The value of the length property is numerically greater than the name of every own property whose name is an array index, whenever a known property of an array is created or changed. Other properties are adjusted as necessary to maintain this invariant. Specifically, whenever a known property is added whose name is an array index, the value of the length property is changed, if necessary, to be one more than the numeric value of that array index. And whenever the value of the length property is changed, every own property whose name is an array index whose value is not smaller than the new length is deleted. This constraint applies only to own ECMA International 2024 187 properties of an array and is unaffected by length or array index properties that may be inherited from its prototypes. An object is an array exotic object, or simply, an array, if its internal method uses the following implementation, and its other essential internal methods use the definitions found in 10.1. These methods are installed in array create 0, 4, 2, 1, p, desc, the internal method of an array exotic O. Bjector takes arguments p, a property key, and desc, a property descriptor, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. If p is length, then a return array set length a desc. Else if p is an array index, then a let length desc be ordinary get own property a length b assert is data descriptor length desc is true c assert length desc is false d let length be length desc e assert length is a non-negative integral number f let index b 32 p g if index length and length desc is false, return false h let succeeded b. Ordinary define own property a p desc I have succeeded is false, return false j if index length, then I set length desc to index plus 1 2. Set succeeded to. Ordinary define own property a length desc 3. Assert succeeded is true k return true return. Ordinary define own property a p desc 0 4 2 to array create length proto. The abstract operation array create takes argument length, a non-negative integer, and optional argument proto an object, and returns either a normal completion containing an array exotic object or a throw completion. It is used to specify the creation of new arrays. It performs the following steps when called. If length 232 1, throw a range error exception. If proto is not present, set proto to %array prototype %. Let a be make basic object. Set a to proto. Set a is specified in 1 0 4 2 1. Perform. Ordinary define own property a length property descriptor length true false false. Return a 0 4 2 3 array species create original array length. The abstract operation array species create takes arguments original array, an object, and length, a non-negative integer, and returns either a normal completion containing an object or a throw completion. It is used to specify the creation of a new array or similar object using a constructor function that is derived from original array. It does not enforce that the constructor function returns an array. It performs the following steps when called. Let is array be is array original array. If is array is false, return array create length. Let c be get original array constructor. If is constructor c is true, then 88 ECMA International 2024. A let this realm be the current realm record. B let realm be get function realm c. See if this realm and realm are not the same realm record, then I have same value c. Realm is true. Set c to undefined. If c is an object, then I set c to get c at species. B if c is null, set c to undefined. If c is undefined, return array create length. If this constructor c is false, throw type e raw exception. Return construct c length 0 4 2 4 array set length a desc. The abstract operation array set length takes arguments a, an array, and desc, a property descriptor, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. If desk does not have a field, then a return. Ordinary define known property a length desk. Let new len desk be a copy of desk. Let new len be 32 desk. Let number len be to number desk. If same value 0, new len number len is false. Throw a range error exception. Set new len desk to new len. Let old len desk be ordinary get own property a length assert is data descriptor. Old len desk is true. Assert old len desk is false. 0. Let old len be old len desk. 1. If new len old len, then a return. Ordinary define known property a length new len desk. 2. If old len desk is false, return false. 3. If new len desk does not have a field or new len desk is true, then a let new writable be true. 4. Else a note setting the attribute to false is deferred in case any elements cannot be deleted. B let new writable be false. C set new len desk to true. 5. Let succeeded be ordinary define known property a length new len desk. 6. If succeeded is false, return false. 7. For each own property keep P of a such that P is an array index and 32 P new len in descending numeric index order. Do a let delete succeeded b a p b. If delete succeeded is false, then I set new len desk to 32 p plus 1 2. If new writable is false, set new len desk to false. 3. Perform ordinary define known property a length new len desk. 5. Return false. 8. If new writable is false, then assert succeeded to ordinary define known property a length property descriptor false. B assert succeeded is true. 9. Return true. Note if original array was created using the standard built-in array constructor for a realm that is not the realm of the running execution context, then a new array is created using the realm of the running execution context. This maintains compatibility with web browsers that have historically had that behavior for the array prototype methods that now are defined using array species create. ECMA International 2024 189. Note, in steps 3 and 4, if desk is an object then its value of method is called twice. This is legacy behavior that was specified with this effect starting with the second edition of this specification. 0, 4, 3 string exotic objects. A string object is an exotic object that encapsulates a string value and exposes virtual integer index data properties corresponding to the individual code unit elements of the string value. String exotic objects always have a data prop, RTY named length, whose value is the length of the encapsulated string value. Both the code unit data properties and the length property are non-writable and non-configurable. An object is a string exotic object, or simply, a string object, if its and internal methods use the following implementations, and its other essential internal methods use the definitions found in 10.1. These methods are installed in string create. String exotic objects have the same internal slots as ordinary objects. They also have an internal slot 1 0, 4, 3, 1, p. The internal method of a string exotic object s takes argument p, a property key, and returns a normal completion containing either a property descriptor or undefined. It performs the following steps when called. Let desk be ordinary get own property s p. If desk is not undefined, return desk. Return string get own property s p 0, 4, 3, 2 p desk. The internal method of a string exotic object s takes arguments p, a property key, and desk, a property descriptor, and returns a normal completion containing a boolean. It performs the following steps when called. Let string desk be string get own property s p. If string desk is not undefined, then a let extensible be s. B return is compatible property descriptor extensible desk string desk. Return ordinary define known property s p desk 0, 4, 3, 3. The internal method of a string exotic object O takes no arguments and returns a normal completion containing a list of property keys. It performs the following steps when called. Let keys be a new empty list. Let str be O, assert. Str is a string. Let len be the length of str for each integer I such that 0 len. In ascending order, do a append to string I to keys for each own property key p of O such that p is an array index and to an integer or infinity p len. In ascending numeric index order, do a append p to keys for each own property key p of O such that p is a string and p is not an array index. In ascending chronological order of property creation, do a append p to keys. 90. ECMA International 2024 8. For each own property key p of O such that p is a symbol. In ascending chronological order of property creation, do a append p to keys. 9. Return keys 0, 4, 3, 4 string create value prototype. The abstract operation string create takes arguments value, a string, and prototype, an object, and returns a string exotic object. It is used to specify the creation of new string exotic objects. It performs the following steps when called. Let S be make basic object. Set S to prototype. Set S to value. Set S tie. As specified in 1 0, 4, 3, 1. Set S as specified in 1 0, 4, 3, 2. Set S as specified in 1 0, 4, 3, 3. Let length be the length of value. Perform. Define property or throw S length. Property descriptor length false. Enumerable false. False. Return S 0, 4, 3, 5 string get own property S P. The abstract operation string get own property takes arguments S, an object that has an internal slot, and P, a property key, and returns a property descriptor or undefined. It performs the following steps when called. If P is not a string, return undefined. Let index be canonical numeric index string P. If index is undefined, return undefined. If is integral number int x is false, return undefined. If index is -0, return undefined. Let str be s. Assert str is a string. Let len be the length of str. If r int x 0 or len r int x, return undefined. 0. Let result str be the substring of str from r int x to r index +1 1. Return the property descriptor result str false, true, false, 0, 4. 4 arguments exotic objects. Most ECMAScript functions make an arguments object available to their code. Depending upon the characteristics of the function definition, its arguments object is either an ordinary object or an arguments exotic object. An arguments exotic object is an exotic object whose array index properties map to the formal parameters bindings of an invocation of its associated ECMAScript function. An object is an arguments exotic object if its internal methods use the following implementations, with the ones not specified here using those found in 10.1. These methods are installed in create mapped arguments object. Arguments exotic objects have the same internal slots as ordinary objects. They also have an internal slot. Ordinary arguments objects also have an internal slot whose value is always undefined. For ordinary argument objects, the internal slot is only used by object prototype to string 2 0, 1, 3, 6 to identify them as such. Note 1. While creating mapped arguments object is grouped into this clause, it creates an ordinary object, not an arguments exotic object. ECMA International 2024 191. Note 2. The integer index data properties of an arguments exotic object whose numeric name values are less than the number of formal parameters of the corresponding function object initially share their values with the corresponding argument bindings in the function's execution context. This means that changing the property changes the corresponding value of the argument binding and vice versa. This correspondence is broken if such a property is deleted and then redefined, or if the property is changed into an accessor property. If the arguments object is an ordinary obj, CT, The values of its properties are simply a copy of the arguments passed to the function, and there is no dynamic linkage between the property values and the formal parameter values. Note 3. The parameter map object and its property values are used as a device for specifying the argument's object correspondence to argument bindings. The parameter map object and the objects that are the values of its properties are not directly observable from ECMAScript code. An ECMAScript implementation does not need to actually create or use such objects to implement the specified semantics. Note: for ordinary arguments, objects define a non-configurable accessor property named callee, which throws a type error exception on access. The callee property has a more specific meaning for arguments exotic objects, which are created only for some class of non-strict functions. The definition of this property in the ordinary variant exists to ensure that it is not defined in any other manner by conforming ECMAScript implementations. Note: 5. ECMAScript implementations of arguments exotic objects have historically contained an accessor property named caller. Prior to ECMAScript 2017, the specification included the definition of the throwing caller property on ordinary arguments objects. Since implementations do not contain this extension any longer, ECMAScript 2017 dropped the requirement for a throwing caller accessor. 0441p. The internal method of an argument's exotic object args takes argument p, a property key, and returns a normal completion containing either a property descriptor or undefined. It performs the following steps when called. Let desc be ordinary get own property, args p. If desc is undefined, return undefined. Let map be args, let is mapped be. Has own property, map p. If is mapped is true, then a set desc to get map p6. Return desc 0442 p desc. The internal method of an argument's exotic object args takes arguments p, a property key, and desc, a property descriptor, and returns a normal completion containing a boolean. It performs the following steps when called. Let map be args, let is mapped be. Has own property, map p. Let new arg desc be desc. If is mapped is true and is data descriptor, desc, is true, then if desc does not have a field, desc has a field, and desc is false, then I set new arg desc to a copy of desc 2. Set new arg desc to get map p. Let allowed be ordinary define own property args p. New arg desc 92 ECMA International 2024 6. If allowed is false, return false. If is mapped is true, then if is accessor descriptor desc is true, then I perform map p. Be else if desc has a field, then assert the following set will succeed. Since formal parameters map ed by arguments objects are always writable, perform set map p desc false 2. If desc has a field and desc is false, then perform map p8. Return true 0443. The let map be args, let is mapped be. Has own property, map p. If is mapped is false, then a return ordinary get args p. Receiver 4. Else a assert map contains a formal parameter mapping for p. P return get map p 0444. The if same value args receiver is false, then a let is mapped be false. Else a let map be args b let is mapped be. Has own property map p. If is mapped is true, then a assert the following set will succeed. Since formal parameters mapped by arguments objects are always writable, b perform set map p v false return ordinary set args p v receiver 0445 p. The internal method of an argument's exotic object args takes argument p, a property key, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Let map be args, let is mapped be. Has own property, map p. Let result be ordinary delete args p. If result is true and is mapped is true, then a perform map P5. Return result. ECMA International 2024 193 1044 create and mapped arguments object arguments list. The abstract operation create and mapped arguments object takes arguments list, a list of ECMAScript language values, and returns an ordinary object. It performs the following steps when called. Let len be the number of elements in arguments list. Let obj be ordinary object create, %object prototype %set obj to undefined. Perform. Define property or throw, obj, length, property descriptor, len, true, enumerable, false, true, let index be 0. Repeat. While index, len, let val be arguments list. Index be perform. Create data property or throw, obj, to string, index, val, c set index to index plus 1. Perform. Define property or throw, obj, at iterator, property descriptor, %array prototype values true, false, label, true. Perform. Define property or throw, obj, callee, property descriptor, %throw type error false, false. Return obj 0, 4, 4, 7 create mapped arguments object, func, formals, arguments list, env. The abstract operation create mapped arguments object takes arguments func, an object, formals, a parse node, arguments list, a list of ECMAScript language values, and env, an environment record, and returns an arguments exotic object. It performs the following steps when called. Assert. Formals does not contain a rest parameter, any binding patterns, or any initializers. It may contain duplicate identifiers. Let len be the number of elements in arguments list. Let obj be make basic object. Set obj as specified in 10, 4, 4, 1. Set obj as specified in 10, 4, 4, 2. Set obj is specified in 10, 4, 4, 5. Set obj to %object prototype %0. Let map be ordinary object create, null 1. Set obj to map 2. Let parameter names be the bound names of formals 3. Let number of parameters be the number of elements in parameter names 4. Let index be 0, 5. Repeat. While index, len, let val be arguments list. Index be perform. Create data property or throw, obj, to string, index, val, c set index to index plus 1, 6. Perform. Define property or throw, obj, length, property descriptor, len, true, false, true 7. Let map names be a new empty list 8. Set index to number of parameters 1, 9. Repeat. While index 0, 94. ECMA International 2024. A, B, C. Let name be parameter names. Index. If map names does not contain name, then I append name to map names 2. If index, len, then let G be make arg getter, name, env. Let P be make arg setter, name, env. Perform map. To string, index, property descriptor get, G, false, true set index to index 1, 20. Perform. Define property or throw, obj, at iterator, property descriptor, %array prototype values true, false, true 1. Perform. Define property or throw, obj, callee, property descriptor, func, true, false, true 2. Return obj 0, 4, 4, 7, 1 make arg getter, name, env. The abstract operation make arg getter takes arguments name, a string, and env, an environment record, and returns a function object. It creates a built-in function object that when executed returns the value bound for name and env. It performs the following steps when called. Let getClosure be a new abstract closure with n, o parameters that captures name and env and performs the following steps when called. A return env get binding value, name, false. Let getter be create built-in function, getClosure, 0. Note: getter is never directly accessible to ECMAScript code. Return getter.
the whole, I don't know. I think the mic was too loud the whole time. The position, independent code, and the relative position code. It seems kind of pointless because either way, the linker has to compute the address. And it's like redundant. Because if you have like a data structure, even if you change the base, it's not totally redundant. Okay, no, I get it now. But for an exe, it says at the base, and the relative address is the same. I don't know. That's probably why they use default relative at the top. Because either way, then you're good. You don't have to think about it. But you do. But you don't. Because if you're using relative addressing, Windows won't let you just access another program's virtual page memory. Which doesn't make sense. Huh. It can't be both at the same time, but somehow it is. What? I gotta ask chatbot to figure this out.
Each program gets its own paged virtual location in memory, correct? OK, and a DLL is used across multiple programs. Each program gets its own paged virtual location in memory, correct? Yes, you are correct. Each program gets its own paged virtual address space in memory. Let's break this down in more detail to understand how memory management works in modern operating systems, especially in the context of virtual memory. OK, and a DLL is used across multiple programs. Yes, exactly. A dynamic link library, DLL, is designed to be shared and used by multiple programs. This is one of the primary benefits of using DLLs. Let me explain how this works. So a DLL is used across multiple programs, and each program has its own exclusively paged addressable memory space. Yes, exactly. Let's clarify this in more detail. So each program is safe, because when addressing it always pertains to its own exclusive address space, and does not access the virtual paged address space of another program. So each program is safe, because when addressing it always pertains to its own exclusive paged address space, and does not access the virtual paged address space of another program. Exactly. You've got it. Each program is safe and isolated because of the way virtual memory and paging work. Here's how it all fits together to ensure safety and security for each program.
Then how is a DLL able to use position independent code, relative addressing, if each program has its own exclusive page address space? If each program can only access its own memory address because it's exclusive to its own program for safety and security, if every program is unable to access another program, how is it possible for a DLL to access any program? Because a DLL would be like trashing the address space of another paged. I need some water. It'd be trashing the address space of another virtual paged program. Well, not trashing. It could trash because it's like going between programs, accessing multiple pages when each program is designed to only access its own memory, which like breaks the entire rule of virtual address spacing. So how is it possible? Like, both can't be true.
How is a DLL able to access any program's address space if every program is isolated to its own paged virtual address for security?
Does that mean the program leaves execution, jumps to a DLL, and then jumps back, so DLL is only used once at a time? Or does the program stop executing, and is there a stack behind the scenes that pushes the address of a program waiting to be executed, and is a DLL on a separate thread, or not execution unit because there's only one? Well, it depends on CPU. And is a DLL on a separate, I'll just call it thread, but a thread belongs to a program. Therefore, is a DLL a program that's able to access other programs? It can't be both at the same time, which is why default relative makes sense. And then it's like, wait a second, none of this makes any sense. Because it can't all be true. Unless something's totally fake. Which is what I'm trying to figure out. Because if the linker resolves things when it links the program, it might as well just link it every month 11 time. Because this doesn't seem very efficient. It seems redundant. It's like a concept that's half-assed and not fully followed through. And how the fuck can a program access another program if they all have their own address space? Is there like a program address and then an address space of that program? Which means that if it had a stack of programs waiting to use a DLL, it'd be like a 64-bit or however many programs. Maybe there's like the computer only runs, if the computer supports 256 programs, would that mean it's 64 bits plus a byte to access an address when you call DLL? Because how can the DLL exist to be used if it's in a different address space? I don't know, I'm gonna ask chatbot. And I think I'll just like leave default relative and I won't think about this because I don't know if when making or using link, whatever, in the developer command prompt, it makes exe, which means it's pick code, position independent code. Pick's also a processor. I don't know. Shortening things like 3 letters is confusing because it can mean many things. But then it means that this also has relative offsetting, which means that the relative offset would be 0, right? Because if it had an offset and you applied a relative offset to its already offset location in memory, when it is position independent, you're going to end up accessing memory past the current location that is at in memory. It can't be both position independent and position dependent code at the same time, which is why it's freaking, I don't get it. Something doesn't add up. It doesn't make sense. Something's missing. I have to figure out what the difference is. Something is off. I'm not gonna like invest time into committing this as something I know if I don't know. I'm not just gonna like believe all willy-nilly. 32-bit code, I don't know. I never used DLLs. I did. I don't know, this is different. 64-bit. It's a shit show. I don't know, this stuff makes no sense. It's not even 64-bit. It's a 40-bit, 48-bit address. It's just stupid. So I don't know, I'm gonna ask chat about this. I'm gonna try to figure this out. And I'm like, try to write some code, whatever. This is taking too long.
How is a DLL able to access any program's address space? If every program is isolated to its own paged virtual address for security, does a program jump to a DLL to execute it? So only one program can execute a DLL at a time, or does a program halt and push an address to a stack? Then a separate thread will grab and run whatever program address that's on the stack to execute it in bunches. But then a thread belongs to a process, which belongs to a program, which means that a DLL is a program that has the magical ability to access the address space of other programs. orders a program halt, and push an address to a stack. Then a separate thread will grab and run whatever program address that's on the stack to execute it in bunches, but then a thread belongs to a process, which belongs to a program. Which means that a DLL is a program and is itself its own actual paged virtual address space that those other programs using it are not able to access, that has the magical ability to access the address space of other programs. A DLL is then a program and has the magical ability to access the address space of other programs when it's not supposed to be able to access the memory across other virtual paged program address spaces. Excellent question. You're diving into the heart of how DLLs work, and you're very close to putting the pieces together. The key is this: a DLL does not have its own independent process or address space. A DLL inherits the address space of the program, process, that loads it. Let me explain step by step. When a program loads a DLL, where is the DLL stored at? Is it a file? Great question. Yes. When a program loads a DLL, it comes from a file on disk, and then it is mapped into memory by the operating system. Here's the full breakdown. And the linker does this so-called mapped into memory, as you say. Excellent follow-up, and it's a very important distinction. No, the linker does not map the DLL into memory. The operating system's loader does that at runtime. Let's clearly separate what the linker does versus what the loader does. Brain 2. What the loader does at runtime. The loader is part of the operating system, like NTDLL, DLL and parts of kernel 32 DLL. It runs when you launch a program and does the actual mapping into memory. Reads the exes import table to see what DLLs are needed. Finds the DLL files. For example, user 32 DLL, my plugin DLL. Maps the contents into the program's virtual memory. Usually, resolves all imports, function addresses, and updates the IAT. 6. If needed, Applies relocations if the DLL couldn't be loaded at its preferred base address. Relocations if the DLL couldn't be loaded at its preferred base address.
Okay, so a DLL is supposed to be used by multiple programs, but Chatbot says that each program is isolated to its own virtual address space, and when it starts up and is loaded, it loads the DLL from the hard drive, which is the slowest process of getting something, and then it maps it to memory, and it resolves the base address and all the addresses. And if it can't get the base address it wants, then it applies whatever, it resolves it, which probably means relative addressing, which means that a DLL having relative addressing is absolutely, completely pointless, because computationally, it's loading this DLL, from the fucking hard drive. Every fucking program has a duplicate of the same DLL across every single program that is using it, unless it modifies it, which it will do if it makes a position-dependent code. And when it does, it'll save it to that program exclusively. So each program will get its own copy with the address applied, so it modifies the original code. So each program has its own copy with its own position-dependent code, because each program may be at a different base address. But even if the DLL used position-independent coding, that means that each one would be at an offset of like 10, 15, 20 from the base. The base would rely on the program. So each program has its own base or whatever, right? But it still has to compute the address offsets, because it says that the linker has to apply the base and also another whatever. But that means that each program has a copy of the DLL, and it's the same exact copy because it doesn't apply position-dependent code when it's position-independent code, which means it's even more pointless, because then not only does every single program copy from a physical file the DLL on start, and then waste space in its own address space, it means that every single program is not only wasting space in its own address space, but it's also holding an exact same copy of the code that's completely wasted, that's computed the same way. Like, this is stupid as fuck. These people are dumb. This stuff is stupid. All this stuff makes no sense. This is so stupid. Okay, so overall, I will be using default relative, so I don't have to think about it, because it's stupid. Either way, it's the same fucking thing. And if it's hidden behind the scenes, then I'm just gonna use default relative. I don't know. I don't want to think about it anymore. This stuff's dumb. So I'm gonna ask Chatbot this big ass question. It's not even like full sentences. I don't know. This is a mess of a question. I'm just gonna ask anyways, and then I'm gonna try to write some stupid code.
So the DLL is not shared by multiple programs. It is always loaded into memory from a file that is held via permanent storage in the loader. It still needs to resolve the addresses. Because you said applies relocations if the DLL couldn't be loaded at its preferred base address, so what is the point of position-independent code? If every program has its own copy of a DLL loaded to its own address space, wasting memory for each paged virtual program address space that uses a copy of said DLL. How is there a point in position-independent code? If IT needs to be resolved when it is loaded, since addressing still needs to be applied to IT, when IT is loaded for use, IT is only relative to that program. IT still takes the same time to compute the addresses, does it not?
I really like chatbot's response to this. This is why, and I'm totally serious, the modern operating system will be obsolete in a few years. It's going to go away. It's going to be replaced with something new. When? I can't say. But it will happen. The modern OS will go poo-poo. Goodbye. Because the modern OS is shit. So I don't know, here's what chatbot says.
Finally, you've hit the core of how modern memory management and position-independent code, PIC, work.
Do you see the word modern? The word modern.
Modern memory management. Core of how modern. Modern. So what is the point of position-independent code? If every program has its own copy of a DLL loaded to its own address space, wasting memory for each paged virtual program address space that uses a copy of said DLL. How is there a point in position-independent code if IT needs to be resolved when it's as loaded, since addressing still needs to be applied to IT?
The only way that position-independent code would make sense in the case of a DLL is if a DLL was shared among programs in the same address space or an isolated address space that's protected by the OS, except the modern operating system can't separate data from code because of the memory model it uses, which is a whole other thing, but it could be simulated if it was set up correctly. The only way that position-independent code would work for a DLL is if a DLL existed in one place in RAM, loaded up in RAM, never from the hard drive, just always in the RAM, unless it had to be paged because of not enough RAM. Then in that case, it would have to be loaded up and used, but only if it's used once. And it like sat in memory, so it doesn't have to be fetched and loaded up ever once it's been loaded up once, only if there's enough memory. If there's not, then it would have to be loaded more than once, whatever. But then that way, it would like reside in RAM, and it could run independently like a thread, let's say. Technically, I don't know. This is a lot of context, the wording I'm using, based on how things are technically defined. So technically, if there was a separate thread that was running constantly, it could process the DLL, and each program could pass an address on a stack, or the DLL could jump around between programs. And programs could wait, or programs could jump to and jump back from. But then there's one instance of a DLL. Each one is using it, and it's not even a copy, it's its own instance. And then it can use position-independent code to calculate the offset to store it back to that program. So it would be able to run across multiple programs at the same time, but not really at the same time, but kind of like it, but more efficiently. Like, that's what it sounds like it does, but that's not what it does. Instead, it loads it from a file the slowest way to get something, and then it keeps it in memory the whole time, but for every process. So every process gets its own copy and has to recompute it every time, which means there's no point in position-independent code, because it says that when a program starts, that's when it's locked in as its position-independent offset as the program's running or whatever. Which means position-independent code is completely pointless from a technological level. But from a programmer view, it might make it easier because you're dealing with smaller numbers. But technologically, at the technical level, they don't know what the fuck they're doing. Well, they do know what they're doing, but they misword it and they make it seem like other things when in fact it's like a worst case scenario that you wouldn't ever expect because it doesn't sound like it does what it is, because it's not. It's nothing the way it sounds. It's all sales and making things sound good. It's all fake and stupid. That's why the modern OS will be obsolete soon. Well, maybe not soon. One day. Because this is ridiculous. It's just stupid. If a real OS came out and it didn't do this, imagine how much faster, efficient, how much battery, power, computation would all be saved. It would be beautiful. This is a nightmare. I'm tired of reading about it. And then to say the word
Modern.
for fuck's sake, it's like another word for lazy or horizontally challenged.
Finally, you've hit the core of how modern memory management and position-independent code, pick, work, and your frustration is understandable. Let's untangle this, because yes, everything you're asking does make sense, and yes, there's a point to it, but it's subtle and built around efficiency, security, and flexibility. Efficiency, security, and flexibility.
Well, it's not.
Tick. Let's address your questions in order. Red question mark. 1. Is the DLL always loaded into memory from a file on disk? Yes. The first time a DLL is needed, the OS loads it from disk, permanent storage. However, if another program already has it loaded, and conditions allow, the OS can share parts of it, especially the Dart text, code section, across processes. Small orange term. This sharing happens through physical memory pages, while each process has its own virtual mapping. The back-end physical memory can be shared, which saves real memory.
Which means that each program doesn't have its own isolated address space. It can't be true at the same time. And if it's true that the OS can share parts, does it share parts? Because I don't know. Because right here, whatever. To like load a DLL or whatever for Windows to compile it. This DLL, to get the DLL, it involves a file path. C programs, Windows, blah 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 here. I guess a library isn't a DLL. Well, what the fuck is the point of a library in a DLL? They're all the same fucking thing. This is also pointless. It's just the same thing with a different file ending and different rules when it could all be broken down to a simple, pure solution. But no, it's not. It's just a shit show with a bunch of made up files and data structures and pointless. Yeah, it doesn't matter, whatever. I guess that's where the money is. And making fake things and then building off it and continuing to build off it and teach other people to build off of fake. Okay, so this is a file path. Does that mean wherever it is in here, does it mean that this file is physically mapped to a page place in physical memory in the RAM? Because that is what chatbot is applying or implying by saying the OS can share parts. That's what it's implying. It's implying that the OS is physically mapping memory to a file, which I very highly doubt. I can't argue with chatbot. This all sounds like bullshit. I'm gonna argue a tiny bit more. I don't know, I think I got it figured out now. Like right here.
While each process has its own virtual mapping, if two DLLs want to load at the same base, one must be relocated. Relocation means the loader must rewrite absolute addresses inside the DLL. While each process has its own virtual mapping, his sharing happens through physical memory pages. The back-end physical memory can be shared. And conditions allow.
Okay, so I'm gonna ask chatbot. This is all contradictory. Because you type in a file address to like find a DLL or whatever. You know, I'm just gonna ask. I can't explain it. It's this pointless. I'm gonna argue with chatbot for another second. Then I'm gonna give up arguing, and I think I figured it out. Well, I have figured out. I mean, like the overall, the bigger picture. I figured that out. Alright, so let's chat about this.
So you were saying that C uses potato program files calculator compute something DLL that the file itself will be physically mapped to the RAM. Yes, you're exactly right. And here's the clearer version of what's happening. Tick. The code and read-only data sections of a DLL are physically mapped into RAM directly from the file on disk. Using memory mapped I/O, let's walk through what this means in simple but precise terms. Small blue diamond, yes. The DLL file is mapped into RAM, but not copied when a DLL like makefile copy edit uses potato program files calculator compute something DLL is loaded by a program. Windows doesn't copy its contents byte by byte into RAM instead. The OS does something way smarter. Tick. It uses memory mapped files. A kernel feature. This means the OS creates a virtual memory mapping of the DLL file. Sections like Dart text, code Dart data, read-only data, and Dart data, writable data, are mapped directly into the program's address space. The actual content is loaded from the file lazily. As pages are accessed, they're brought into RAM. Brain. You can think of it like the OS says, this part of your memory corresponds to this part of the file. The actual content is loaded from the file lazily. As pages are accessed, they're brought into RAM. The actual content is loaded from the file lazily. As pages are accessed, they're brought into RAM. Is loaded from the file lazily. 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 Is loaded from the file. Is loaded from the file lazily. The code pages are the main ones that get physically shared across processes. If a DLL is compiled as PIC and does not need relocation, the code remains pure and shareable. Fire. Key benefit. No extra copying. Multiple programs that use the same DLL will have that DLL mapped at different virtual addresses, but they all share the same physical memory pages for the code. Saving RAM. This is possible only because of memory mapping and PIC. So the OS keeps a list of all the string-accessed file locations, and where in RAM that they are lazily loaded into what part of the OS keeps this list of string file paths, and then it is true. Then that each program will compete to execute a DLL. Since it is shared across multiple programs, pages address spaces that are not accessible to other programs except in the case of a DLL, meaning that the address space is not isolated or secure because everything can actually access anything if it is able to bypass the MMU, or if there is a buffer overflow in a DLL and things leak or escape, then run code outside. In the case of a DLL, meaning that the address space per running program is not isolated or secure because everything can actually access anything, since parts are backed by real RAM, then are mapped to the virtual and could possibly bypass the MMU, or if there is a buffer overflow in a DLL and things leak or escape. You're asking some very advanced and insightful questions, and you're pressing into real OS design, memory management, and security architecture. Let's tackle this clearly and honestly.
Really wish there was a new OS. Maybe one day.
Small blue diamond Q1, does the OS keep a list of all mapped files and where they're in RAM? Tick. Yes, it does, but not as a simple string list. The OS, like Windows or Linux, keeps internal kernel data structures that track which files, for example, DLLs or executables, are currently memory mapped, which sections of those files are mapped to which virtual addresses in each process, which physical memory pages are backing those mappings, whether a page is shared, read-only, copy on write, etc.
Right here.
Which sections of those files are mapped to which virtual addresses in each process.
Which means that every single program has its own copy, or at least its own. There are copies of copies of copies, even if it's not the DLL itself, which it most likely is. I don't believe any of this.
This is not done using strings, but by using file objects in kernel memory, page tables, MMU mappings, section objects and control area structures, Windows internals. So yes, the OS knows exactly which part of which file is in memory, and where, across all processes, but it's implemented with complex, low-level kernel structures and file handles, not a lookup table of strings.
Then how does it know what string relates to which DLL if it doesn't contain a lookup of the string itself? Contain a map? Contain what string? What? Never mind, it doesn't matter. It's whatever.
Small blue diamond Q2. Does this sharing break process isolation or security? Crossmark no. It absolutely does not break memory isolation. Crossmark no. It absolutely does not break memory isolation. This is key to understand. Even though processes can share the same physical memory pages, like DLL code, the MMU enforces access control strictly per process. Each process still has its own virtual address space, its own page tables, managed by the kernel, strict read-write execute permissions per page. So when program A calls a function in a DLL, it's executing its own virtual mapping of that DLL. Program B does the same, but in its own mapping, they cannot directly access each other's memory or mappings, even though the backing physical memory pages might be the same. Closed lock with key. This physical memory sharing is completely safe and controlled, because the MMU, Memory Management Unit, only translates virtual addresses using the current process's page table.
Unless function A calls a function in a DLL, then it changes the address that's passed to the MMU, because you're now outside of the address space unless you're backed by physical memory, which can't access the other parts of memory.
Fire, Q3, could a vulnerability, like a buffer overflow, in a DLL break isolation? Tick, yes. Within the same process, if a DLL has a buffer overflow bug, and your program uses it, then that bug can corrupt memory inside your own process.
Unless, and then they have an unless.
But it cannot leak into another process, unless the attacker is already exploiting inter-process mechanisms. There is shared memory, deliberately set up. A privileged process is targeted via other OS exploits. So, DLL bugs are a threat to the calling program, but not a direct threat to other processes, because of virtual memory isolation. The DLL runs inside the process that loaded it. Its code is shared, but its execution context, memory, and data are private to the process.
The overlap. There's so much overlap. It's all bullshit.
Concept.
They're explaining the technical workings of the modern operating system as a concept. They're not explaining the factual, physical, whatever. Oh, this is such bullshit.
Your intuition is right. Shared DLL code lives in physical RAM, and multiple programs can execute it simultaneously. Multiple programs can execute it simultaneously.
No, they can't. No, they can't.
But because of the MMU, page tables, and OS enforcement, each process only sees its own virtual view, and memory remains isolated and secure. Remains isolated and secure. Unless. Isolated and secure. Unless. Isolated and secure. Unless. Isolated and secure. Unless there's a security exploit.
There's more than buffer overflows. You can't say, they can't say, isolated and secure.
isolated and secure. Concept.
Based on this concept, because it's broken. The concept is broken, and physically, how it's implemented itself, the mechanisms are broken. The whole thing is broken.
Memory remains isolated and secure.
Nothing is isolated and or secure.
Unless there's a security exploit, like a buffer overflow that turns into ROP or shellcode injection, there is no way to cross into another process's memory. There is no way to cross into another process's memory.
I won't get into like hardware exploitation. I don't know. Everything's bullshit. Not modern at all. Okay, so I'm gonna like leave. Default relative as it is. And it's that simple. That's all I gotta do. And I'm gonna zero out these registers. And I finally have like a total, maybe 90% understanding of this. Chatbot made it sound like default relative, the relative address, and the RAP relative. I don't know. The way this is worded is very confusing. Because the RPI can be accessed as a base register. You know what? It doesn't matter. I'm not doing a class here. I'm just gonna get going. I don't know. I finally think I have a concept, or like the big picture of whatever. I think Chatbot did save a teeny bit of time. Or not. It's probably the same amount of time. I still gotta read. The documentation to really get an understanding of it. So I'm gonna like, I don't know, zero out the registers. There's no segment registers, but I think the base registers are still there. And then, I don't know, I'll make like a new part, a new spot in the data segment, or I'll make a BSS segment. I think a BSS segment is zeroed out by default, depending on the compiler. I gotta check. It doesn't matter if it's zeroed out. I can just zero it myself. I don't know, I'm gonna try to like write some stupid assembly I had to figure out whatever the fuck relative addressing whatever the hell relative addressing had to do. Okay, so it's rip relative. The way they word it is so confusing. I don't know. I figured it out. So now I feel safe to like access addresses and not have to think about it. Because doing this means it's covered. In either case, and the only time that I'd have to think about it is if I'm like explicitly or explicitly, however you say the word, if I'm like making a DLL specifically, is when this would matter. But then it gets more complicated, so I'm not gonna bother right now. I'm not, yeah, whatever. I don't know, BRB. I need to get some water. So, it's so late. Dang it. I have to get to parsing. I'll do like the bit test or whatever. I'm gonna have to get the time to speed test. I can't waste all day on this. I think I'll like the. I think I'll take a break, get some water, and then I'll like explain. I don't know how to get the highest bit or like a clever way, but it might not be the fastest. I don't know. It's probably not the fastest because there's an instruction for it, so it's probably not the fastest, but it's clever. I'll do that. I'll run it. I'll like have it output the result. And then that's like it, and then I'll get the parsing, whatever. And then tomorrow I'll like try to get the timer to speed test it. And that'll probably take too long. So maybe the next day I'll be able to actually speed test it. Because I can't just like, I don't know, I have to parse. Otherwise, I have to like finish parsing the rest of the code, the JavaScript engine, whatever. Otherwise, I'm not gonna want to get back to that because it's really boring. So I'll get some water and I'll BRB.
The internal method of a proxy exotic. Boolean. Call. Trap. Handler. Target. V. If Boolean trap result is false, return false. Let extensible target be. Is extensible. Target 0. If extensible target is true, return true 1. Let target prota be target 2. If same value, V, target prota, is false, throw a type error exception 3. Return true. Note for proxy objects enforces the following invariants. The result of must be either an object or null if the target object is not extensible. applied to the proxy object must return the same value as applied to the proxy object's target object. Note: for proxy objects enforces the following invariance. The result of is a Boolean value. If the target object is not extensible, the argument value must be the same as the result of get prototype of applied to target object. ECMA International 2024 205 1053. The internal method of a proxy exotic object O takes no arguments and returns either a normal completion containing a Boolean or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler is extensible. If trap is undefined, then a return is extensible. Target. Let Boolean trap result be to Boolean. Call. Trap. Handler. Target. Let target result be is extensible. Target. If Boolean trap result is not target result, throw a type error exception 0. Return Boolean trap result 0, 5, 4. The internal method of a proxy exotic object O takes no arguments and returns either a normal completion containing a Boolean or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Prevent extensions. If trap is undefined, then a return target. Let Boolean trap result be to Boolean. Call. Trap. Handler. Target. If Boolean trap result is true, then a let extensible target be is extensible. Target be. If extensible target is true, throw a type error exception. Return Boolean trap result 0, 5, 5, p. The internal method of a proxy exotic object O takes argument p, a property key, and returns either a normal completion containing either a property descriptor or undefined, or a throw completion. It performs the following steps when called. Note: for proxy objects enforces the following invariance. The result of is a Boolean value. Applied to the proxy object must return the same value as applied to the proxy object's target object with the same argument. Note: for proxy objects enforces the following invariance. The result of is a Boolean value. Applied to the proxy object only returns true if applied to the proxy object's target object is false. 2. Perform. Validate non-revoke proxy O. Let target be O. 06. ECMA International 2024 3. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Get own property descriptor. If trap is undefined, then a return target. P. Let trap result obj be. Call. Trap. Handler. Target. P. If trap result obj is not an object and trap result obj is not undefined, throw a type error exception. Let target desk be target. P. 0. If trap result obj is undefined, then if target desk is undefined, return undefined. B. If target desk is false, throw a type error exception. C. Let extensible target be is extensible. Target. D. If extensible target is false, throw a type error exception. E. Return undefined. 1. Let extensible target be is extensible. Target. 2. Let result desk be to property descriptor. Trap result obj. 3. Perform complete property descriptor. Result desk. 4. Let valid be as compatible property descriptor. Extensible target. Result desk. Target desk. 5. If valid is false, throw a type error exception. 6. If result desk is false, then if target desk is undefined or target desk is true, then I throw a type error exception. B. If result desk has a field and result desk is false, then I assert target desk has a field. 2. If target desk is true, throw a type error exception. 7. Return result desk. Note: for proxy objects enforces the following invariance. The result of must be either an object or undefined. A property cannot be reported as non-existent if it exists as a non-configurable own property of the target object. A property cannot be reported as non-existent if it exists as a known property of a non-extensible target object. A property cannot be reported as existent if it does not exist as an own property of the target object and the target object is not extensible, a property cannot be reported as non-configurable unless it exists as a non-configurable own property of the target object. A property cannot be reported as both non-configurable and non-writable unless it exists as a non-configurable, non-writable own property of the target object. 0, 5, 6, p, desc. The internal method of a proxy exotic object O takes arguments p, a property key, and desc, a property descriptor, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Define property. If trap is undefined, then a return target. P. Desc. Let desc obj be from property descriptor. Desc. Let boolean trap result be to boolean. Call. Trap. Handler. Target. P. Desc obj. If boolean trap result is false, return false. 0. Let target desc be target. P. ECMA International 2024 207. 11. Let extensible target be. Is extensible. Target. 2. If desc has a field and desc is false, then a let setting config false be true. 13. Else a let setting config false be false. 4. If target desc is undefined, then A if extensible target is false, throw a type error exception. B if setting config false is true, throw a type error exception. 5. Else A if is compatible property descriptor, extensible target, desc, target desc, is false, throw a type error exception. B if setting config false is true and target desc is true, throw a type error exception. C if is data descriptor, target desc, is true, target desc is false, and target desc is true. Then, I if desc has a field and desc is false, throw a type error exception. 6. Return true. Note for proxy objects enforces the following invariance. The result of is a boolean value. A property cannot be added. If the target object is not extensible, a property cannot be non-configurable unless there exists a corresponding non-configurable own property of the target object. A non-configurable property cannot be non-writable unless there exists a corresponding non-configurable, non-writable own property of the target object. If a property has a corresponding target object property, then applying the property descriptor of the property to the target object using will not throw an exception. 0, 5, 7, p. The internal method of a proxy exotic object O takes argument p, a property key, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. 1. Perform. Validate non-revoke proxy O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler has if trap is undefined, then a return target. P. Let boolean trap result be to boolean. Call. Trap. Handler. Target. P. If boolean trap result is false, then a let target desc be target. P. B if target desc is not undefined, then I if target desc is false, throw a type error exception. 2. Let extensible target be. Is extensible. Target. 3. If extensible target is false, throw a type error exception. Return boolean trap result. 08. ECMA International 2024. Note for proxy objects enforces the following invariance. The result of is a boolean value. A property cannot be reported as non-existent if it exists as a non-configurable own property of the target object. A property cannot be reported as non-existent if it exists as a known property of the target object, and the target object is not extensible. 0, 5, 8. The perform. Validate non-revoke proxy O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Get. If trap is undefined, then a return target. Let trap result be. Call. Trap. Handler. Target. P. Receiver. Let target desc be target. P. If target desc is not undefined and target desc is false, then if is data descriptor, target desc, is true and target desk is false, then if same value, trap result, target desk, is false. Throw a type error exception, B if is accessor descriptor, target desk, is true and target desk 0. Return trap result. Note, the value reported for a property must be the same as the value of the corresponding target object property if the target object property is a non-writable, non-configurable own data property. The value reported for a property must be undefined if the corresponding target object property is an unconfigurable own accessor property that has undefined as its 0, 5, 9. The completion. It performs the following steps when called. Perform. Validate non-revoke proxy. O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Set. If trap is undefined, then a return target. Let boolean trap result be to boolean. Call. Trap. Handler. Target. P. V. Receiver. If boolean trap result is false, return false. Let target desk be target. P. 0. If target desk is not undefined and target desk is false, then ECMA International 2024-209. If is data descriptor, target desk, is true and target desk is false, then if same value, V, target desk, is false. Throw a type error exception, B if is accessor descriptor, target desk, is true, then if target desk 1. Return true. Note, the result of cannot change the value of a property to be different from the value of the corresponding target object property if the corresponding target object property is a non-writable, non-configurable own data property. Cannot set the value of a property if the corresponding target object property is a non-configurable own accessor property that has undefined as its 0, 5, 1, 0. P. The internal method of a proxy exotic object O takes argument P, a property key, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy. O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Delete property. If trap is undefined, then a return target. P. Let boolean trap result be to boolean. Call. Trap. Handler. Target. P. If boolean trap result is false, return false. Let target desk be target. P. 0. If target desk is undefined, return true. 1. If target desk is false, throw a type error exception. 2. Let extensible target be. Is extensible target. 3. If extensible target is false, throw a type error exception. 4. Return true. Note for proxy objects enforces the following invariants. The result of is a boolean value. A property cannot be reported as deleted if it exists as a non-configurable own property of the target object. A property cannot be reported as deleted if it exists as a known property of the target object and the target object is non-extensible. 0, 5, 1, 1. The internal method of a proxy exotic object O takes no arguments and returns either a normal completion containing a list of property keys or a throw completely on. It performs the following steps when called. Perform. Validate non-revoke proxy. O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Own keys. 10. ECMA International 2024. 6. If trap is undefined, then a return target. Let trap result array be. Call. Trap. Handler. Target. Let trap result be. Create list from array like trap result array, string, symbol. If trap result contains any duplicate entries, throw a type error exception. 0. Let extensible target be. Is extensible target. 1. Let target keys be target. 2. Assert. Target keys is a list of property keys. 3. Assert. Target keys contains no duplicate entries. 4. Let target configurable keys be a new empty list. 5. Let target non-configurable keys be a new empty list. 6. For each element key of target keys, do a let desk be target key. B if desk is not undefined and desk is false, Then, I append key to target non-configurable keys. See else. I append key to target configurable keys. 7. If extensible target is true and target non-configurable keys is empty, then a return trap result. 8. Let unchecked result keys be a list whose elements are the elements of trap result. 9. For each element key of target non-configurable keys, do if unchecked result keys does not contain key, throw a type error exception, be remove key from unchecked result keys. 0. If extensible target is true, return trap result. 1. For each element key of target configurable keys, do if unchecked result keys does not contain key, throw a type error exception, be remove key from unchecked result keys. 2. If unchecked result keys is not empty, throw a type error exception. 3. Return trap result. Note: for proxy objects enforces the following invariance. The result of is a list. The returned list contains no duplicate entries. The type of each result list element is either string or symbol. The result list must contain the keys of all non-configurable own properties of the target object. If the target object is not extensible, then the result list must contain all the keys of the own properties of the target object and no other values. 0, 5, 1, 2. This arguments list. The internal method of a proxy exotic object O takes arguments this argument, an ECMAScript language value, and arguments list, a list of ECMAScript language values, and returns either a normal completion containing an ECMAScript language value or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy. O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Apply. If trap is undefined, then a return. Call. Target. This argument. Arguments list. Let argArray be create array from list. Arguments list. Return. Call. Trap. Handler. Target. This argument. argArray. Note: a proxy exotic object only has an internal method if the initial value of its internal slot is an object that has an internal method. ECMA International 2024 211. The 10th of May 2013. Arguments list. New target. The internal method of a proxy exotic object O takes arguments list, a list of ECMAScript language values, and new target, a constructor, and returns either a normal completion containing an object or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy. O. Let target be O. Assert. Is constructor. Target. Is true. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Construct. If trap is undefined, then a return. Construct. Target. Arguments list. New target. Let argArray be create array from list. Arguments list. Let new obj be. Call. Trap. Handler. Target. argArray. New target. 0. If new obj is not an object, throw a type error exception. 1. Return new obj. Note: 2 for proxy objects enforces the following invariance. The result of must be an object. 0, 5, 1 for validate non-revoke proxy. Proxy. The abstract operation validate non-revoke proxy takes argument proxy, a proxy exotic object, and returns either a normal completion containing unused or a throw completion. It throws a type error exception if proxy has been revoked. It performs the following steps when called. If proxy is null, throw a type error exception. Assert. Proxy is not null. Return unused. 0, 5, 1, 5 proxy create. Target. Handler. The abstract operation proxy create takes arguments target, an ECMAScript language value, and handler, an ECMAScript language value, and returns either a normal completion containing a proxy exotic object or a throw completion. It is used to specify the creation of new proxy objects. It performs the following steps when called. If target is not an object, throw a type error exception. If handler is not an object, throw a type error exception. Let P be make basic object. Set P's essential internal methods, except friend, to the definitions specified in 10.5. If is callable, target, is true, then A set P is specified in the 10th of May 2012. B if is constructor, target, is true, Then, I set P as specified in the 10th of May 2013. Set P to target. Set P to handler. Return P. 12. ECMA International 2024. Note 1. A proxy exotic object only has an internal method if the initial value of its internal slot is an object that has an internal method. 11. ECMAScript language. Age. Source text. 1.1 Source text syntax. Source character. Any Unicode code point. ECMAScript source text is a sequence of Unicode code points. All Unicode code point values from U plus 0000 to U plus 10FF, including surrogate code points, may occur in ECMAScript source text where permitted by the ECMAScript grammars. The actual encodings used to store and interchange ECMAScript source text is not relevant to this specification. Regardless of the external source text encoding, a conforming ECMAScript implementation processes the source text as if it was an equivalent sequence of source character values, each source character being a Unicode code point. Conforming ECMAScript implementations are not required to perform any normalization of source text, or behave as though they were performing normalization of source text. The components of a combining character sequence are treated as individual Unicode code points even though a user might think of the whole sequence as a single character. Note in string literals, regular expression literals, template literals and identifiers, any Unicode code point may also be expressed using Unicode escape sequences that explicitly express a code point's numeric value. Within a comment, such an escape sequence is effectively ignored as part of the comment. ECMAScript differs from the Java programming language in the behavior of Unicode escape sequences. In a Java program, if the Unicode escape sequence U000, for example, occurs within a single line comment, it is interpreted as a line terminator. Unicode code point U plus 000A is line feed, LF, and therefore the next code point is not part of the comment. Similarly, if the Unicode escape sequence U000A occurs within a string literal in a Java program, it is likewise interpreted as a line terminator, which is not allowed within a string literal. One must write N instead of U000A to cause a line feed, LF, to be part of the string value of a string literal. In an ECMAScript program, a Unicode escape sequence occurring within a comment is never interpreted and therefore cannot contribute to termination of the comment. Similarly, a Unicode escape sequence occurring within a string literal in an ECMAScript program always contributes to the literal and is never interpreted as a line terminator or as a code point that might terminate the string literal. 1 static semantics. UTF-16 encode code point. CP. The abstract operation UTF-16 encode code point takes argument CP, a Unicode code point, and returns a string. It performs the following steps when called. Assert 0 CP0 times 10FF. If CP0 XFF, return the string value consisting of the code unit whose numeric value is CP. Let C1 be the code unit whose numeric value is floor. CP0 times 10,000. 0 times 400 plus 0 XD800. Let Q2 be the code unit whose numeric value is CP0 times 10,000. Modulo 0 times 400 plus 0 XDC00. Return the string concatenation of Q1 and Q2. ECMA International 2024 213. 1 2 static S. Semantics. Code points to string. Text. The abstract operation code points to string takes argument text, a sequence of Unicode code points, and returns a string. It converts text into a string value, as described in 6.1.4. It performs the following steps when called. Let result be the empty string. For each code point CP of text, do a set result to the string concatenation of result and UTF-16 encode code point, CP3. Return result. 1 3 static semantics. UTF-16 surrogate pair to code point. Led. Trail. The abstract operation UTF-16 surrogate pair to code point takes arguments led a code unit, and trail, a code unit, and returns a code point. Two code units that form a UTF-16 surrogate pair are converted to a code point. It performs the following steps when called. Assert. Lead is a leading surrogate and trail is a trailing surrogate. Let CP be lead 0xd800. 0 times 400 plus trail 0xdc00 plus 0 times 10,000. Return the code point CP 1 1. For static semantics, code point at string position. The abstract operation code pointer takes argument string, a string, and position, a non-negative integer, and returns a record with fields, a code point, a positive integer, and a boolean. It interprets string as a sequence of UTF-16 encoded code points, as described in 6.1.4, and reads from it a single code point starting with the code unit at index position. It performs the following steps when called. Let size be the length of string. Assert position 0 and position size. Let first be the code unit at index position within string. Let CP be the code point whose numeric value is the numeric value of first. If a first is neither a leading surrogate nor a trailing surrogate, then return the record CP 1 full 6. If a first is a trailing surrogate or position plus 1 equals size, then return the record CP 1 true. Let second be the code unit at index position plus 1 within string. If second is not a trailing surrogate, then return the record CP 1 true. Set CP to UTF-16 surrogate pair to code point first, second 0. Return the record CP 2 false 1 1. 5 static semantics. String to code points. String. The abstract operation string to code points takes argument string, a string, and returns a list of code points. It returns the sequence of Unicode code points that results from interpreting string as UTF-16 encoded Unicode text as described in 6.1.4. It performs the following steps when called. Let code points be a new empty list. Let size be the length of string. Let position be 0. Repeat. While position, size. Let CP be code point at string position. Be append CP to code points. C. Set position to position plus CP. Return code points. 14. ECMA International 2024. 1.1.1. 6 static semantics. Parse text. Source text. Goal symbol. The abstract operation parse text takes argument source text, a sequence of Unicode code points, and goal symbol, a non-terminal in one of the ECMAScript grammars, and returns a parse node or a non-empty list of syntax error objects. It performs the following steps when called. Attempt to parse source text using goal symbol as the goal symbol, and analyze the parse result for any early error conditions. Parsing and early error detection may be interleaved in an implementation-defined manner. If the parse succeeded and no early errors were found, return the parse node, an instance of goal symbol, at the root of the parse tree resulting from the parse. Otherwise, return a list of one or more syntax error objects representing the parsing errors and/or early errors. If more than one parsing error or early error is present, the number and ordering of error objects in the list is implementation defined, but at least one must be present. Note to see also clause 17. 1.2 Types of source code. There are 4 types of ECMAScript code. Global code is source text that is treated as an ECMAScript script. The global code of a particular script does not include any source text that is parsed as part of a function declaration, function expression, generator declaration, generator expression, async function declaration, async function expression, async generator declaration, async generator expression, method definition, arrow function, async arrow function, class declaration, or class expression. Eval code is the source text supplied to the built-in eval function. More precisely, if the parameter to the built-in eval function is a string, it is treated as an ECMAScript script. The eval code for a particular invocation of eval is the global code portion of that script. Function code is source text that is parsed to supply the value of the and internal slots, C10.2, of an ECMAScript function object. The function code of a particular ECMAScript function does not include any source text that is parsed as the function code of a nested function declaration, function expression, generator declaration, generator expression, async function declaration, async function expression, async generator declaration, async generator expression, method definition, arrow function, async arrow function, class declaration, or class expression. In addition, if the source text referred to above is parsed as the formal parameters and function body of a function declaration or function expression, the formal parameters and generator body of a generator declaration or generator expression, the formal parameters and async function body of an async function declaration or async function expression, or the formal parameters and async generator body of an async generator declaration or async generator expression, then the source text match by the binding identifier, if any of that declaration or expression is also included in the function code of the corresponding function. Module code is source text, that is code that is provided as a module body. It is the code that is directly evaluated when a module is initialized. The module code of a particular module does not include any source. Note 1. Consider a text that has an early error at a particular point, and also a syntax error at a later point. An implementation that does a parse pass followed by an early errors pass might report the syntax error and not proceed to the early errors pass. An implementation that interleaves the two activities might report the early error and not proceed to find the syntax error. A third implementation might report both errors. All of these behaviors are conformant. Copyright sign, ECMA International 2024-215. Text that is parsed as part of a nested function declaration, function expression, generator declaration, generator expression, async function declaration, async function expression, async generator declaration, async generator expression, method definition, arrow function, async arrow function, class declaration, or class expression. Note 1. Function code is generally provided as the bodies of function definitions. 15.2, arrow function definitions. 15.3, method definitions. 15.4, generator function definitions. 15.5, async function definitions. 15.8, async generator function definitions. 15.6, and async arrow functions. 15.9. Function code is also derived from the arguments to the function constructor 20, 2, 1, 1. The generator function constructor 27, 3, 1, 1. And the async function constructor 27, 7, 1, 1. Note 2. The practical effect of including the binding identifier in function code is that the early errors for strict mode code are applied to a binding identifier that is the name of a function whose body contains a use strict directive, even if the surrounding code is not strict mode code. 1, 2, 1 directive prologues and the use strict directive. A directive prologue is the longest sequence of expression statements occurring as the initial statement list items or module items of a function body, a script body, or a module body, and where each expression statement in the sequence consists entirely of a string literal token followed by a semicolon. The semicolon may appear explicitly or may be inserted by automatic semicolon insertion. 12.10. A directive prologue may be an empty sequence. A use strict directive is an expression statement in a directive prologue whose string literal is either of the exact code point sequences use strict or use strict. A use strict directive may not contain an escape sequence or line continuation. A directive prologue may contain more than one use strict directive. However, an implementation may issue a warning if this occurs. 1, 2. 2 strict mode code. An ECMAScript syntactic unit may be processed using either unrestricted or strict mode syntax and semantics. 4, 3, 2. Code is interpreted as strict mode code in the following situations. Global code is strict mode code if it begins with a directive prologue that contains a use strict directive. Module code is always strict mode code. All parts of a class declaration or a class expression are strict mode code. Eval code is strict mode code if it begins with a directive prologue that contains a use strict directive, or if
I probably shouldn't start off the stream every time saying I don't give a fuck, because that kind of means I give a fuck. And if I start off swearing, I kind of just keep swearing after that. So I should probably not do that as an intro.
async generator expression.
And, because like the stream starts up, I don't know, the sound is out of whack. I gotta talk extra slow because it's like freaking, the sound is so out of sync. I can't even hear what I'm saying until the stream gets going. And it's still laggy. I don't know, this software sucks.
Sync generator constructors is strict mode code if the last argument is a string that, when processed, is a function body that begins with a directive prologue that contains.
So, I'm just gonna find the highest bit set, routine, whatever. And then I'll paste it over here, I'll convert it, and then I'll run it. And I'll explain it. And I gotta check. I'll check first, whatever. To see, I don't know, make sure like nobody else uses this technique, because I don't want to claim I thought of it if someone else documented it.
ECMAScript functions.
Because then I look stupid. Even though, I don't know, whatever.
Executable code other than ECMAScript source text. Whether a function object is defined within ECMAScript code or as a built-in function is not observable from the perspective of ECMAScript code that calls or is called by such a function object. 2. ECMAScript language. Lexical grammar. The source text of an ECMAScript script or module is first of input elements, which are tokens, line terminators, comments, or white.
I spend so much time looking stupid on purpose, so if I do look stupid, it doesn't really mean much, because I've looked stupider intentionally before the cases when I do something stupid. So like, cancels out the stupidness in a stupid way. But not really.
The capital I N P U T capital E L E M E N T capital R E G capital E X P capital O R capital T E M P L A T E capital T A. Goal is used in syntactic grammar contexts where a regular expression literal, a template middle, or a template tail is permitted. The input element regexp goal symbol is used in all syntactic grammar contexts where a regular expression literal is permitted but neither a template middle nor a template tail is permitted. The input element template tail goal is used in all syntactic grammar contexts where a template middle or a template tail is permitted but a regular expression literal is not permitted. In all other contexts, input element div is used as the lexical goal symbol. Note the use of multiple lexical goals ensures that there are no lexical ambiguities that would affect automatic semicolon insertion. For example, there are no syntactic grammar contexts where both a leading division or division assignment and a leading regular expression literal are permitted. This is not affected by semicolon insertion, see 12.10, in examples such as the following. A equals b high g exec, c map, d, where the first non-white space, non-comment code point after a line terminate.
Okay, now I'm gonna try to find whatever.
Syntactic context allows division or division assignment. No semicolon is inserted at the line terminator. That is, the above example is interpreted in the same.
I have too many tabs open. If I lose power or Windows crashes, it's gonna be a pain to reopen everything. I gotta close some of them.
regexp, white space, line terminator comment token right brace punctuate irregular expression literal. ECMA International 2024 217. Capital I N P U T capital E L E M E N T capital R E G capital E X P capital O R capital T E M P L A T E capital T, A, white space, line terminator comment token regular expression literal template substitution tail, input element template tail, white space, line terminator comment token div punctuated template substitution tail, input element hashbang or regexp, white space, line terminator comment token hashbang comment regular expression literal 2.1 Unicode format control characters. The Unicode format control characters, that is, the characters in category CF in the Unicode character database such as left to right mark or right to left mark, are control codes used to control the formatting of a range of text in the absence of higher-level protocols for this, such as markup languages. It is useful to allow format control characters in source text to facilitate editing and display. All format control characters may be used within comments, and within string literals, template literals, and regular expression literals, U plus 200C, 0 width non-joiner, and U plus 200D, 0 width joiner, are format control characters that are used to make necessary distinctions when forming words or phrases in certain languages. In ECMAScript source text, these code points may also be used in an identifier name after the first character. U plus F, 0 width no break space, is a format control character used primarily at the start of a text to mark it as Unicode and to allow detection of the text's encoding and byte order. ZWMBSP characters intended for this purpose can sometimes also appear after the start of a text, for example as a result of concatenating files. In ECMAScript source text, ZWMBSP code points are treated as white space characters. See 12.2, the special treatment of certain format control characters outside of comments, string literals, and regular expression literals is summarized in Table 35. Table 35. Format control code point usage. Code point name abbreviation usage U plus 200C 0 width non-joiner ZWNJ identifier part U plus 200D 0 width joiner ZWJ identifier part U plus FF 0 width no break space ZWNBSP white space 218 ECMA International 2024 12.2 white space code points are used to improve source text readability and to separate tokens, indivisible lexical units, from each other, but are otherwise insignificant. White space code points may occur between any two tokens and at the start or end of input. White space code points may occur within a string literal, a regular expression literal, a template, or a template substitution tail where they are considered significant code points forming part of a literal value. They may also occur within a comment, but cannot appear within any other kind of token. The ECMAScript white space code points are listed in Table 36. Table 36. White space code points. Code points. Name. Abbreviation. U plus 0009. Character tabulation. Tab. U plus 000B. Line tabulation. VT. U plus 000C. Form feed. FF, U plus FF, 0 width no break space, ZWNBSP, any code point in general category space separator, USP, no 1 U plus 0020, space, and U plus 00A0, no break space. Code points are part of USP syntax. Note 2, other than for the code points listed in Table 36. ECMAScript white space intentionally excludes all code points that have the Unicode white space property but which are not classified in general category space separator. ZEDS 2.3 white space tab VT FF ZWMBSP USP line terminators like white space code points. Line terminator code points are used to improve source text readability and to separate tokens, indivisible lexical units, from each other. However, unlike white space code points, line terminators have some influence over the behavior of the syntactic grammar. In general, line terminators may occur between any two tokens, but there are a few places where they are forbidden by the syntactic grammar. Line terminators also affect the process of automatic semicolon insertion. 12.10. A line terminator cannot occur within any token except a string literal, template, or template substitution tail, LF, and CR line terminators cannot occur within a string literal token except as part of a line continuation. A line terminator can occur within a multi-line comment but cannot occur within a single line comment. Line terminators are included in the set of white space code points that are matched by the S-class in regular expressions. ECMA International 2024-219. The ECMAScript line terminator code points are listed in Table 37. Table 37. Line terminator code points. Code point. Unicode name. Abbreviation. U+000. Line feed. LF. U+000D. Carriage return CR. U+2028. Line separator. LS. U+2029. Paragraph separator. PS. Only the Unicode code points in Table 37 are treated as line terminators. Other new line or line breaking Unicode code points are not treated as line terminators but are treated as white space if they meet the requirements listed in Table 36. The sequence CR, LF, is commonly used as a line terminator. It should be considered a single source character for the purpose of reporting line numbers. Syntax: line terminator, LF, CRLS, PS, line terminator sequence, LF, CR look ahead, LF, LS, PS, CRLF. 2.4 comments. Comments can be either single or multi-line. Multi-line comments cannot nest, because a single line comment can contain any Unicode code point except a line terminator code point, and because of the general rule that a token is always as long as possible, a single line comment always consists of all code points from the marker to the end of the line. However, the line terminator at the end of the line is not considered to be part of the single line comment. It is recognized separately by the lexical grammar and becomes part of the stream of input elements for the syntactic grammar. This point is very important because it implies that the presence or absence of single line comments does not affect the process of automatic semicolon insertion. See 12.10. Comments behave like white space and are discarded except that if a multi-line comment contains a line terminator code point, then the entire comment is considered to be a line terminator for purposes of parsing by the syntactic grammar. Syntax: comment, multi-line comment, single line comment. 20. ECMA International 2024. Multi-line comment charsopt, multi-line comment chars, multi-line not asterisk char, multi-line comment charsopt, post asterisk comment charsopt, post asterisk comment chars. Capital M, U,
I think this is it.
I, N, E, capital N, O.
I don't have like a bunch of different copies. I think this is like the original one.
S,
The other ones are like spread out through the program.
O, R, capital A, S, T, E, multi-line comment charsopt, post asterisk comment charsopt, multi-line not asterisk char, source character but not, capital M, U, L, T, I, capital
I think
A, R, D, capital S, L, A, S, H, capital O, R, S, T, E, source cap.
I think this part gets a value and it ors to itself when it's just right 1 to 460 times, and then it ands with itself shift to the right one but inverted to keep only the top bit because it ands it with itself before it's inverted, then shift to right one.
Sopt 2.6 token S syntax common token identifier name private identifier punctuator numeric literal string literal template
So if the number looks like this, whatever.
expression literal right brace punctuator and template substitution tail productions derive additional tokens that are not included in the common token production. ECMA International 2024 221 12.7 names and keywords. Identifier name and reserved word are tokens that are interpreted.
So it looks like this at first. Whatever argx is. Let's say argx. But I don't know if that's this. Then after all this,
The syntactic grammar defines identifier as an identifier name that is not a reserved word.
it ends up being set to this.
On character properties specified by the Unicode standard. The Unicode code points and the specified categories in the latest version of the Unicode standard must be treated as in those categories by all.
Except the highest bit isn't set. It's the highest bit, all the bits below it.
Find in later editions of the Unicode standard. Syntax. Private identifier.
So if you take the highest bit set, or you take the result, whatever, you just have to write 1.
Identifier start. Identifier start char. Unicode escapes.
Then this bottom bit gets shifted off. And then this 0 is shifted in from left.
Unicode ID continue.
And then it gets inverted. So you get
A, B, C, D, E, F, G, H, I,
I don't know if I typed that many times because it's laggy.
O,
So when you and this with this,
W, X, Y, Z, capital A, capital
after the not's been applied, whatever,
D, not but Gustav X's Unicode ID start. Any Unicode
then argx ends up being this.
start. Unicode ID continue. Any Unicode code point with the Unicode property ID continue. The definitions of the non-terminal Unicode escape.
So since all these bits are ended with 0,
1. This standard specifies specific code point additions. U plus 0024.
and these bits that start off are ended with 0 and 1,
Anywhere in an identifier name and the code point.
you get 0, 0, 1. Because only this bit is set in both operands.
Are permitted anywhere.
And then 0, 0, 0.
Name 22. Copyright sign.
So I think that's what this does here. This is on the internet. Some guy, I'll look it up in a second. I didn't come up with this part. This is like, I don't know.
A single Unicode code point equal to the identifier code point of the Unicode escape sequence. The preceding the Unicode escape sequence does not contribute any code points. A Unicode escape sequence cannot be used to contribute a code point to an identifier name that would otherwise be invalid. In other words,
We'll just save this, actually.
the result must still be a valid identifier name that has the exact same sequence of source character elements as the original identifier name. All interpretations of identifier name within this specification are based upon their actual code points regardless of whether or not an escape sequence was used to contribute any particular code point. 2 identifier names that are canonically equivalent according to the Unicode standard are not equal unless, after
So if argx is equal to this, after this routine here, you get this.
Unicode escape sequence. It is a syntax error if identifier code point of Unicode escape sequence is not some Unicode code.
And then enters this routine, which I don't think anybody else has done it this way. To count like this gets the highest bit set, it isolates it.
Fire part char lexical.
I already kind of showed the code, it doesn't matter. Nobody's gonna see this. I'll just explain it. I got other, whatever, things I figured out. Doesn't matter.
Fire code points of the derived ID. And the list concatenation.
So this is a result. After this up here. And once passed into here,
Find piecewise over the following productions. Identify a start.
the result will be the highest bit set, which is the highest bit pin position set,
Respect
which is 0.
with Unicode properties. Other ID start and other ID continue. ECMA International 2024 223. Identify a part. Identify a part char. Return the code point matched by identify a part char. Unicode escape sequence. hex 4 digits. Return the code point whose numeric value is the NV of hex 4 digits. Unicode escape sequence.
So this is bit 0, the position, bit 1, bit 2, 3, 4, 5, 6, 7, 8. So the result would be 9.
Is a token that matches identify name, but also has a syntactic use. That is, it appears literally in a fixed
It'd be 9 whatever after it does this.
words of ECMAScript
And then my routine here,
and many others.
it accounts for if no bits are set, it'll be 0.
Are not, and some are reserved only in certain contexts. If and while a reserved words or weight is reserved only inside async functions and modules, async is not reserved.
So the CPU has an instruction, and they have like whatever the intrinsic that Chatbot said for Visual Studio and Clang. You can't pass in 0 because it's undefined. I don't know, my routine, whatever, it accounts for 0. So if it's 0, I guess technically it doesn't. But it is defined. It's in bit 0. Which means that if you pass in 1, it's 0. I guess logically, that's probably why it's undefined. It should probably return 64 if no bits are set. Because 64-bit has 63 bits, so it's 0 to 63, but 64 is outside of the range of 0 to 63, and that'd be the easiest way to indicate that nothing's set, because if you're going to represent 0 to 63 bits as a result, there's only 0 to 63 bits, and if you're going to pass it in a single value, that's a 64-bit register or something large enough to hold the number 63. You need like another bit or some way to indicate that no bits are set. So that's probably why some implementations return 64 if it's 0. But then other people or implementations, they go like, oh, it's undefined. And then they don't change the number. Because if you don't change the number
Character elements. A code
when it's 0,
expressed by Unicode escape.
but if you keep garbage, it's the same. Okay, logically, it's not undefined. There's a reason. But everybody's going to use a different reason for passing or the value that's assigned when it's 0. Okay, it all kind of makes sense. But calling it undefined isn't true for Chatbot to say that. It's defined different depending on how they wanted to implement it, but it's never undefined.
Mode code. Note 3. The names, arguments, and eval are not keywords, but they are subject to some
So
1, 1, 8, 6, 4, 1, 5.
I'm gonna look up whatever this guy's technique is. And I did kind of come up with this idea from this idea, but not really. Because here the guy's he's folding the number to get to overlap. And if you shift right once, twice, 4, 8, 16 times. Wait, does it? I think it needs to be shifted more for 64-bit. It might, I think it has to be shifted up to half the size of the register. I don't know. I gotta check. He's folding the number.
Syntax. Null literal.
So he's combinationally merging the number columns, rows. I think columns. I'm so tired. Columns, rows, I don't know. I'm tired. Doesn't matter.
Numeric literal. Decimal literal. Decimal big integer. Literal non-decimal integer literal. Plus sep. Non-decimal integer literal. Plus sep. Begin literal suffix legacy octal integer literal. Decimal big integer literal. 0 big int literal suffix. Non-zero digit decimal digits. Plus sep oct begin literal suffix. Non-zero digit numeric literal separated decimal digits. Plus sep. Begin literal suffix. Non-decimal integer literal. Sep. Binary integer.
So he's shifting it right. 1, 2, 4, 8, 16.
N. Decimal literal. Decimal integer literal. Decimal digits. Plus sep opt exponent part. Plus sep opt. Decimal digits. Plus sep. Exponent part. Plus sep opt. Decimal integer literal exponent part. Plus sep opt. Decimal integer literal. 0 non-zero digit. Non-zero digit numeric literal separator opt decimal digits. Plus sep. Non-octal decimal integer literal. Decimal digits. Sep. Decimal digit. Decimal digits sep. Decimal digit. Plus sep. Decimal digits. Plus sep. Numeric literal.
This is decimal. This is decimal. This is binary.
6. ECMA International 2024. Non-zero digit. 1 of 120.
So that's 1, 2, 4, 16.
1789.
It's 2,
Sep.
4,
Indicator. 1 of EE.
8.
Sep. Decimal digits sep. Decimal digits sep. Decimal digits sep. Binary integer literal. Sep. 0b binary digits sep. 0b binary digits sep. Binary digits. Sep. Binary digit.
16. What's the point? Does it have to be signed?
Digit. 1 of 0 1. Octal integer literal. Sep. 0 octal digits sep. 0 octal digits sep. Octal digits.
It works with unsigned, so I don't know.
Octal digit. Plus sep. Octal digit.
There may be no point in the 16 if it's a 16-bit value.
Legacy octal integer literal octal digit. Non-octal decimal
I'll just keep it whatever.
octal digit. Capital L, E, G, A,
So OR's the result each time.
O, C, T, A, L,
Okay, basically whatever.
octal D, E, C, I, M, A,
It ends up being this, and then it does and stuff,
E, E,
and then turns into that. But I don't know, the logic behind it is to fold the number half the amount of times, so it gets applied halfway each time, filling in all the holes. All the holes.
E, capital D, E, C,
So it looks like this, whatever. And then you can shift it right one, invert it, and then invert, and then and it.
E, R,
So it cancels out all the ones set, except for the bit that's set that has been shifted right of the original value.
T, A, L,
So really, this doesn't actually relate to this logic, but somehow I'll just look up what this guy does. It's logic, basically. I don't know. in computers, they don't run off math. Math is the construct of logic, because you can't have math without logic. Because math is made up order of operations based off of predetermined operations that have a certain result. It's applied. I don't know, it's not worth explaining. It's logical though.
9, 3, 1 static semantics, early errors, numeric literal, legacy octal integer literal decimal integer literal, non-octal decimal integer literal. It is a syntax error if the source text matched by this production is strict mode code. Note in non-strict code, this syntax is legacy 2, 9, 3.
At some point, chatbot says, you like ask too many questions, so I'm like turning VPN on and off so we can ask more questions.
Decimal
I'm not gonna pay for this.
decimal digits 10n, where n is the number of code points in decimal digits, excluding all occurrences of numeric literal separator. The MV of decimal literal, decimal integer literal. Exponent part is the MV of decimal integer literal. 10e, where e is the MV of exponent part. The MV of decimal literal, decimal integer literal. Decimal digits exponent part is the MV of decimal integer literal plus the MV of decimal digits 10n, 10e, where n is the number of code points in decimal digits, excluding all occurrences of numeric literal separator, and e is the MV of exponent part. The MV of decimal literal. Decimal digits is the MV of decimal digits 10n, where n is the number of code points in decimal digits, excluding all occurrences of numeric literal separator. The MV of decimal literal. Decimal digits exponent part is the MV of decimal digits 10e, n, where n is the number of code points in decimal digits, excluding all occurrences of numeric literal separator, and e is the MV of exponent part. The MV of decimal literal, decimal integer literal exponent part is the MV of decimal integer literal 10e, where e is the MV of exponent part. The MV of decimal integer literal. 0 is 0. The MV of decimal integer literal, non-zero digit numeric literal separator op decimal digits is the MV of non-zero digit 10n plus the MV of decimal digits, where n is the number of code points in decimal digits, excluding all occurrences of numeric literal separator. The MV of decimal digits. Decimal digits decimal digit is the MV of decimal digits 10 plus the MV of decimal digit. The MV of decimal digits. Decimal digits numeric literal separator decimal digit is the MV of decimal digits 10 plus the MV of decimal digit. The MV of exponent part. Exponent indicator signed integer is the MV of signed integer. The MV of signed integer. Decimal digits is the negative of the MV of decimal digits. The MV of decimal digit. 0 or of hex digit. 0 or of octal digit. 0 or of 228. ECMA International 2024. Note, for example, 3 inches is an error and not the 2 input elements 3 and in legacy octal escape sequence. 0 or a binary digit. 0 is 0.
I don't know. I think there's a guy, chatbot says, Donald, whatever his name is, Knuth. I think someone was credited. I'll just let chatbot be chatbot and say that's right. Because this guy did a lot of stuff, whatever. It might be someone else though. It doesn't matter.
Decimal digit. 6 or of non-zero digit. The MV of decimal digit. 7 or of non-zero digit. The MV of decimal digit. 8 or of non-zero digit. The MV of decimal digit. 9 or of non-zero digit or of hex digit. 2 or of octal digit. 2 is 2. 3 or of hex digit. 3 or of octal digit. 3 is 3. 4 or of hex digit. 4 or of octal digit. 4 is 4. 5 or of hex digit. 5 or of octal digit. 5 is 5. 6 or of hex digit. 6 or of octal digit. 6 is 6. 7 or of hex digit. 7 or of octal digit. 7 is 7, 8 or of non-octal digit. 8 or of hex digit. 8 is or of non-octal digit. 9 or of hex digit. 9 is the MV of hex digit, or of hex digit. A is 10, the MV of hex digit. B or of hex digit. B is 11, the MV of hex digit. C or of hex digit. C is 12, the MV of hex digit. D or of hex digit. D is 13, the MV of hex digit. E or of hex digit. E is 14, the MV of hex digit. F or of hex digit. F is 15, the MV of binary digits. Binary digit is the MV of binary digits 2 plus the MV of binary digit. The MV of binary digits. Binary digits numeric literal separator binary digit is the MV of binary digits plus the MV of binary digit. The MV of octal digits. Octal digit is the MV of octal digits 8 plus the MV of octal digit. The MV of octal digits. Octal digits numeric literal separator octal digit is the MV of octal digits 8 plus the MV of octal digit. The MV of legacy octal integer literal. Legacy octal integer literal
I don't know. I have to check out. Just read this, whatever. So like this technique, whatever, gets the highest bit isolated because there may be other bits set. Out of all those bits, this bit is the highest one, and the rest are set to 0. So like this is to get the highest bit set, but to compute the position that it's the 9th bit, it doesn't, or the routine above, this doesn't compute that. This doesn't compute that. So that's what this computes, whatever. I'm gonna ask Chatbot if this is a technique, which it might exist. I don't know, I'm gonna read what Chatbot says. I never asked Chatbot. Chatbot wasn't around at the time I thought of this. So if it does exist, I guess someone else thought of it too. And it must not be that clever.
The technique you're referring to is commonly called finding the highest set bit or isolating the highest set bit. It works by progressively shifting the bits to the right, merging them back with OR operations, and then applying a mask to isolate the highest bit. Here's a breakdown of how it works. X equals X. 1. This ensures that each bit in X propagates to the left one position, filling in lower bits with the highest bit that is set. X equals X. 4. Propagating further, so that more positions get filled. X equals X and X. 1. After the shifts, this step isolates the highest set bit. It removes all bits to the right of the highest set bit and leaves only that bit. Purpose. This technique is used to find the highest bit that is set 1 in a number. The final value of X will have only the most significant bit set to 1, and all other bits will be 0. Example, let's say X equals 42, which in binary is 101,010. After the shifts and OR operations, X will become 111,111, binary, and then applying X equals X and X, 1, will isolate the highest set bit, leaving X equals 32. This technique is often used in bit manipulation algorithms, particularly in problems like finding the nearest power of 2 or efficiently calculating log base 2. Who invented the technique? The technique you referred to for isolating the highest set bit doesn't have a single inventor, but it is a well-known bit manipulation trick used by computer scientists and programmers. It has been widely used for several decades in various fields such as graphics, low-level system programming, and algorithms. While it is difficult to attribute this exact technique to one individual, Donald Knuth, a pioneer in the field of algorithms and computational theory, made significant contributions to bit manipulation techniques in his famous book series The Art of Computer Programming, 1968 onwards. However, the specific technique of finding the highest set bit likely evolved gradually as part of the general body of knowledge in computer science.
What does it mean evolved? Is there a better way to find it now? Shut about that.
Moreover, these types of bit manipulation tricks, which operate at the bit level on binary numbers, have been popularized in competitive programming and are commonly used in optimization problems. The technique is part of a larger set of tricks used for efficiently manipulating and analyzing binary numbers in short. This technique likely evolved through the collective work of computer scientists and engineers over time and doesn't have a single inventor but is a result of practical problem solving in the field of computer science. What page in the book by Donald Knuth is the technique you are talking about prior? What page is it on? The technique I described, known as bit scan reverse or finding the highest set bit, is not directly attributed to a specific page in Donald Knuth's The Art of Computer Programming, TOP.
I don't know. That's that bit scan, reverse instruction, whatever, on the CPU. So they must have implemented this at the CPU level. So it's probably faster to call that instruction. But that returns a position, not. It's a different value though. I'm gonna check the book really quick because I read parts of the book, but I didn't read the whole book. I don't know. And I'm gonna ask chatbot what modern technique is used or whatever. And I'm gonna see, I'll scroll up whatever and see if chatbot says like the technique I'm talking about is already in use or whatever. Or if it's not, because I don't know. I was assuming that, whatever.
What does this mean, however? The specific technique of finding the highest set bit likely evolved gradually as part of the general body of knowledge in computer science. By evolved, what mechanical operation other than bit operations could be used if it's a bit computation in and of itself? What kind of advanced knowledge is known in computing that was not known in what you are making sound live primitive times? When I mentioned that the technique of finding the highest set bit likely evolved gradually as part of the general body of knowledge in computer science, I was referring to how bit manipulation techniques, like isolating the highest set bit, were developed over time by many computer scientists and engineers, as new problems arose in computing and efficient algorithms were needed. The term evolved here doesn't refer to a biological or mechanical evolution in the sense of physical hardware or biological organisms. Instead, it means that the technique was refined, optimized, and made part of standard practices in computer science over time as people solved various problems related to bit manipulation. This knowledge gradually became available as part of the accumulated body of algorithmic techniques, which was passed on through papers, books, and research. What else could be used for bit computation? The process of finding the highest set bit is inherently a bitwise operation, and this type of computation can only be done using operations that directly manipulate the individual bits of a number. In modern computers, bitwise operations, and, or, XOR, NOT, are the most efficient and low-level ways to perform this task. No other kind of mechanical operation would be more appropriate for working with bits, because modern bits are the fundamental units of digital data. Any operation on them must be a bitwise operation, shifting, and, or, etc. Over time, compiler optimizations and hardware-specific intrinsics were developed. For example, modern processors often have special bit scan reverse, BSR instructions that directly return the position of the highest set bit without needing to manually propagate bits, making the operation much faster than it would be purely in software.
But behind the scenes, you know what? I'm not gonna argue with Chatbot. Page. Oh, I forgot to switch it. Dang it. Did I not switch it that whole time? Oh well. This even the full book. It only goes up to 2.6. This is chapter 4. Are there different volumes? I don't know. I don't know. I think the screen might have been like this whole time. I was just scrolling through chatbot, asking it, and read whatever answers and stuff. So I'm asking chatbot this because this technique, I guess I gave credit to David Knuth, even though like a bunch of people, whatever. This technique is known, or whatever. So I'm asking chatbot if this technique that I'm gonna show in a second is known or not. So that whole first part, I don't know, just asking it about that. And the chatbot said there's like more advanced ways. Tried to sound smart, so I don't know. And I asked it, and it said like basically the bit scan instructions were made so they do this operation here at CPU level with an instruction called bit scan. Which is in this table. It says right here, BSF and BSR. It takes a register and a register memory. I don't know, instruction timing, throughput, or UOPS, whatever you want to call it. So chatbot was referring to the fact that you can call BSR or BSF at hardware level, and you don't have to manually make code like this anymore. But in C programming, especially Visual Studio, they don't let you access this directly. Even though it's modern times and this is available, as a C programmer, you don't have direct, easy access to these modern features on the modern CPU. In C, you're stuck to doing this and then hoping the compiler will go, oh, you're doing a BSR. And if the compiler is smart enough, it'll replace this code. It'll replace this code with this single instruction, BSR. But not totally, because BSR returns the position of the bit that it's at, the highest one set. All this returns the value with the bit set, not the position it's at, just the bit in that position it's on. And then the CodeMS and chatbot, now if other people figured out, because I don't know, maybe other people figured this out. What mine does is extracts or extrapolates whatever the highest bit set when one of them set to create the number which is the position that the bit's at. So these two routines, this one and this one, are replaced by BSR. So basically, I don't know. What I want to test, it's taking way too long to get assembly running. I want to test if this here is faster when I write it in assembly than in C. When I type this in the C compiler, it's slow. It seems too slow. So when I type it in assembly, I want to see if it's any faster, or if the C compiler is doing a good job and actually is just slow. So that's why I want to speed test it. So now I'm going to ask chatbot if this technique that I'm going to describe right after now is already known or whatever. I have to get to parsing. So I don't know, I'll have chatbot read it again.
Is there a way to get the highest bit position that is set in a number, without a loop, that doesn't use div, but masking to get the column that the pin relates to and setting that to the result to compute the highest pin that is set? When all the bits below it are 0, that also does not use any addition. Yes, there is a method to find the position of the highest set bit in a number using bitwise operations, shifting, and masking, without using loops, division, or addition. This technique is often called bit scan reverse, BSR, or finding the highest bit set. The idea is to progressively propagate the set bits upwards using shifts and or operations. The result is a number where only the highest set bit remains, and all lower bits are 0.
Okay, so now it's explaining the first process of isolating this bit. And I think the only reason it's saying it is because I literally asked it about this prior. Otherwise, I don't think it'd be isolating the bit, but it is, so I don't know. So that's the first part, I guess, to chatbot's response. So that's like obviously a known technique. I already stated that. I'm talking about the second part here. I'm gonna explain in a second. You can't even see the whole thing goes to the right. Alright, so this is the second part.
To find the position, int x, of the highest set bit. To compute the position of the highest set bit, starting from 0, you can use a bit manipulation trick that involves the above method and then apply a bit scan to count the position. While this approach doesn't directly use loops, you would typically rely on a compiler intrinsic or assembler function, which would use the aforementioned bitwise operations. Rely on a compiler intrinsic or assembler function.
Yeah, because modern compilers are so great.
Unsigned int highest bit position equals 31, built-in CLZ, x.
That's it. That's what it's gonna say. It's not gonna tell me how it's done.
Built-in CLZ, x, counts the leading zeros of x, the number of zeros before the first 1 bit from the left, and subtracting it from 31 for a 32-bit integer gives the position of the highest set bit. It avoids loops, division, addition, or subtraction in the main process and is purely based on shifting and masking.
How do they know that? How do you know that? Just for calling an intrinsic function. How do you know it doesn't loop? You don't. You have no idea what it's doing. And it's not even explaining the process. It's just saying it exists. This is it. I want to know the process. So I can say, is my technique a known technique? Or did I find a technique that people haven't used yet? That's what I want to know. Wow, it didn't even explain it. Okay, so I guess it says that this is how it's done. And it's not going to explain the process, even though, whatever.
I have a bit fiddling trick to compute the highest bit set, its position when one bit is set. What are known techniques to do so via bit twiddling, not a single CPU inst? To compute the position of the highest set bit, that is, the index of the most significant one bit in a number, using bit twiddling, there are several well-known techniques that do not rely on a single CPU instruction like BSR or CLZ. These methods use bitwise operations and, or, XOR, and shifts to manipulate the bits directly.
Chatbot pisses me off. And then it shows this, right? And it shows the technique I already showed. It just takes things that I already told it and it restates them back. It doesn't do anything. But then I said, do not use built-in CPU instructions. And then they're like, look, this is how it's done. Fucking, I said don't use CPU instructions. I want this. I want to see the process. The logic behind it, not just call a fucking instruction. I don't know what this even is. Huh? Does it even work? Is it even like the same thing as getting the highest bit set? Does chatbot even know what it's doing? What the fuck? So I'm gonna ask it this, and I'm like, compute a value, see what the result is, whatever. So if you got if x is 7 or 8, or I'll do 7. So 7 and not 7, -7. Which is what? -6? yeah, -6, or what? Hold on. I don't know, I think it's -6, whatever. This is -7. This is 7. This is 2's complement, -7. So 7 and this. So do this and 7. Gives me 1. So I do 7, right shift 1. Because chatbot says this will work. 7, right shift 1. Oh. I'm clicking the wrong button. I was confused because it looked like it actually worked. Because 7, right shift 1. Did it work? And I'm like, oh wait, 7, I have to use the shift, and then pick 1, and then it's 3. So it's like 7, this is like a single shift. Itself, there's no number, so it's like shifting it. And then when, I don't know, I typed in 1, and it just overwrites the value. It didn't even, so it's not correct. 7, right shift 1 is 3. Wait, is that correct? This is 7, right shift 1 is 3, so 3 is, this is 0, 1, 2, 3. So this bit is off.
Two. Using De Bruijn sequences. This technique uses De Bruijn sequences to efficiently find the position of the highest set bit. De Bruijn sequences are precomputed bit patterns that can be used to accelerate the process. Here's the method using a De Bruijn sequence for a 32-bit number.
Is this code even valid? I think chatbot's broken. This isn't the full function. I guess they're gonna use X maybe in here. I don't know, this makes no sense, it's broken.
I said don't use any single CPU inst. I want to see the bit manipulation logic to evaluate if the technique I found has already been discovered.
This chatbot's example, it doesn't work. It doesn't make sense. It might, but its example it gave is broken. And I'm asking chatbot to show an example, like a real example.
I see. You're looking for a bitwise technique to compute the highest set bits position that doesn't rely on any single CPU instruction like BSR or CLZ. and purely uses bitwise operations. Let's go through some common bit twiddling techniques that compute the highest bits position. I'll give you a few examples of such techniques to help you evaluate if the method you've found is novel or already well known.
Chatbot is so fucking stupid.
That doesn't rely on any single CPU instruction like BSR or CLZ, and purely uses bitwise operations.
And this is technique 1.
Technique 1. Propagating the highest set bit. This technique is one of the most popular ways to compute the highest bit set using bitwise operations only.
And Chatbot uses the exact thing, the instruction I said not to use, right here.
Built-in CTZ. Count trailing zeros, position of the highest set bit.
And then right here, I said don't do it, and it's like, okay, I'm not going to use an instruction. It says it right here. And then it shows an example, the first example, and it uses literally what I told it not to do.
Sing-bit twiddling. There are several well-known techniques that do not rely on a single CPU instruction like BSR or CLZ.
And then the first example, it uses that fucking instruction right here. For fuck's sake.
Return built-in CTZ, X.
Like, Chatbot, it's not smart. It is no threat to humanity. Anyone that thinks that is true is a fucking idiot. Chatbot is a fad. It doesn't even do anything. Oh my god, and output the same thing. And it's still broken. It's not even, this isn't even valid code. It's an open array with a dot accessor. That's not going to build. And I said, don't use addition earlier. Or, you know what, whatever. Okay, so basically, my technique does this, but it unrolls it, and it doesn't need addition or branching, which is why it should be faster, or whatever. I'm gonna just explain my technique really quick. And then their example, it's just shifting a bit each time. That's stupid. And then down here, they do this. They use another fucking intrinsic instruction. Okay, so I don't know. Here's what Chatbot says. I'm gonna assume that my technique doesn't exist. If it does, then whatever, I guess it exists.
Evaluation of known techniques versus your method based on the methods above. Here are some key points. Techniques 1 and 2 are well known in bit manipulation. The method where bits are propagated and counted, Technique 1, is widely used and documented. Techniques involving shifting and masking, Technique 2, are common as well, especially in competitive programming. Technique 3 is another variation of propagating bits. The general idea of filling all bits left of the highest set bit is a classic trick.
It just mixed it up, how it worded it.
Possible novelty if your method involves a different sequence of bitwise operations or optimizations that combine the steps more efficiently, it may be a novel variation. But the core logic, propagating bits and finding the highest set bit, has been around in various forms.
No shit, that's what I was saying.
Common patterns in bit manipulation 1. Filling bits from the highest set bit using shifts. 2. Using masks to progressively narrow down the position of the highest set bit. 3. Optimizing counting by using hardware instructions which you've excluded from your query. If you have a unique sequence of operations or a more efficient variation, feel free to share it, and I'd be happy to help evaluate its novelty. Feel free to share it.
Yeah, feel free to give it to you for free. Stupid idiot. Chatbot sucks. So I'm gonna assume my technique doesn't exist. So it took way too long to figure out nothing except the same thing stated multiple times by chatbot. That's great. Okay, so now I'm gonna explain my technique. But first, I gotta get some more water. So I'm trying to be obnoxious because you shouldn't be watching my stream. You should be go living your life. Don't watch someone else live their life. I'm just documenting this because I don't know, whatever. I can't just it takes so long to explain and make a joke every time. I need to just get some water. So I don't know. I'll be RB. But go live your life. Don't waste time watching people stream. And don't forget to give the video a thumbs down. Any negativity, it just fuels my fire. I could use a little more fuel. So, thumbs down. Give it a click. I'll be RB. And I'll explain this right when I get back. For real, for real. I'll actually explain it. I literally need some water.
H-E-S-I-Z-E-D capital E, X, P, R, E, S, S, I, O, N, capital A, N. When object literal appears in a context where object assignment pattern is required, the following early error rules are not applied. In addition, they are not applied when initially parsing a capital C, O, V, E, R, capital P, A, R, E, N, T, H, E, S, I, Z, E, D, capital E, X, P, R, E, S, S, I, O, N, capital A, N, or capital C, O, V, E, R, capital C, A, L, L, capital E, X, P, R, E, S, S, I, O, N, capital A, N, D, capital A, S, Y, N, C, capital A, R, R. Property definition. Cover initialized name. It is a syntax error if any source text is matched by this production. Object literal. Property definition list. Property definition list. It is a syntax error if property name list of property definition list contains any duplicate entries for proto and at least two of those entries were obtained from productions of the form. Property definition. Property name. Assignment expression. This rule is not applied if this object literal is contained within a script that is being parsed for JSON parse. See step 4 of JSON parse. 3, 2, 5. To static semantics is computed property key. The syntax-directed operation is computed property key takes no arguments and returns a boolean. It is defined piecewise over the following productions. Property name, literal property name, return false, property name, computed property name, return true. Addition to describing an actual object initializer, the object literal productions are also 250. ECMA International 2024. Note 1. This production exists so that object literal can serve as a cover grammar for object assignment pattern. It cannot occur in an actual object initializer. Note 2. The list returned by property name list does not include property names defined using a computed property name. 1, 3, 2, 5, 3. Static semantics. Property name list. The syntax-directed operation property name list takes no arguments and returns a list of strings. It is defined piecewise over the following productions. Property definition list. Property definition. Let prop name be prop name of property definition. If prop name is empty, return a new empty list. Return prop name. Property definition list. Property definition list. Property definition. Let list be property name list of property definition list. Let prop name be prop name of property definition. If prop name is empty, return list. Return the list concatenation of list and prop name. 3, 2, 5, 4. Runtime semantics. Evaluation. Object literal. Return ordinary object create. Object prototype object literal. Property definition list. Property definition list. Let obj be ordinary object create. Object prototype perform. Property definition evaluation of property definition list with argument obj. Return obj. Literal property name. Identifier name. Return string value of identifier name. Literal property name. String literal 1. Return the SV of string literal. Literal property name. Numeric literal. Let NBR be the numeric value of numeric literal. Return. To string. NBR. Computed. Property name. Assignment expression. Let exp value be. Evaluation of assignment expression. Let prop name be. Get value. Exp value. Return. To property key. Prop name. 3, 2, 5. 5. Runtime semantics. Property definition evaluation. The syntax-directed operation property definition evaluation takes argument object, an object, and returns either a normal completion containing unused or an abrupt completion. It is defined piecewise over the following productions. Property definition list. Property definition list. Property definition. Perform. Property definition evaluation of property definition list with argument object. Perform. property definition evaluation of property definition with argument object return unused. ECMA International 2024 251 property definition assignment expression let exp value be evaluation of assignment expression let from value be get value exp value let excluded names be new empty list perform copy data properties object from value excluded names return unused property definition identifier reference let prop name be string value of identifier reference let exp value be evaluation of identifier reference let prop value be get value exp value assert object is an ordinary extensible object with no non-configurable properties perform create data property or throw object prop name prop value return unused property definition property name assignment expression let prop key be evaluation of property name if this property definition is contained within a script that is being evaluated for JSON parse. See step 7 of JSON parse. Then a let is proto set to be false, else if prop key is proto and is computed property key of property name is false. Then a let is proto set to be true, else a let is proto set to be false. If is anonymous function definition, assignment expression, is true and is proto setter is false, then a let prop value be named evaluation of assignment expression with argument prop key, else a let exp value ref be evaluation of assignment expression be let prop value be get value exp value ref if is proto setter is true. Then, if prop value is an object or prop value is null, then I perform object, prop value be return unused, assert. Object is an ordinary, extensible object with no non-configurable properties. Perform. Create data property or throw, object, prop key, prop value 0. Return unused. Property definition, method definition. Perform. Method definition evaluation of method definition with arguments object and true return unused 3 2 6 function defining expressions see 15.2 for primary expression function expression see 15.5 for primary expression generator expression see 15.7 for primary expression class expression see 15.8 for primary expression async function expression see 15.6 for primary expression, async generator expression, 52, copyright sign, ECMA int, Runational 2024, 132, 7 regular expression literals syntax, C12, 9, 5, 3, 2, 7, 1 static semantics, early errors, primary expression, regular expression literal, it is a syntax error if, capital I, S, capital V, A, L, I, D, capital R, E, G, U, L, A, R, capital E, X, P, R, E, S, S, I, O, N, capital L, I, T, E, R, A, regular expression literal, is false. 3, 2, 7, 2 static semantics, capital.
Alright, so like, break down how this works, whatever. So since math isn't real, well, it's real. It's based off, I don't know, just keep it in layman's terms. Okay, so basically, I take the fact that when one thing is true, I don't even, bleh, I need to drink the water. Now that I got water. My mouth is like sticking to the top of my mouth. Now my mouth is wet. You might hear like I don't know. Okay, now I think I could talk without extra sounds other than my voice. Okay, so basically, I take the fact that one thing being true means that other things are true, and it's not even assuming it's factual, it's logical. So, I have to like rewrite this anyways for assembly. This is unreadable. My allergies are killing me. If I take a Claritin, I'll be drowsy. I don't know. Anyways, I test as a number with this bit pattern. So 0xa It's hexadecimal, whatever, for 1010. And right here, I have 0x88888. So I'm testing for a short, which is 16 bits, but this can be applied, whatever, to bigger bit size, whatever. So I take the full 16-bit number, I cut it in half to look like this, whatever. So this is like 16 bits. I set the top half on, the bottom half off. It's 8 and 8 bits. So anything that's above 7 bits is true. Okay? I'm trying to explain this really simply. Don't overthink it. So, that's a fact. Because I think this is 17. Why am I doing 17? I mean 7, not 17. Okay, that should be 16. Any number, the bit. These bits here, 0 through 7. So bit 0 is here, bit 1, right? Facts, whatever. So bit 8 is here. The number 8, this is a hexadecimal, whatever. So I'm gonna type up 0 to 16 in hexadecimal. Well, I'm gonna type it in binary and then put hexadecimal to the left of it, whatever. I don't know, when I explain it, it makes sense or whatever. It's like really simple. This is 0, 1, 2, 3. Now I got 0, 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14, 15. I didn't click it fast enough. or it's laggy and the clicks didn't all register. So the hexadecimal value for 0, 0, I don't know, it goes 0 to 9, then A to F. Okay, so here's how simple my trick is. Anything above 7, this is a number 7 binary, depending on how you conform to binary. That is assuming that you start with 0 and then you set 1, and then every time you run out of permutations, whatever, you add another bit to the left of it or the right of it, depending on idenness, if it's big endian or little endian, and then you set another bit to indicate that it continues the pattern of setting the lowest bit to on, and so on. So if you're conforming to that as a mathematical accumulated result from the base of 0 in hexadecimal, however the heck you want to word it, assuming that is true. Okay, so I guess that's an assumption. The only assumption that exists is how the data is represented itself. But based on this representation data, as you can see, everything past 7 has the upper bit set on. These is 0, 1, 2, 3, 4, 5, 6, 7. The bit's off, so it's true that anything above 7 has this bit set. 0 or 8 to F, which is 9, 10, 11, 12, 13, 14, 15. So this is 15. And this is a 16-bit number that I'm showing this example. This trick, whatever you want to call it, can be expanded to whatever bit. It doesn't matter. It works for like 32-bit, 64-bit. So here's the trick. Since it's true that if any of these bits are set, it's possible to physically set a single bit to represent all of these numbers. The number range 8 to F can be represented by one big ass bit mask for test only these bits. Now, since that is true, based on logic, if I take this bit mask, logic, or whatever you want to call it, I'm just going to divide it by 2, because this whole thing runs off the fundamental, whatever you want to call it, rule that you go 0, 1, 0, 1, 0, 1. So I'm going to cut it in half, I'm going to cut it in half, I'm going to cut it in half. So this is the first time that it's cut in half. So now when I take this pattern, I cut it in half, I'm going to remove half of it. So I remove 4 bits on the left, or the right, and then 4 bits on the left, or the right, whatever, it's the same thing. And then you get this pattern. And then I apply that to bit 4, or bit 2. But then I take this number and I duplicate it, because this case is true for both cases. The upper half of 8 and the lower half of 8. If you cut 8, which is 4 and 4 bits, in half, you propagate dividing it, or whatever. So these bits, if these bits, or these bits specifically are set, then these bits will map directly to this bit. You see the pattern? No bits here, it's set here, and that's set here. So there's an overlap here, which also occurs here, here, but then not here, because here maps up to here. So you see the pattern. So I'll apply it again. So I'll take this, I'll remove 2 bits to cut in half on the right and left, and then it ends up with this. So I take this and I duplicate it, because it holds true. It's still true. It's always been true. Logically, it's true. So when I go to this bit, that's the first bit from the bottom bit, right here, whatever. So if this bit is set, which is right here, I'm like delete zeros, whatever. Alright, do you see the overlap? Only in this case are all 3 true. In this case, it's not true for bit 2 or bit 1 or whatever. Alright, I'm almost done. This is it. This is the last, whatever. So what's this? Before I duplicated it, now I'm gonna remove, cut it in half again, whatever, from the right and left. Now it's 1, 0. So I take 1, 0, and I duplicate it, because this fact is still true. You see how it toggles? 0, 1, 0, 1, 0, 1. That's right here. 0. So now, if it is true that a number is within this bit range, and this bit range, and this bit range, and this bit range, then it'll be 111, which is 15. So this first chunk here, if any of these bits are set, it maps always to to this bit. Okay, so these bits, if any are set, they always map to bit 3. And then these bits, any of these bits that are set as on, any of these bits, they always map directly to bit 2. And these bits, any of these set, they map directly to bit 1. And then any of these bits, if they're set, they map directly to bit 0. So I take whatever column that the number is in, and I map it, if it's set, directly to its bit position, and then I can OR the result. So I replace this ternary condition, whatever, with a branchless bit mask. I need some water. And I set, I don't know, I'll just simplify it. So if it's true, that the bits in this range are set, any of them, whatever, then I set bit 4 in the number. If it's true that any of these bits are set, I set bit 2. Any of these bits are set, I set bit 1. Any of these bits are set, I set bit 0. So, whatever argx is, after it's been broken down to a single bit being set of the whole number, it basically does this whatever. Since like it's 1 bit and it's true, it technically falls through this column, this column, this column, depending on the number that it is, the bit position, and that directly maps from the bit value to form the position that the bit's at. So like a little funnel, whatever. So like the number 1 drops layer 1, layer 2, layer 3, layer 4. So you can just OR the result. And there's no loops, there's no addition, there's no math. It's just broken down to logical columns. And then you can break this up. There would be no point in threading this, but it is faster. This technique works on addition, subtraction, I don't know, whatever. I don't know. There's some fancy things you can do with threading and stuff, but there's no point in threading something like this. But if you're threading a number to do a number computation, you're probably doing something wrong. But if you want to thread a very large number, you could section this off and isolate it and break it down to like completely different processors, whatever, or cores, threads, doing different parts of the number at once, and then form it all to a single value in the end without having to know the result of the neighboring operations. So I don't know. That's kind of what I was trying to figure out, is how to like break down math so it could be done simultaneously without having like to worry about carry and stuff, like the carry or whatever. Because when you do addition, there's like a carry, and if you break it up into separate units, a unit has to wait for the other unit to complete to pass down the carry, or you add up the carry at the very end. I don't know. That's kind of what I was trying to figure out, whatever. So this doesn't use a loop or addition. And it's basically just 4 operations, but not really. On an ARM processor, it might only be 4, because ARM has a result, a source, operand 1 and operand 2 has like 3. It has 3 opcodes for some of its instructions. So maybe this could, I don't remember ARM exactly. I don't know. On x86, it's going to break down to a couple instructions. So I'm going to like rewrite this and I'll test it. I won't speed test it till tomorrow. I'm going to try to parse the code or whatever, get something done. So like tomorrow I'll try to like speed test this or whatever, figure out what the fastest way is. Because when I pass this into the C compiler, and the C compiler has to be typed up like this or whatever, and it seems like the code that it produces is very slow. I want to see if I can optimize it in assembly using the same technique to see if it's faster than what the compiler generates. But it might be the same speed, so I don't know until I try it. Because this could be broken up to account for pipelining and stuff, and remove register dependencies. I'm just gonna like write up first and then I'll run it and build the executable, just make the result And I'm done with assembly for now. I don't even need assembly until I like meet the standard, then I might dig into assembly. Because, I don't know. I'm gonna write a faster engine. Because the current JavaScript implementation sucks. I gotta burp. Oh, my stomach is so gassy. It's hard to talk. Anyways, that's my like trick or whatever. I don't know if anybody else figured that out. So assuming no one else did, I don't know, possibly the first, if it even matters. I thought it was pretty clever. But it doesn't matter in the end. Nothing matters. Okay, so and there's no reason for the mask. I could subtract, get the sign bit, shift it to the right, and then shift the sign bit to the position 8, 4, 2, or 1. Or like the position 0, 1, 2, 3. But that ended up being much slower in C. So like the mask was faster, whatever. So when I write in assembly, maybe the shift will be faster, but it might not be, because masking is generally faster. But then that depends on the CPU. So I'm gonna make a copy of all this stuff. And then I'll keep this. So I'm gonna like try to write this up really quick. But if nobody else planned, or not planned, if nobody else claimed that technique for counting bits, whatever, I claim it officially. Well, I claimed it a couple months ago. I have a video So if anybody else claimed it, I made that video private. I made a bunch of videos private. Whatever, it doesn't matter. I don't want to like foreshadow things that are gonna happen. Anyways, I made a video a couple months ago, so if anybody claims that they did have this idea, if this is my actually my idea first, I did claim it technically a couple months ago. So if this is an original idea to count the bits, I claim it. But I already claimed it though, technically, a couple months ago. I could pull up the video as proof. So I don't know, whatever. It's mine. As long as nobody took it. Which I don't think they did, because I kind of looked. I couldn't find anywhere. So I'm gonna like listen to music. I paused music. I feel like I'm dying. I need to listen to something. I'm gonna try to like compute this. I'm gonna run the assembler, make sure it works, whatever. And I'm gonna get back to parsing. And tomorrow, I'll get a stopwatch, whatever, and like speed test this assembly versus compiler. And then I don't know, my JavaScript engine, this could be a lot faster. A lot faster. I would write the whole thing assembly, but I'm not giving away that much. It wouldn't be worth it. People would just steal everything. So I'll just write chunks in assembly. I've got other things, whatever. I don't know, the stream's at 8 hours and 30 minutes. So I have plenty of time. I don't know. So I'm gonna like write this up in assembly. It's not gonna be optimal. I haven't programmed in assembly in forever. And I haven't really programmed in 64-bit assembly. Because I was like, this stuff is shit. Because it is. So now I'm gonna be programming in this shit, I guess. I just gotta get to the standard here so I can get this engine done. Doing this assembly doesn't hurt because I'd have to do it anyways. So at least now I'm getting my feet wet and I'll be like more ready for when I actually get to the standard. I still have to finish parsing the program. So I'm gonna do that right after I get something running in assembly. So this isn't gonna be optimal. So judge away this code that I'm gonna write in assembly. It's probably gonna suck. I just wanna make sure, I don't know. I just wanna write something that works. And then I'm gonna get to a present program. So I'm gonna stop talking. I'm actually gonna listen to music. My ear, it's been so silent. I'm gonna die. I can't take the silence. Sweet, sweet music to my ears. I don't know why the sound software keeps failing. It's supposed to, whatever. It's supposed to be reading the PDF for the standard, but this software keeps dying. Anyways, chatbot is pointless.
How do I get the compiler to make the single SHR operation, not use the CX reg?
I don't remember if shift right even uses the CX register. I think that was only rotate. I don't know, whatever. So like I asked it the wrong question, start with whatever. But this is what it says.
In x86-64 assembly, when using the SHR shift right instruction, there are two common ways to specify the shift count.
But then it says this.
When you use SHRRBX with no immediate specified, the instruction defaults to using the CL register for the shift count.
And that says like, what? Huh? And I wasted my time Googling it. And someone says,
Skip to main content stack. Capital O, V, E, R, F. Skip to main content stack. Capital O. Skip to main content.
oh my god, it's not reading it.
V. The single operand version of SHR is using an implied immediate of 1 SHR %EDX shift CDX 1 bit to the right.
So chatbot says this.
Conclusion. To make sure the SHR operation uses the immediate operand and doesn't involve the CX register, simply use the form SHRRBX 2, or whatever immediate value you need. This will generate the most efficient machine code for shifting by a constant value.
Oh, it's so icky. We describes it. And then I asked this.
You can use the SHR Is there a SHRY not code? Act D. Is there a SHRY not code? No, there is no specific SHR1 opcode that directly performs a shift of 1 bit to the right in x86 assembly. SHRRBX 1. Shift RBX to the right by 1 bit.
I don't know. Chatbot says everything wrong. And then I said, the internet says blah blah blah. I paste what the guy said. And then chatbot says,
You're right, and I apologize for the confusion earlier. In x86 assembly, the single operand version of SHR indeed uses an implied immediate of 1 when no immediate value is specified.
So chatbot is wrong on 90% of what it says. I need to go to the internet more often because chatbot's not right. Anyways, I think this will do this. This probably won't be faster, but I'm setting AX, BX, shifting AX, moving to CX, shifting BX, moving to DX, shifting CX, or AX, BX, shift right, DX, or BX, DX, or AX, BX, move CX, AX, and then I shift right, AX, and I XOR AX with CX. So I staggered all the instructions. So technically speaking, the CPU should be able to register reorder or reorder the instructions, whatever, and do the move, for AX, BX, CX, DX, all independently. And then I can shift right AX1 and move to C. Okay, whatever. So like I staggered all the registers. Hypothetically, this should be faster, but probably not. Because hypothetically, even though the CPU register reorders, it's not always going to like do exactly what you think it needs or it does. It might be better to unroll this twice, but I unrolled it 4 times. So I don't know. Assuming whatever, this should work. It might not be faster. It breaks it down to operations that can be executed independently. And down here, whatever, it moves to CXAX. And it shifts right AX. I don't know. Maybe this should be CXAX. But if I do that, it already moved to the register before. And then there's like RAX, or not RAX. There's a special encoding for the AX register where it takes like a byte less. I don't know if that was for 16-bit or 32-bit. I don't know. It doesn't matter. I gotta like look up the instruction table. This probably isn't gonna be optimized. But it's a thought that counts. And because I gotta get the extra programming. So this probably isn't gonna be optimal. But when I run it, I can see like how close it is, and then I'll actually have to optimize it. Unless this runs faster than the compiler right off the bat, which it might not, but it might. I don't know until I run it. I'll check what the compiler. Let's check now. I have to get to parsing. This is more fun, the parsing. So I'm going to type up whatever this is. Maybe I don't have to type it up. Yeah, chatbot sucks. Oh, it is a short. So this is what the compiler generates, the C compiler. So pushes the stack, pass in the arg. Alright, so C compiler uses the stack to hold the result it's using the X register. So it's probably going to get the AX encoding or whatever. I gotta turn on optimization though. Okay, this is a Microsoft compiler. It's already optimizing better than GCC. Which I don't know. That's why it took so much longer to generate. So Microsoft Visual Studio is slightly better, but it might not be. Depends. So Visual Studio sets it to EAX, shifts it right 1, moves result. Okay, so Microsoft, the Microsoft compiler, whatever, it only unrolls it twice. So me unrolling it 4 times might be slower, but look at the amount of code generated unrolled twice. There's like 37 instructions. Or like 30. Okay, now the compiler optimized it down to, what's 22 minus 6? So it's like 16 instructions. And I have 14 instructions. Oh wait, it might be the same count. I accidentally left the shift rate 16. So now it's 14 instructions. I got 14 instructions. So, which one's faster? Visual Studio and its 14 instructions. 1, 2, 3, 4, 6, 7, 8, 9, 10, 13. Oh, it's 13. Oh, wait, it's 13. Well, mine could be 13 too. If I just. No, it's still 14. I don't know, look at it later. Okay, so Visual Studio might be faster. In this case, I haven't actually optimized yet. This is my first attempt. It probably will be slower. Maybe not. I need to get to parsing. Okay, so that's this part. So I gotta write this part. I'll write this up and then I'll paste the C code to here and see what the result is. See what Visual Studio comes up with. And then I actually should get parsing. I still need to get like a stopwatch to actually time this, like speed test it. At least I can run it and see the output, at least for now. I'll do like the stopwatch to time it tomorrow. So I don't know. I'll make it this part. Okay, I just spent too long. I don't know. I have to like figure stuff out. So this technically has a dependency on the carrier flag, but I think it's pretty fancy, so it might not be faster. I don't know, I'm gonna see what the compiler makes on Godbolt or whatever it's called. Well, I don't know. Here's what I do first. So, since all these masks, the bottom bit is ignored. I'm pretty sure the bottom bit is ignored. I do a shift right on the AX register 1 to make sure the sign bit will be off. Then I move to CX. The mask that's going to be set to mask the bits. And that mask is going to give the upper 2 bytes. I could do like XOR AL. But like using the high and low register, that usually destroys performance. The carry flag, I don't know, I don't know until I run it. I don't remember everything. So instead of like clearing out the bottom of the register, well, now it's like shift to right 1. Okay, whatever. This isn't actually optimized. I kind of attempted to optimize. And then I move to DX, AX, BX, the mask, or bit 2, or the second bit. The second bit position. I move CX, AX, and then I AND DX with the mask here, but it's shifted right 1 to account for the shifted 1 up here. And then negate CX, rotate, carry left, source index. And that's assuming source index was set to 0, which it was at the top of this. I set them all to 0. All the registers, whatever. And it's probably faster to use the full 64-bit register in x86-64. This isn't really optimized. I don't know, I still have to get the hang of it. This is only like 16-bit, whatever. So, and then I AND BXAX. Because I set BX to the mask prior and negate DX to test if any bits were set or not. Chatbot said negate sets carry flag and rotate carry left. Carry is in the name, so I'm pretty sure it's a carry flag. I don't remember totally, so assuming that's correct, it will negate DX, rotate carry left SI, so SI is equal to CX here, when it negates CX, only if overflow occurs, when it's not 0, when the mask keeps the value, which means any pins are set in this bit range of the value, will the carry flag be set. And when the carry flag is set, rotate carry left will set SI, which is 0, to 1, because there's nothing else in the value. Rotate carry left. Does it even rotate if the carry's left? I don't know. The register's, I don't remember. The register's 0, so I'm going to assume it's going to carry a 1 in at the bottom, but that's not even a rotate instruction, technically, right? I can't remember. This is close enough. Assuming it does what I think it does, what chatbot said, because I asked chatbot, chatbot's probably wrong. Going off memory, I don't know, whatever. So that sets this bit at the bottom. Then I negate DX and I rotate carry left SI again. So now whatever SI was here, whatever value it was, is being rotated left again. So when it rotates left, this bit gets removed. It's rotating left, the value, and it's carrying to the left, the value. So if negate DX, set the carry flag, it sets a 1. Okay, so that means this is like 8 bits, whatever. So then does this. And when I do rotate, carry left again, if I negate BX, then this bit gets destroyed because it's rotated. I'm carrying in the carry bit. Sets this bit if it was negated. Otherwise, it'll carry in 0. Which means that this could be 1 or 0. And this one could be 1, 0, 1, 1, or 0, 1, 0, 0. And I do that again. Negate AX this time. And I rotate left, rotate carry left, SI, which means gets rid of this bit. Only if this negation set the carry flag will be set. Which means now there's 4 bits set here. And when I mask for FF, this value, the top bits, here in my diagram, whatever, this has to go to bit 3. Right? So when it does rotate, carry left, it sets it to bit 0. And it gets carried left 1, 2, 3 times after it's been set. So after it's been set here, 1, 2, 3, it carries in 1, 2, 3. So whatever the other 3 bits are, they get set. 1, 2, 3. So now the result, even though it was carried in first, it was at the bottom. At the end here, after it does the 4 rotates, it was right here. But it goes rotate, carry, rotate, carry, rotate, carry. And then the carry bit is ta-da! In the 3rd bit position. I kind of spent, I don't know, I shouldn't have spent this long. I gotta get to parsing. Okay, so it moves to CX, then it moves to DX, then to BX, then to CX, then to DX. It negates CX, rotates carry left, source index. So you see on the left hand whatever A, C, D, B, C, D, C, S, I, B, D, S, I, A, B, S, I, D. Could this be put up here? This might be better. No, it's not. This might be better place it. I can't do that. Does and set the carry flag? I gotta check chatbot. I shouldn't optimize for one instruction, but possibly this goes here. The compiler might, or the CPU, see on the left hand side, I don't know, I just went through CDB, whatever. They don't duplicate one after another. There's like register at least between, which means that if it's out of order, it can begin processing the next one in the pipeline before the operation finishes. So if I put negate BX before the and AX, the CPU might have easier time of grabbing more instructions, but it might not. So I'll just leave it underneath, because after the negation, I don't remember if and sets the carry flag or not. I don't know. Each instruction has different rules. But if I put the negate, then directly under it, I rotate. As far as I remember, that works. Or it should. Okay, so this does this. Okay, so this does this C code right here. So I'm going to type into the Godbolt compiler, whatever. I'm going to type in this. And I want to see if Visual Studio outputs code that looks like this, or what Visual Studio outputs. I don't have time to like get a stopwatch working. It's gonna take too long, so I'll do that tomorrow. But I can at least run this. Maybe it'll work. I don't remember if SI can be used in a rotate carry left, because that's the index register. And there's like different rules, but then apparently 64-bit you can do a SIL, which is the source index register, the low 8 bits, and then I don't know, they added this because this isn't in the old 32-bit, so maybe, I don't know, this is kind of cool because there's a low bit, a low byte, a high byte, 32-bit, 16-bit, and 64-bit, and they have encodings, whatever, to access all of them as low, high, 16, 32, or 64. And then they even added to the index registers, the low, even though it like breaks the old school 32-bit. Does it break the old school? Maybe it used to support that. I didn't think it did. I didn't know that. I wish I knew that. Unless chatbot's lying. So I don't know. SIH isn't a thing. See, chatbot is the stupidest fucking thing. I'm not gonna ask. Why am I asking chatbot, for fuck's sake? Right here, they have SIL and SI. They might have had SIL, but there is no S high. Like ABCD, you can get the high 8 bits, but they don't have that for the rest of the registers. Well, this came from chatbot too. This is probably wrong. Why am I asking chatbot? Fuck. Chatbot is stupid. You know what? I need to stop using chatbot. It's making me dumber. It's literally making me dumber. I need to just Google it. Google stuff from now on. So I'm gonna type this in to the compiler and see what the compiler makes. I like undo. I don't know if it like messed something up. But the way things were ordered or whatever. Dang it. Somehow it scrolled this window. It could have like moved folders around. Okay, anyways. The order that it's in, whatever. I do CX this mask, then BX this mask. I don't know. Everything's ordered perfectly. They can do the rotates after every other instruction, so it sets a mask to the 8, the third pin, then the second pin, then the fourth pin. But even though it does 8, third pin, second pin, fourth pin, so like it should be like 4-2 if you want to be like in order, whatever. But laying it out this way means I can like rotate, carry left. I don't know. It like works perfectly. I don't know how fast it'll be though. But it should work, so I'll try to run in a minute. I want to see what Visual Studio outputs in C language. So this is how many instructions. It's only 16 instructions. This one was 14. I think Visual Studio had 13 instructions. This is 15 or 16. I don't know, 16, I guess. At the end of this, whatever SI has the result. I think there would be a way to, like, since AX register or CX, I think it would technically be possible to optimize this. This one uses only these bits. But whatever. There's like 4 bits empty at the bottom. So it might be possible to shift to right 4 bits, 4 more bits, and then negate it, and then shift to left in 4 bits, and then mask to keep only those 4 bits. But that would take a couple more instructions. And then, I don't know, there's a ton of different ways to optimize it, but it's not optimizing unless I get out the instruction tables and I check the timings and all that stuff. So I'm not doing that, so I'm not going to. I'm gonna just check chatbot and stop thinking about optimizing. Not chatbot, I mean Gotbolt, the compiler thing. See what Visual Studio makes. So if Visual Studio does this in less than 16 instructions, it's probably going to be faster. Because usually the instruction count, even though the timings or whatever, it tends to come down to less instructions are faster. Unless it's like a really slow instruction, like divide or whatever. I want to type this in. I'll just type it in. And the mask was faster of the results, whatever. So I don't know, this is like guaranteed whatever Visual Studio compiled is fastest. So this is like a fair comparison. But it's not really fair because I didn't really optimize this. And I don't remember everything. I have to like figure it out again. I just gotta type this up over here. I hate when they add the freaking part. I hate when they like modify it as you're typing. Like I just want to type it. I don't want it to put the closing parentheses and stuff. It's so annoying. finally, testing. Now I can finally paste this in, whatever. And the compiler makes this. Alright, the carry flags are probably slower because the compiler is shifting right 31 just to keep the bottom bit. And they do all the negations in a row. This might be slower though, because the pipeline can only do so many negations at a time. I think mine might be faster. So assuming that the carry flag whatever isn't that large of a carry dependency whatever between instructions, this might be faster. Because I can do a shift, a move, an and. Because I can do 4 data operations at least at a time, generally. The CPU, whatever. So we got C, D, B, but these are immediates, so I don't think they count as a data operation. I think that's like when it points to somewhere else. So this is an immediate, so I don't know. I think it's whatever. And I could also load up the full register to fit the 16-bit and the 16-bit and do 2 operations at the same time. There's like a ton of ways to optimize it. I don't know. Assuming this is optimized, it might not be. I was just going for smaller code. But this one does an and, a negate, rotate carry, and negate, rotate carry. Now if that's like, and it can do it on a DX register, then CX, then source index, so they're not dependent on each other. They're all independent, so the CPU can fetch this instruction, execute it as it's doing this one. Technically speaking, it's not really as it's doing it, but that's the technicality. In context, I guess, whatever the context is. Assuming so, it is fetch, and it can do these on different ports because rotate, but it can't do this one because it depends on the result of this one for the carry flag. So this will cause a stall. So like if it does this instruction, it does this one, and it's like, oh, I can't do this one until this completes. Then the CPU can go, oh, but I can do and bxax. And then by the time it does that, if the and is done from dx, it can negate it. And whenever this does complete, the negate cx, rotate carry left, si, si, when that does complete, then this carry instruction can continue. So this might need to be split up to like do si, si, and di, di. Or something. I don't know, it doesn't matter. When I do the speed test, whatever, I'll try to optimize it. Unless this is faster. If it's faster, like right off the bat, I'm not going to bother to optimize it. So I think this is more out of order or whatever. So this was 16 instructions. And the instructions and the registers are out of order. The Visual Studio compiler makes this. So it's a negate, a negate, a negate. And then there's 4 of them. So if it can handle 4 negations in the pipeline, in the ports, then they can all be done at the same time. But if not, it might do 2 of them and have to wait and then do 2 more negations. But then it's able to go down, do a shift and an and, depending on if these negations completed. So I don't know. I'm going to count up the instructions. I'll just subtract to get however many. That's 26 instructions. (26 minus 16) is 10 instructions. So this, I think, is very poor. Let's see what GCC outputs. Is trunk the slow one? looks like cling came down to 16 instructions, which is great. Look at my code, whatever. That's 16 instructions. Whatever. And then clang output 16 too. And then Visual Studio, Microsoft Visual Studio, the crappy compiler. It might be faster. I don't know. I'll test it. Visual Studio though, it did 26 instructions. It's almost twice as many instructions as Clang at high optimization and whatever I have, which makes me think that it was right in thinking or assuming that Visual Studio makes suboptimal code for this. So this might be faster than a division by a magic number to get the highest bit position set. But I don't know till I test it, but I think it might be, because I got it to 16 instructions. And so did GCC. So I'm gonna look at, I don't know, GCC. And then the streams had like 11 hours. $11 hours and 20 minutes. Alright, I'm gonna go like 30 minutes. And then I gotta end the stream. I'm gonna try to catch up on sleep, so I won't do another one. So I guess I'm not going to, I'll just end the stream early. I don't know. I'm just gonna like look at whatever GCC output. There's no way I can get the time to actually speed test in 29 minutes. It's gonna take forever. Because when I ask chatbot, it's not gonna work. I'm gonna ask it again. I have to Google it. It's gonna take a while, so I'm not gonna bother right now. So tomorrow though, I'll speed test whatever. And if it's factual that I can get code, or write code that's faster than Visual Studio, whatever, and I write like parts of the engine, the JavaScript engine that need to be optimal. It's gonna be really fast. Really fucking fast. I still gotta write in ARM assembly too. So that's another thing. Dang it. So I don't know, I gotta get the Raspberry Pi running to run some ARM assembly on it. I could just emulate it. It's not the same. Why is it? Huh. Why are they zeroing out EAX and then assigning EAX to RAX times 8 when it's 0? Shouldn't it just be 0? Or even that? The type is set, not equal. That not equal. It sets a flag. If the 0 flag set, it sets a byte to 1. I think I tried using that before. I didn't like it. I didn't like it. So I don't know. So they set, see all the 1 or 0. Okay, never mind. The AX register, it is set. They're setting it here to 1 or 0, depending on this test. And then they zero out ECX. And they test, and then they're using the result of 0, 1 set to AX, or whatever they register. Right here to load into EAX, RCX plus 8. So they're getting the byte that's after whatever. Okay, whatever. No, they're using this instead of a head. So instead of a head, they're using LEA because that's the ports or whatever. Because the instruction uses the arithmetic logic, the ALU. So that way they skip ahead instruction. The XOR, the test, the not equal, those probably don't use the ALU. Not the shift, but the lead does. So they're getting, I don't know. And they're playing the same technique. XOR test, set, shift left, the XOR test. Set not equal, the XOR test. So they're not actually loading an address, they're just computing it with Lee, so they don't have to use an addition. For the ports or whatever, to like saturate the data ports. No, not the pipeline ports, whatever you want to call it. Visual Studio, so this actually looks optimized. Instead, what I'm doing, I don't know, I literally just reordered the instructions where I think they might be picked up better or whatever. I don't know till I run it. And then negate in the rotate carry doesn't have a dependency. So speed-wise, I don't know till I run it, but GCC might be faster. I'll look at instruction times in a second. I'm just gonna stall till the end of the stream and over-explain everything. Because I want to look at it anyways, I don't know. I gotta like figure this stuff out again. So Visual Studio is doing a move, and an and. It's just bleh. It's doing a move, EAX. And then does an and right after it. I don't know what Visual Studio is doing. This doesn't look very optimal. And then Visual Studio is using the E 32-bit mixed up with the 64-bit. Usually they complain, they're like, always use 64-bit. So it might be optimized. Visual Studio is doing a combination, or I don't know, it's doing kind of what I did, but it's just setting the bit to the bottom, and it's not doing the carry flag. And down at the bottom, it's just like, it like crudely just ORs it all together. So I don't know. I think this is gonna like stall the ports because it can only do so many instructions at once. So I'm gonna look at the instruction timing. So set not equal. I'm just gonna look up whatever this computer is. First gen i7 for timings. Every CPU is different, but they're somewhat similar, but they're not. It all depends. This computer's a first gen potato, and I've had good luck optimizing on a first gen potato before. It tends to apply to second, third, fourth, 10th gen potatoes. So whatever the current Intel i7, whatever it is, this potato computer, it should apply pretty well to whatever the modern potato is, because this is the first gen potato, and the rest of them are just potatoes made off this potato, like from the eyes of the spud, because spuds have eyes and then they spud or whatever. So I'm looking for a set not equal. I guess it goes by different name, or just like a brand new instruction. Dang it, how's it on this table? This might be it. I think it's set. The condition code, that might be what CC means. It's like not equal is a condition code. And then not equal is 2 letters, so it's probably why it's CC. Because that's also 2 letters. So I don't know, it's like 1, 1, 1, 1. Is this expensive? I'm using rotate carry left instead. So rotate carry left is holy crap, is that expensive? Oh, it's not that bad. I was gonna say, what the hell? Okay, so rotate carry left. Register 1, which means 1 bit carry. We're looking at 2, 2, 2, 2. And then set. It's just register. Memory. It's all ones. And then this test is register in memory or immediate. Holy crap, that's fast. I'm using negates. Where's negate? This is why they're using Lee instead of add, because it's faster. Man, using Control F, the PDF file sucks ass. Freaking doesn't stay where you are. Like, scroll back to the freaking page. Where the heck is negate? Man, this is so annoying. It says it right here, but I can't find it when I do Control F. Man, this stupid shit. This PDF file viewer sucks. Okay, so negate is 0.33, which might actually be faster because I have a negate, then rotate, carry left 1 bit. So even though this is 2, this is 0.33. I think it was throughput, whatever it was. So it can do like 0.30%, 30%, 30%. It could do like 3 at a time, which means it could do this negation and this negation and this negation at the same time. But it can't do this one until this completes. But it could do this one, this one, and this one. So it could do 3 negations. I think. Right? I don't know. At least 2 negations. As it waits for the carry, whatever. So even though this carry takes 2, because a test, I think it was 1, 1, 1, 1. Okay, maybe not. The test is 111. It's also 0.33. Okay, so this may be faster. I don't know until I run it. And I'll do that tomorrow. But this is an absolute turd. Visual Studio, I don't know why. Some code, it just doesn't make good code. I think it's on purpose sometimes. It seems intentional because sometimes it's so bad. The code that Visual Studio makes, it's like, how could this be so poorly? I don't know. It does seem intentional sometimes. So, my code might be slower. I might have to optimize it. But I don't know until I run it. Alright, I think I'm done for now. I didn't get anything, or I don't know, I didn't get any parsing done. So I gotta like, I think I was doing the bit shifts, whatever. So tomorrow, I'm gonna get a speed test. To speed test this code, whatever. To see if this is faster. Or Visual Studio or GCC. GCC might be faster. It probably is. So I'm done for now. Oh, and I got a whole bunch of stuff to think about now. So I'll get a timer, a stopwatch. I'll time all this stuff tomorrow. I can't waste hours doing that. So I'll do like maybe 2 hours of that. And then I'll spend the rest of the day 10 hours of the stream. Finding, replacing, and getting the bit shifts updated to 64-bit. And once the program whatever is in 64-bit, and I can go through the ECMA standard, whatever, get the JavaScript engine to meet the standard first. Then I'll have it meet the 2024 standard. After I meet the standard, I'm gonna have to put in some assembly. I already started figuring that stuff out here. That's what I'm doing today. So I have to get to that point so I can actually do that. So I can actually like get assembly and stuff set up. So I don't know. That's the plan. I need to get this stuff done. Alright, so it's like the end of the stream for now, I guess. I'm gonna let the stream run on for 10 more minutes because it doesn't always end the whole stream. So this end of the stream, it's gonna run on for 10 more minutes. Peace.
correctly, but not crossing function or static initialization block boundaries within an iteration statement 148 to runtime semantics, evaluation, continue statement, continue, return completion record, continue, empty, empty, continue statement, continue label identifier, let label be the string value of label identifier, return completion record, continue, empty, label 4.9 the break statement syntax, break statement, yield, await, break, break, no line terminator here, label identifier yield await, 149,